Hello everyone and welcome to this video on the Business Intelligence full course by Edureka. Business intelligence involves collecting, analyzing and presenting data to help organizations make informed decisions. It uses tools and techniques to transform raw data into actionable insights including data warehousing, data mining and reporting. BI provides a comprehensive view of business performance through dashboards and visualizations, enabling companies to identify trends, optimize process, and improve decision making. Its ultimate goal is to support better strategic planning and operational efficiency, giving business a competitive edge. With that said, now let's outline today's agenda for this Business Intelligence full course. We will begin with an introduction to what business intelligence is. Then, we will discuss how to become a BI analyst, highlighting the essential skills required for this role. We then dive into data warehousing, discussing its significance in BI and covering core data warehouse concepts. Following this foundational knowledge, the course introduces Excel as a key tool for data analysis, starting from basic tutorial for beginners and advanced to essential formulas, functions, and advanced techniques including VLOOKUP and pivot tables. The course then focuses on Power BI, a popular BI tool, where we will start with a beginner's tutorial and progress to building interactive dashboards using Power Query and creating data visualizations. This segment also explores the differences and similarities between Power BI and MSBI. Additionally, we will introduce Tableau, another leading BI tool, exploring introduction to Tableau to more advanced topics like Tableau Server and Tableau Online. Additionally, this full course includes a comprehensive analysis of Tableau versus QlikView, providing insights into selecting the right tool for specific needs. We will also explore a variety of top BI tools, giving an overview of the most widely used solutions in the industry. The course concludes with preparation for the job market, offering resources on data warehouse and BI analyst interview questions and answers, ensuring that learners are well equipped to enter the field confidently. But before we begin, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, visit the Edureka website for Business Analyst Master's course, the link to which is in the description below. Now, without much further ado, let's get started with our first topic: what is business intelligence?
So we'll understand why business intelligence and data warehousing are among the fundamental and the foundation for any company's success. So why do we have to go for business intelligence, right? Business intelligence is the activity which contributes to the growth of any company. And there are also so many MNCs which have been established over the past few decades. Now, how did that happen? They just didn't happen by luck, right? So they were all small ideas. They were small companies that started with a small idea and then they grew bigger. So that's what any company that wants to do good, that's what they do. The first thing is they plan what they want to be. And depending on their plan, then they start gathering data. Okay, now once they gather data, they know they are in the right direction now. So they know what to do and how to do it. And then they do further data analysis on that. They make up their plans and they come up with strategies. They come to know what is the important thing that needs to be done and all these things. So when they finally have a concrete plan, then they execute it into business action. And once those actions are taken, then they're all good, right? That's when the business starts to grow. That's when the company gets back all their investment. And that's how actually any company grows. So any company that has done well over the past few decades, be it Microsoft or Google or Facebook or Amazon, Salesforce, all of these companies that have all grown from small ideas and they've become something big, right? And any startup that's also trying to do great nowadays, even they have to adopt the same strategy and the same plan. This is a very common thing and this is something that everyone knows, okay? But this is not what I've come to teach all in this session. What I've come to teach all is something about data warehousing. And that is one of the most important strategies or activities which is part of business intelligence, right? So before I talk about data warehousing, let me go into details of business intelligence. So what exactly is business intelligence? BI is the act of transforming raw or operational data into useful information for business analysis, right? So BI here stands for business intelligence. That's the short form. And yeah, it is the act of transforming any raw or operational data. So when we say raw or operational data, it's basically the data that you've collected, the data that you have about your business. So it can be, even if your company is starting from scratch, then whatever data you've gathered, so you've kind of got to take that data and convert that into useful information, right? So that you can plan and make strategies. And if you're a company that's well established, then you have to look at your past results, how your company has done over the past 6 months or the last quarter or the last year or two, and then come up with proper plans for your future. So when you do this, then this entire act is called as business intelligence. And how does it work? And this working of business intelligence is with respect to the IT technology, okay? So BI, which is based on data warehouse technology, okay? This is the key term that you got to remember. The BI is based on data warehouse technology. It extracts information from a company's operational systems. And the data that is extracted is first transformed. And when we say it's transformed, it's cleaned and integrated. And then it's loaded into data warehouses. Now, the thing here is there'll be data in many forms. It can be in the form of flat files. It can be in the form of databases. If it's a running company and if you're trying to do good, okay, if you've been in the working for a number of years, then you'll have data about your past success, about your sales data, your marketing data, your expenditure, all these things. You might have stored in any form, maybe in the form of databases, maybe in the form of Excels, flat files. So all these things. So these make up your data source, right? So you have this data over here, and this data is first transformed, okay? It's first extracted, then inside the data warehouse, it's transformed, which is cleaned and integrated. Okay, so once it's transformed, then it's ready for you to do your data visualization or data analysis. It's in a form in which you can get insights. And this is the data which the end users will be using. So you will have your data analysts in your company, right? Your data scientists, your data analysts, and all the other people, your managers, and the other guys who call the big shots in your company. So all these people, they'll be using this data to make your analysis. And that's the role of data warehouse. It is sandwiched between these two endpoints, and this serves as the basis or the springboard for success. And finally, since the data is credible, it is used for business insights. Yeah, this is again something that I just spoke about, right? So now you'll have a better understanding of how business intelligence works, right? So you all know that business intelligence is something important, and how important and how good it is, how does it work, is what I've explained in this slide.
Here's a simple question for you guys. Which of the following best describes the goal of business intelligence? Your options are: option A, to store large amount of data, B, to automate routine tasks, C, to support better business decision making through data analysis and reporting, or D, to develop mobile applications. If you know the correct answer, please comment down below. In our previous module, we understood what is business intelligence. Now, in our next module, how to become a business intelligence analyst, you will learn about the skills and steps needed to start a career in this field.
To understand why one should become a business analyst, there should be several aspects that you should be looking into. First being the job opportunities. Well, speaking of job opportunities, in India there are up to 6,000 vacant jobs as per now, and this includes both for experienced as well as freshers. While in the US, there are up to 43,000 vacant jobs. Now, this data is based on data available on LinkedIn, Glassdoor, or even Indeed. Similarly, we need to take a look at the Silicon Valleys, because Silicon Valleys always offers ample number of jobs. Now, speaking of Silicon Valley of India, Bangalore offers around 2,000 vacant jobs, includes freshers and experienced, while that of California offers up to 4,300 jobs. Now again, this includes data collected through LinkedIn and Glassdoor. The next aspect which comes into your picture when you are starting your preparation to become a BI analyst would be salaries. Definitely we've got you covered here, and average salary in India comes up to 6 lakh per year, while in US comes up to $91,000 per year. Now again, this data is collected through LinkedIn and Glassdoor. Now through this you can understand this is an average salary which includes even for freshers and until experienced. So this salary can go up to 10 lakh if you're experienced, or even beyond that. With that said, I hope this might have satisfied you to start your preparations for BI analyst. Well, if not yet, we'll go ahead in today's session and understand who is a BI analyst, why one should become a BI analyst, and further more questions. Well, the next thing that you will have in your head is who is hiring, which are the companies, or where should I apply? Well, these are the companies that you should be applying for. Now, as you can see in the data collected here, most of the product-based companies is hiring for BI analyst. Now, you can say by this that every company which is product-based predominantly is looking for a business intelligence head. Now, what does business intelligence mean? Like I gave in the start of today's session, BI is basically applying intelligence to one's business. Now, already established service-based companies Definitely, they would need BI analyst, but they would not need in such dominance because they have already established. So they need someone who can manage and go through to take forward. But while product-based company, they always need to think in innovative way, think outside the box. This is where a business intelligence analyst comes into picture. And hence, applying for product-based company is always a go here. Hope that was clear. With that, let's move on to our next session, which covers as to who is a business analyst. Now, basically, like I said in the start of today's session, business intelligence analyst is someone who applies their knowledge or their experience or perhaps their intelligence into business making, into project making, into establishing new aspect in their business. So business intelligence analyst, who is also known as BI analyst, like I said, uses data and other information to help organization make sound business decisions. Now, of course, there are several aspects one has to consider in order to become a business analyst. Now, some of these aspects includes data mining, reporting, descriptive analysis, statistical analysis, data visualization, visualization analysis, querying, data preparation. Now, through all these processes, you realize that these are the tasks that has to be covered as a BI analyst. So mining of data is very important, as in when you get reports or as in when you get raw data from your clients perhaps, or even your end users, customers. You have to clean it, you have to analyze it, you have to report, make reports of it, give a descriptive analysis, statistical plot graphs, and give a visualization out of it. Now we will approach as to how we can visualize these data further ahead in the session today. So querying is important, visual analysis is important. So these are the common tasks a BI analyst have to carry on. So I hope that was clear and you got to know what a BI analyst does in a skeleton. With that, we'll understand how exactly does an organization benefit out of BI analyst. Now, there are several ways one organization can benefit. Some of the points I've covered here, which is to identify ways to increase profit. Like I said, applying intelligence to any job will always benefit them. Now, imagine you have a protocol that is being followed. What if something comes out of the box? What if something comes which you have not anticipated? That is where a business intelligence analyst comes into picture, and he will think as to how this particular situation can be handled. This is where you can increase your profits. The next thing is to analyze customer behavior. Just like I said, a customer might feel unsatisfied or dissatisfied at any given point of time. There, he might just change his requirement. And these things should, in prior, be analyzed by someone, because these things are the ones which consume a lot of time. Now, if it has been analyzed prior, it will consume time and money also, efforts perhaps. So this is where a BI analyst will come into picture. The next thing is to compare data with competitors. Now, who will do? If there is a developer and tester, he will just work on that particular product or delivering that particular product to the team. But how do you know if this product is doing good in the market? How do you know if this is beating someone else in the market? This is where a BI analyst will collect all the data and make a report out of it. The next thing is to track performance. It's not just important just to maintain your records or to reach to the customer's requirements. Sometimes the performance will break down time to time. It is important for us to keep track and maintain that balance. This is where a BI analyst will help you do that. The next thing is to optimize operations. Of course, the end operations will be maintained by the person who has created it. Now, to optimize or to give the requirements of optimization will be done by a BI analyst. You need to predict success without seeing what is the outcome, or at least drafting the outcome. No one can actually work on an end product. You need to spot market trends. Now, without analyzing the market values, like we just discussed about competitors, you don't know where to stand. Perhaps what product would you make? Now, without knowing the market trends, you will not know which product you should be making to which customization. The next thing is to discover issues and problems. Definitely, with every business, every project that you encounter, there will be certain problems, be it big or small. Now, this has to be documented prior with a good intelligence. With that being understood, we will move on to our next session, which says how to become a BI analyst. Now, we have well understood who is a BI analyst, what does he do, how this will benefit an organization. So we need to understand how should we become one, because all these things can be answered only when you know how you can become a BI analyst. This is where our job description will come into picture. Now, if you go through several job descriptions, you will know and understand as to what we should be learning for. So going through these job descriptions, we will come to a conclusion of skills that we should be learning or even tools that we should be learning as a BI analyst. So let's go through the job description. Here, again, a very popular online platform, which is Disney Plus Hotstar, they are hiring for a BI analyst. Now, what are the requirements that they're saying? So I've taken a job description here where I have highlighted few points which summarizes the requirements of the person who has to be working as BI analyst. Now it says that he should be well versed in Power BI, Tableau, prepare and analyze data, data analytics perhaps. There is R, SQL, Python, good communication skills, analytical skills. Well, through this, I have summarized all the points, which goes like Power BI and Tableau is a must and should tool. You should have good analysis of data, good communication skill, which is a general one to everything. There's SQL, there's Python or R. Now, if this is not enough, we'll go ahead and see one more job description, which is Dell. Now, Dell is a popular service-based and product-based company as well. Here, I have summarized to project management. Yes, project management is also one important skill. Of course, this will not be asked in every company, but in most of the company or several companies, this could be asked. Why not be unprepared, right? Let's be prepared on every possible skill that will be asked in every kind of company as a BI analyst. There's project management, again, Power BI, Python, and SQL. As you can see, as we go ahead in several job descriptions here, Power BI, Python, and SQL stays constant. Let's see one more, which is Puma, again, another product-based company. And here again, we have Power BI, Excel, data analysis, SQL, and Python. So from this, we can conclude some of the skills that we need to become a BI analyst. So as we have come across, we need some database concepts, SQL predominantly. SQL is must and should be known by everybody who is applying for BI analyst. Excel. Now, Excel is also one more important tool that is to be known by a BI analyst. If you have good Excel skills, you can actually analyze data. Now, sometimes there are cases where people do not know any kind of data visualization tools. Did you know that these kind of data visualization can be done even in Excel? So knowing Excel is an added advantage. Analytical skills, of course, being an analyst, analytical skill is a must and should. Power BI. Now here I can go ahead and add Tableau also. The next thing is Python. Python is where you use, it is a programming language where you use for your data visualization. Now to plot graphs or even to make your analyzation of data easy, you can use Python. So usage of Python is very important. So make sure you know Python. Now, project management skills. Here, I must mention most of the skills that I mentioned here, or perhaps even every skill that I just mentioned here. We have courses for everything on our channel. I'll speak about it towards the end of today's session, but here I had to mention that be it SQL or Microsoft Excel or even analytical skills, Power BI, Python, project management also, we have course on our website. Now, if you think that you don't want to do the course, you are good enough and you just want to brush up, you can go ahead on our YouTube channel also. Like I said, I'll be speaking about it in the end of today's session. Now, moving forward, we have R language also. R again is used predominantly when you have to clean data, you have to process data, or even plot some visualizations, you need to be using R. Tableau, again, one of the data visualization tools, just like Power BI. Now, at this point, I would have to mention that here it is not just the skills. You need to be aware of certain tools as a BI analyst. Now, in the job descriptions, if you are an experienced person, there are chances that you will be asked for a tool-based experience. Now, speaking of that, we will address some of the tools here. Companies use different tools. Now here I have spoken about SAP Business Objects, DataPine, MicroStrategy, SAS BI Intelligence, there's QlikSense, there's Zoho Analytics, Sisense, and even Power BI is a tool. Now, these are some of the tools that companies predominantly use. Some of them are free, some of them have trial basis. So you can go ahead and pick any one of them, or even you can search on web and you'll find several number of BI tools. So with that, we will move on to our roles and responsibilities. Now, as a BI analyst, it is very important that you know certain roles and responsibilities prior to starting your preparation. So the first thing you need to know is you need to be learning and fully understanding the data landscape in databases and applications. So data is your king. Now everything that you have to work is in and around data. So make sure you understand and study data completely. The next thing is using and developing data collection process. Again, it surrounds around data itself. So it will be around understanding data. The next thing will be around collecting data. So everything will revolve around data itself. The next thing is reviewing and validating. Here you can understand there is a sequence or a step of responsibility that a BI analyst have to follow. The next thing is gathering end user reporting and dashboard requirements. Finally, you have to review, validate, maintain customer data as collected. Also, maintaining is very, very important. Make sure you will always maintain good data and also your projects.
Previously, we discussed becoming a business intelligence analyst. Next, we will dive into data warehousing and BI, focusing on how data warehouses support BI systems.
Let's go into details of data warehousing. Let's understand the challenges in achieving business intelligence. So first of all, why should we use a data warehouse? Because data collected from various sources and stored in various databases cannot be directly visualized. Okay, now look at this image here. In this diagram, you have different databases like Oracle, you have the SAP base, you have the Microsoft SQL Server, and then you have other databases like SQL database and all these things. Okay, you can also have flat files in this list. So all these make up your data sources. You as a company can store data everywhere. So if you're a small company, you might just deal with Microsoft Excel and you might just use small analysis tools. Okay, but if you're a big company that has a lot of data coming in, so if you're a retail company, then you'll have to store details about your sales, your marketing, and what's been your growth. So for all these purposes, you need big databases, right? So all the data will be stored in all these databases. Okay, now the problem is some teams in your company might be using one database and the other teams may be using another database. Now the biggest problem that people would find while they are doing visualization or doing analysis is data is there in different databases and they'll have a tough time integrating them, right? Now that's where data warehouse comes in, and that's where data warehouse goes. Data warehouse, it integrates data from all these databases and then processes that data and brings it in a form which is very easy to do visualization. Okay, that's what the second point says. The data first needs to be integrated and then processed before visualization takes place. Now this is the problem that you have with the regular databases. Okay, the data from here, they cannot be directly used for visualization. And since data warehouse can do that, since it can integrate data from multiple data warehouses, and since that data can be processed easily, since it brings the data in a form which can be easily visualized, that's where data warehouse has the advantage. That's where it scores. So that's the problem with database, and that's the advantage that data warehouse has. In fact, data warehouse is more like an act. It's a discipline which is followed by people. Okay, these are actions which are adopted and strategies which are taken. Okay, that's what data warehouse is, and that is the role it plays in us doing very good visualization. All right, so now this should be a little more clear for you people as to why data warehouse plays the key role in the whole BI aspect, right? Okay, great. Let's go to the next slide then. Now let's understand in detail what a data warehouse is. Now, a data warehouse is a central location where consolidated data from multiple locations, okay, or databases, that's what locations mean, from multiple locations are stored. Now this means This is exactly what I explained earlier, right? So you have data that's coming in from multiple data sources. You have all the data, you consolidate all the data into one single place. And the data warehouse is maintained separately from an organization's operational database. Now, DWH here stands for data warehouse, all right? So, and here it says that data warehousing is maintained separately from an organization's operational database, okay? And yeah, the DWH here stands for data warehousing. And the reason a data warehouse is stored separately from the operational database is because the data should not get affected. So you will have your operational data on one end, okay, where all your legacy data will be stored, where all your probably even your real-time data will be stored. So all your transactions, all your sales, all your marketing, all your operations data, all these will be stored in one place. And during the act of data warehousing, when you're doing that, when you're making analysis, when you're using that data, you don't want that to get corrupted, right? So it's more like a backup. So for backup purpose, your operational data is separated. So you have your operational data, you keep it in one area, and then you create a new database, okay? In fact, it's called a data warehouse, okay? So you get all the data from multiple sources or maybe from a single source, get it into a data warehouse, and from here, you do your analytics. So the process of getting the operational data into your data warehouse, that's called extraction, transform, and loading, okay? Now, when you've done these three things, you form your data warehouse. And from your data warehouse, you use the OLAP strategy, okay? So OLAP stands for Online Analytical Processing. So you use this OLAP strategy, or well, this analytics processing for the business users to do analysis. So it's there in the name, right? It stands for analytical processing. So the business users, whatever analysis they want to do, they do it because there is the option of OLAP. And then along with the analysis, they can also do visualization. For visualization, you have various other tools like Tableau and QlikView, right? There are some amazing tools. So you can get this data, you can get it into the data warehouse, and the data warehouse also, it can be stored in some kind of database. You can store this data back into some kind of Oracle or SQL server, or maybe even in Excel. And when you've stored there, then you can do your OLAP activities there. And also you can import that data into your various visualization tools like Tableau or QlikView, and thus you can get insights. You can get insights into your data. You can deliver presentations during your board meetings. You can show your findings to your superiors or your managers. You can do all these things. So that's what a data warehouse is, okay? And then the next point we have here is end users access it whenever any information is needed. Yeah, so this is again the same thing, right? So once the data comes in from the operational system, it's stored in the data warehouse, it stays there. So this data is not going to change. So whatever change you want to do to your operational data, that can be done, okay? You can modify this data, you can update it, you can delete data here, you can do all these things. But once your data comes into your data warehouse, it cannot be deleted, okay? You can maybe modify things. The worst case scenario, you can modify data here, okay? But it's highly advisable not to. But of course you can, so that's the thing. But yeah, the key point you got to notice, the end users can use it anytime. They can probably access data that is 10 years old or 20 years old and all these things. And how can they do it? By using OLAP. So they can do the analysis and they can run it over different times, right? So these are a series of snapshots. So based on, you can find data analysis like what happened at this particular day on this particular year, all these things. You can see what kind of product was sold, how many customers bought which product. All these details can be easily gathered and accessed from here. So that's what we say when the data can be accessed at any time by the end users or the business users. So the business users here are typically those of managers. It can be managers or people who are leading board meetings, who are making a plan for the next quarter or the next half year or the next 1 year and all these things. So guys, yeah, that was a question which Jacob asked, guys. So Jacob asked, who will be the end users? Who will be the business users? So that's what they are, okay? People who will be using this data. It can be even data analysts or data scientists and all those people. Right, guys? Are you clear, Jacob? Okay, great. And there's a note, okay? The data warehouse here, it is not loaded every time when new data is added to the database. So what this means is, you have data coming in your operational data, okay? This operational data will get updated every minute, probably every second. If you have a 24/7 working sales team, then they'll be making sales round the clock, right? So as and when any sale happens, the data will be added to your database, to your operational data. But that not necessarily needs to be added to your data warehouse also. So what you find in your data warehouse is legacy data, right? It's historical data, which you can use to perform analysis or all those find insights. The operational data, if you have new data coming in here, this has to be imported and this has to be moved to your data warehouse first. And then once it's moved to your data warehouse, from here it can be used for analysis and all these things by your end users. So that's what this diagram here means, and that's what the last point also means. Okay, data warehouse is not loaded every time new data is added to this database. Okay, Fine then, if you guys have understood what a data warehouse is, I can go to my next slide and talk about the next topic. So that was about data warehouse. Now let's look at the advantages of a data warehouse when we compare it to any database or just regular flat files and all these things. The first advantage is that strategic questions can be answered by studying trends. So this is the biggest benefit that you can get, right? Your data analysts and data scientists, they can answer strategic questions. They can read the past data. They can predict your future also by coming up with, by having their strategic questions be answered, because trends can be analyzed using the data warehouse. It's basically the data that is stored in your operational data also, but it's just that it's easier to study trends on your data warehouse rather than database. Okay, why not a database? What is it that a data warehouse can do that a database cannot do? So guys, that's what I was answering. The first thing is, let me go back to my previous slide for this. Okay, so you have your operational data here. So you have all your data here, which is probably legacy, which is even real time. All these things will be present here. But in your data warehouse, you'll only have your legacy data. You'll only have the historical data. You won't have real time data here. But that doesn't mean it's not, it's any lesser than operational data. Since you have your data completely here, you have the freedom to do your analysis, and you also have your freedom to do your data visualization. Okay, so that's one advantage. And the other advantage with the data warehouse is that your data will be coming in from multiple sources, right? You'll have data coming in from multiple sources. Your tables will not be related to each other. Even if it's from the same database, you'll have multiple tables for multiple teams, right? And you can't easily integrate all these tables because they'll be separated. Okay, that is one big problem that you will face when you're doing the analysis or visualization. But in a data warehouse, it will be stored such that all the data will be interlinked, right? It'll be related by using schemas or all these things. So you have different schemas like star schema, snowflake schema, galaxy schema, and all these things. So you have all these dimensions and facts, all these concepts using which you can relate your tables. You can relate your data. So all your rows and all your columns here, which are unrelated, which are stored in separate databases or in separate flat files, separate tables, they can all be integrated. They can all be stored together. So there'll be a relation. So every single row or every single table will be linked with each other. And when you do an analysis like that, then you can probably pull data across the database, right? So whatever data is stored across the various databases, you can pull all that data and link them all together by running one query, and you can get all those details in just by just running one single query using your data warehouse. This is the second advantage. Okay, that's why business users, they prefer to use data coming in from a data warehouse. So this is a more structured and this is a more related data when you compare it with the operational data and the basic data source. All right. Anyways, moving on. That was about data warehouse, and talking about the advantages of data warehouse. I spoke about the fact that you can answer strategic questions by studying all the trends, by studying your past data. You'll have all the graphs. You can have the pictorial representations, right? You can see what was whether the trend is growing or not, which product is getting sold, how better it's getting sold. All these things you can easily read by using a data warehouse, because data warehouse makes your data more readable information. So that's the thing. So you guys must know the difference between data and information, right? So information is something that is processed. Processed data is called information. So information is easier to understand, easier to relate to, and easier to use. Now that's what data warehouse does. It takes you one step closer to information, right? So that's the advantage. And yeah, the other thing is data warehousing is faster and it's more accurate. Yes, this is something that's completely true, because in your database you will have loads of data. Of course you'll have historical data and real-time data, but the thing is it's not going to be as fast as data warehouse. Data warehouse, you'll have links there, you will have links, you'll have tables, you'll have relations between the various tables, and because of all these things you can easily gather and you can easily access data here, and the data that is gathered from here, it's also more accurate, because there won't be much change, because there's not going to be any question of real-time data coming in and changing things around, right? So whatever processing or analysis, it's done based on the past data that is stored in the data warehouse, and that makes this data more accurate. It makes it more stable. So stability is the key word here, and stability is not something that you can have all the time in database, but you will have it with the data warehouse. So that's the second big advantage. And in fact, there are many more advantages, right? So data warehousing is something that you guys will understand when you start implementing. So in the demo session that I'll show you later today, that time you will understand, you'll understand the other advantages with data warehousing. Okay. And one important point that you need to notice, that data warehouse is not a product that a company can go and purchase. Okay, it needs to be designed, and it depends entirely on the company's requirement. So like I said, your database is something, it's a necessity, right? Your database, or where you're storing your data source is something that you have to have, and then your data warehouse is something that is designed and which completely depends on your company's requirement, based on your data source, based on the requirements that you want to get out of your data source, out of the data that you have in your data source. You can come up with a way to design your data warehouse, right? So data warehouse is more of a concept, and it's a strategy, and it's not an end product. It's not a tool or something that you can use. You have multiple tools to implement data warehousing, and the thing you got to notice, data warehousing is not a product. Okay, so it's a strategy that you adopt to make your data more readable and make your data in a better fashion. Okay, so that's the biggest advantage with data warehouse. So look at this guy here. Okay, he'll just run one query on the data warehouse. Okay, now what the data warehouse will do, the data is taken from the operational systems. All right, and in fact, if there are multiple operational systems, then all those multiple data from multiple operational systems will be integrated together, and then that will be standardized, and any inconsistencies there in that data will be removed. Okay, now these are the three important things. The data is taken from the operational systems, and that data, if there are multiple operational systems, those will be integrated. Okay, and then the data will be standardized, and any inconsistencies will be removed. And once all these three things are done, then it can be stored in an easy format, which can be which is very suitable for analysis and access. And that is what a data warehouse is. So whenever he runs a query on this kind of a data warehouse, which is a process and which is ready in such a fashion, you can get the result quickly, and this result will also be more accurate. All right, so this is the big advantage with the data warehouse. So I hope this is clear. It's a pretty simple concept here, and it's just an overview of what I explained in the previous slides, right? Okay, so moving on, there are 4 important properties that a data warehouse has. Okay, and these 4 properties are based on what Bill Inmon said. Bill Inmon is the father of data warehousing, and initially he defined data warehouse as a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of the management's decision-making process. Okay, so when we say subject-oriented, it means that the data will be categorized and stored by the business subject rather than by the application. Now, let me get back to this point after I finish these 3. Okay, now this is the most complicated point. Okay, now talking about integration, right? He said that data is integrated. So the meaning here is data on a given subject is collected from disparate sources and stored in a single place. So this is something you people know. Data is collected from multiple sources, and they're all stored in one single place. So you don't have to go about searching for data in different tables or different sources and all those things. And then your data, it is time variant. It is stored as a series of snapshots, each representing a period of time. So when you do your analysis, you can do it based on a series of snapshots of time. Okay, you can see what was your company status on this month that year, or on this month this year. What is the progress that's been made, or if it's not a progress, if it's the same, if your growth has been stagnated, then you can find out what are the metrics, what are the reasons why that has happened. You can find all these things, and you can look at all those details from a time approach, right? From a time variant approach. So that's what a data warehouse, the advantage here is. Okay, that's one of the properties and the advantages that you have. And then data is non-volatile. The data in a data warehouse is not updated or deleted. So this is what is the other property that I mentioned earlier. Once a data comes into a data warehouse, it cannot be deleted, or neither can it be changed. In fact, it can be updated, but the process of having to update it is a little complicated. Okay, but of course it can be updated and deleted. So that's the thing, but it's highly recommended not to update. Okay, so that's the advantage with the data warehouse, and since it will not be changed, there's no question of it getting corrupted, and that's why doing analysis and all these things are a better option. Now getting back to the first point, we said that it is subject oriented, right? Data is categorized and stored by business subject rather than by the application. Now what this means is the data here will be stored, or the data that you retrieve from a data warehouse, right? You will get it in the form that you want it to. Now if you want to give me an example of that, let's say that we are dealing with a retail company, and in my retail company I have a marketing team, I have a sales team, and I have an operations team. And my sales team kind of keeps track of all the sales that happens over a period of time. Okay, let's say the last 1 month, whatever sales they have done, they have stored all those details. And then you have your operations team, which will make sure there is a smooth running of all the process. Once the sale is done, there are various other activities involved, right? like shipping the product and all these things, shipping and coordinating the transferring activities and all these things. And then your marketing team is probably that team which would take care of your sales, which would ensure that the right leads come in, to ensure that the right people get the right kind of service, and it's all about acquiring more such sales, right? So your marketing team is on top of the funnel, and they do all these things. Now, if you want to integrate all these details, if you want one single view of them, and you want to find details such that in this particular month, what was your sales, and what was the kind of operations that was done, right? What kind of service was given to those customers, and from how they became our customers. So when we the question of how they became is something related to marketing. So if you have a question like this where three factors are involved, then at that point of time, it's your data warehouse which comes to the rescue. Because when your question is related to this particular time, and these three different metrics, sales, marketing, and operations, then all these things can be integrated, and you can get one single view from your data warehouse. This is what a database lacks, correct? So integrating all your different data sources and storing them together and making them ready for anytime access is the biggest advantage and the most important property of a data warehouse. So if you guys had any problem in the previous slides, then I'm pretty sure this is something you have really understood after this slide, because this is probably the epitome of data warehouse, right? These three properties, if you understand these four properties, then you're pretty much ready to understand the next part, the next you're ready to go to the next step in data warehousing, right? So by now you should have understood how important all this is, why how important business intelligence is, and what kind of role this data warehouse plays. You can just think of how humongous a deal a data warehouse is, correct? Yeah. So now that we've spoken about the properties, let's go to the next slide. And okay, now we have to talk about key terminologies. Okay, so right now we've understood data warehousing from a higher level. Okay, now let's dig deep. Let's go to more basics here. Okay, let's understand the key terminologies that are related and that are involved in a data warehousing. So first of all, we have OLTP and OLAP. Okay, now there are four things which I will talk about. The differences between OLTP and OLAP. Okay, then I'll talk about EDL, I'll talk about data mart, and then finally about metadata. Okay, so let me go to the first topic, that is OLTP versus OLAP. Okay, so in this part, which is OLTP, OLTP stands for online transaction processing. Okay, now this is something that is a representation of that of a database. If you're running any kind of queries on your database, then that's called online transaction processing. Okay, and then OLAP stands for online analytical processing, and this is the property of a data warehouse. So any kind of query or any kind of analysis that you run on your data warehouse, that's called as an OLAP activity, correct? So let's go into the differences between the two. So first of all, any data that is stored in a relational database, right, in an which involves OLTP, that contains the current data as well as past data. Okay, current data as well as past data. But with respect to a data warehouse and while performing an OLAP, you will be dealing with only historical data here. Okay, it contains only historical data, and the data that will be stored in your database. Okay, when you use the OLTP, then those queries will be useful in running your business. Okay, when you have to run your business, like if you want to store the data of the number of sales that has happened today, like every time a sales happens, then your records in your database has to be updated, right? So that's what we say. So when you update your record with the latest details of your customer, then that is what is the meaning of useful in running the business. Okay, but an OLAP is something that is useful in analyzing the business. So here the kind of activity that you would do is that of finding out details like at what time how many customers bought the products, or at what time which customer bought which all products. All these kind of questions will be answered with the help of OLAP. Okay, and then the whole OLTP model of accessing data, of accessing or querying data on a database, it's based on the entity relationship model. Okay, but whereas with the data warehouse, it's based on the star schema or the snowflake schema and the fact constellation schema. Okay, so it's also called as the galaxy schema. So all these three things will come into picture. Okay, and then your relational database, it provides a primitive and a highly detailed data. So since you'll have one database, if you run one kind of a query like select star from this particular table, then it would give you all the details that is stored, right? So you cannot filter too many details with respect to the data that is stored in your database. Okay, of course you can, but the level of the filtering and analysis that you can do is not that much. So the data that you will get back from your query, right, the result that you will get back from your query will be highly detailed, okay, and it will not be exactly what you want. So it will not be that accurate. But whereas with the OLAP, when you do an OLAP on a data warehouse, it provides a summarized and the consolidated data. It will point to you exactly what you want to look for, correct? So it will, it's a very processed data, and it points to one particular aspect which matters the most. So that's what this is. And then the OLTP, you use this for writing data into the database. Okay, so like I said, the same sales example, whenever a new sales happens, your database has to be updated, right, with the new records of the product sold, of the customer who bought the product, and all these things. So you basically use it for writing data into the database. But your data warehouse is primarily used for reading data from the data warehouse. So writing to the data warehouse is something that is done so that you can do the reading from the data warehouse. Okay, the primary concept here is to read the data from the data warehouse and to do the analysis and all the visualization activities. But with the database, it's more of writing the data into the database. All right, and the size. So speaking of the size, a database's size would range anywhere between 100 MB to 1 GB. Okay, and this is also a very vague number. 100 MB is a very less number, I would say, and 1 GB is also very less. So it would typically be much more than this. But compared to this range, if you look at a data warehouse size ranges from 100 GB to 1 TB, correct? So your data warehouse will have all the historic data, and it will have all the relationships between the different data, right, such that you can do your analysis straight away. So since it makes all the data more efficient and stuff, the data here, the size ranges from 100 GB to almost 1 TB. So that is what a data warehouse is, and that's the power of a data warehouse. All right, and I can actually show you the difference between the two in today's demo session. Okay, later during the session, I'll show you that the size of the source file that I have. I will show you the different sizes of the two files that I'll be using as the source, and then after they are processed, the data that I'll store in my data warehouse, I'll show you what is the size of that data. So there'll be a big difference between the two. Okay, and the data warehouse will be more than the database. I will show you that aspect later. All right, so. And that's about this point. And then, yeah, of course, this will be fast. Okay, database is fast and it provides high performance. All right. So your data warehouse, of course, it's not as fast as your database, but it's highly flexible. It's highly flexible because it gives you different views. So you have something called as the OLAP cube, right? So using the OLAP cube, you can you can look at insights from different angles, different perspectives, and different views of data you will get. So that is the big advantage here. Okay, and the number of records that is accessed, it is in tens, but whereas with the data warehouse, the number of records accessed is in millions. All right, an example of this can be all the bank transactions made by a particular customer. So if there is one customer and whatever transactions he's made, he will get all those all those details, right? So supposing, take the example of any email statement that you request for, any email statement or a bank's account statement, all these things. So they are an example of OLTP. So whatever details are present in the database, those will be given to you. But whereas the bank transactions made by a customer at a particular time, okay, this is a more filtered query, and the answer also will be very accurate and point you to exactly that particular question. So that's what an OLAP is. So it's not going to give you an overview here. It's going to exactly point you to what you want. It's not very much in detail, but it's more accurate. Correct. So that's what an OLAP is, and that's the difference between OLTP and OLAP. Okay, so these are the two strategies that are used for accessing data. OLTP is used for accessing data in a database, and OLAP is used for accessing that data in a data warehouse. All right. Okay, if you have any doubts, then that will be cleared by this slide. Okay, because the examples are there for both these strategies. So if you want more examples of an OLTP, then one would be that of a supermarket server, which records every single product purchased at that market. Okay, so every single product in their history or probably in the last 1 month, all these things can be accessed using your OLTP, okay, from your database. You don't have options to do much of filtering here. And then another example is that of a bank server, which records every time a transaction is made for a particular account. Okay, every time a transaction is made in a particular account, the data will be updated in that table, and you can query that kind of data and you'll get that result. Okay, another example is that of a railway reservation server, which records the transaction of a passenger. So whatever activities a passenger does, so all these things will be recorded by the reservation server, right? So this is one example. But when you look at the OLAP, they will be much more detailed. The queries here will be much more detailed, and the answers will be much more accurate and very crisp. Okay, so an example is that of a bank manager wants to know how many customers are utilizing the ATM of his branch. Okay, because maybe based on that, he may take a call whether to continue that ATM or relocate that ATM to a different place, right? So this bank manager would want to, first of all understand if there's any use in having the ATM in that place. Are people using it? Correct? If people are using it, then how many people are using it? At what time are they using it? Or would it be better to have the ATM in a different location where it's much more easier for people to access it? So all these kind of questions will be answered only if you have OLAP in place. Okay, only when you have a data warehouse in place, not with the database. So another example is that of an insurance company that wants to know the number of policies each agent has sold. Okay, this will help in better performance management of agents. So you'll have multiple agents in your company, and you would want to know their performance, right? You'd want to know who is the best performing agent. You would want to know how they are performing. Why is this person performing better? You can optimize each of their performances. So all these things can be done with the help of a data warehouse, and they can be done with the help of OLAP, right? The OLAP strategy, the OLAP activity that is done on a data warehouse. So that is the difference between the two, right? So I hope you're getting the differences here, guys, right? OLTP and OLAP. Okay. Now, the second important terminology that we have with data warehouse is that of ETL, extract, transform, and load. So by going by the definition, ETL is the process of extracting the data from various sources, transforming this data to meet your requirements, and then loading the data into a target data warehouse. Okay, you're extracting the data from here, right? You're extracting it, and then you're transforming it into the way you want, in a more readable fashion, in a more relatable fashion. Then once that is done, you load that data into a data warehouse, and the whole process of getting the data from your data source to your data warehouse, this is done by the ETL, the activities of extraction, transformation, and loading. So we have popular tools for this very process. So you have tools like Talent, Informatica, you have Irwin, all these things. And Informatica and Talent are probably the most popular tools for this process, for extraction, transformation, and loading data into a data warehouse, right? So this is something that you should have understood by now. Okay, great. So the next one is data mart. Okay, now if you've understood so far till ETL, then half your job is done, because data mart is something that's very close to a data warehouse, and you don't have that much of a difference when compared to a data warehouse. But the basic difference between the two is the data mart is just the same data warehouse itself, but a smaller version. Okay, so let's look at the definition here. The data mart is a smaller version of the data warehouse which deals with a single subject. Okay, the data marts are focused on one area, hence they draw the data from limited number of sources, and the time taken to build data marts is very less compared to the time taken to build a data warehouse. Now, to give you an example or an explanation of this, in your data warehouse you will have all your details, right? All your details that you have. So this itself is more refined, okay? But your data marts are smaller versions of that data warehouse, which is used to satisfy only certain users. Supposing you have one particular user base, okay, that is your sales team or your sales manager who wants to use only your sales data, then that can be done with the help of a data mart. And similarly, you have a marketing team who wants to access all the marketing data, then that can be done by using a data mart. Okay, and then again you have other operations team that wants to do who wants to access the operations data, then you can give them only access to that data by using a data mart separately. Okay, now the need for data mart is, first of all, your data warehouse will store all the data, okay, your sales data, marketing data, operations data. So all the data coming from different data sources. So you'll have multiple data sources, right? All that will be stored in one single place. And from here, this will again act like separate data sources, right? So for the sales team, this will act as a data source. For a marketing team, this will act as a data source. And then for the operations team, this mart will act as a data source. Now answering the question as to why we need them, it's to probably give more security, to enable more security and integrity. Because since all your data will be there in your data warehouse, and if you let all your entire company access the data warehouse, they'll get access to all the details and all the work that is done by other teams. Okay, so there might be multiple teams and there'll be multiple strategies which you might not want to reveal to other teams. So at that kind of a time, you can divide your data warehouse such that only this particular users, okay, your sales users or a particular user base gets access to only certain data from your data warehouse. So at that kind of a time, a data mart is useful. Or you can have a second data mart for only another set of user base. For example, your marketing users. So they will get access to only the marketing data from your data warehouse, right? And then your operations data. Similarly, which can be accessed only by your operations folks. So that's the different advantages that you have, since the data is all divided, it's all stored separately. Different people have access to different parts of your data warehouse. So this probably brings more advantages, right? So that's the data mart, and that's why I told you that if you've understood so far till ETL, then half your job is done. But data mart is something that that extends the functionality of a data warehouse, right? So that is the thing. And speaking of the differences that is there in this table, the data warehouse will store the enterprise-wide data, right? The enterprise or the enterprise-wide data. Whereas data marts will store only departments-wise data. There'll be multiple departments in the whole company in the enterprise, and they will store department-wide data. And then the data warehouse, it will have multiple subject areas, okay? But a data mart will have a single subject area. There'll be multiple data sources in case of a data warehouse, okay? But in case of a data mart, there'll be limited data sources. In fact, there can be just one data warehouse, right? This will act as a source to your data marts. But however, we have said limited here because not always do you need a data warehouse. There are also instances where your data source itself acts as an input to data mart, okay? Now that is something that you will understand in the next slide, okay? So just don't get confused when we see that limited data sources. It doesn't mean this is the only source. They can also come from a proper data source like a flat file or from a database and all these things, all right? And then a data warehouse, it occupies a large memory. This of course because there's a lot of data, enterprise-wide data will be stored here, multiple subject areas will be there. Because of that, there's larger data here at stake, and that's why there's a greater memory that's occupied, okay? But in case of your data mart, it occupies limited memory because it's very crisp and limited to only a particular department, okay? And then the other thing is, a data warehouse is takes longer time to implement, but a data mart takes very short time to implement. Because once you have all your data warehouse stuff in place, you can easily divide them by just creating different data marts, okay? So the tough part is your data warehouse. So once you've got your data warehouse sorted, you can easily form your data marts. In fact, there's even the other way. There are also practices where you first build your data marts, and once you've done that, after that you create one single repository, and that's when you create a data warehouse. So there's also two approaches here. One is the top-bottom approach, and the other one is bottom-up approach. Okay, now speaking of the different types of data marts, okay, this is what I was talking about in the previous slide. So you have three different types. One is a dependent data mart, the other one is independent data mart, the third one is hybrid data mart. Your dependent data mart is the data is first extracted from the OLTP systems and then populated in the central data warehouse. And then from this data warehouse, the data travels to the data mart. So look at this example. Okay, this is the standard practice or the default approach where you have an OLTP source. Then you get that data into a data warehouse, and then from the data warehouse you form a data mart. Okay, you'll have multiple data marts where each different mart will have particular data from the entire data warehouse. Okay, this is the first regular approach. And then you have the independent data mart, which is a slight variation compared to dependent. So here the data is directly received from the source system. Okay, you don't have a data warehouse in place over here. That is what this line means, and this is suitable for small organizations or smaller groups within an organization. So basically, an organization which is very small, it might not need to go through the trouble of creating a data warehouse and stuff. So they can just have an OLTP source, and from there they can just get the data in onto a data mart, and they can use it for various purposes. Okay, that's what we have an independent data mart for. So that's the difference. It just does not involve a major data warehouse. So directly the data goes to a data mart. In fact, you'll have multiple data marts over here. You'll have data mart 1, data mart 2 and stuff, okay, which will be coming directly from the OLTP source. And then you have a third type, which is the hybrid data mart. So by definition, you might know what this is, right? By the name itself is pretty obvious. It's a combination of these two. The data here is fed from both the OLTP systems as well as the data warehouse. Okay, so look at this example for that instance. The data here, it's coming from the OLTP source as well as from a data warehouse. So this is what the hybrid data mart is. And depending on your company, depending on the size of your company, the requirements of your company or your organization, you can choose one of these. You can model your entire database and data warehouse in any one of these models, either the dependent or the independent data marts or hybrid data marts. All right, so that's about the different types of data marts. So moving on to the next slide, we have something called as metadata. Now, people here from programming background or from the technology background, you might all be aware of what a metadata is. Metadata basically is defined as data about data. Okay, it contains data about where your actual data is stored. Supposing you have your raw data, right? Where is that data stored? What is the size of that data? So these are the answers to these kind of questions is what will be present in your metadata. Your metadata will contain the location of your actual data. It will contain the size of your actual data. It will contain details like which was the source it came from and when was it created. All these details will be stored in your metadata, right? So that's what metadata is. So that's how different metadata is from regular data. And metadata, specifically in a data warehouse, it defines the source data, that is a flat file, relational database, and other objects. So the reason that we give so much importance to metadata in a data warehouse is because, take the example of any company that's having a 24/7 business. Okay, they have a rolling sales team that works throughout the clock. The 24/7 they have sales coming in. Data will be going into your database. Okay, now in this case, you cannot always keep adding data into your data warehouse, because you know that data warehouse is not real time, correct? So you'll have to manually update your data into your data warehouse, probably at every day at a particular time, maybe at 6 o'clock every day in the morning, or maybe once in the night at 10 o'clock, or at basically at regular intervals. You've got to store data into your data warehouse, and this whole strategy becomes difficult because you have to do this process every day. So every day when a guy comes in the morning, he has to look at the new data that has come into your database, correct? And then from that database, which is data source, he has to add that data to your data warehouse. Now this process becomes difficult. So that is where metadata comes in handy. With metadata, you define the address where your data source is. Okay, you define the address of your flat file from where your data is coming in, or your relational data from where your data is coming in. And then you can also, in fact, store the metadata of your data warehouse where you want the data to go. So it basically saves a lot of your time. Okay, and this is the most common and the most unspoken fact about a data warehouse. So any professional that's dealing with data warehouse, he would always be using metadata because it saves a lot of time. Because every time you cannot be importing data from a database, you always have to get it from your metadata by defining rules and defining your source and your targets. Correct? So metadata saves a lot of your time, and this is something I'll show you a demonstration on. Okay, and when I show a demonstration, you will understand how easy it is. So you'll just write the rules such that you have your source over here, and then you have your destination over here, your target over here. And once you've written this thing, you don't have to go back here. So every day it might pick up the data from here and it might move to your data warehouse and all these things. It will update all the new details which are present in your database, and it will add it into your data warehouse. So that's what a metadata does. It's a very big advantage, and it's one of the best strategies that we can go for. Okay, and then the final point here is metadata is used to define which table is source and target, and which concept is used to build business logic called transformation to the actual output. Yeah, this is what I told you, right? So it's used to define which is your source and target, and how to build your business logic called transformation. So transformation is basically your act of converting your source data into the form that you want to, and what is the logic that you use, correct? So all the different the filter criterias, all the transformation criterias, all these things can be also done using the metadata, correct? So even the process of getting the data from your source to your destination, it can involve extra additional steps which can save your time, and default process basically. So every time you have data in a particular format, you might want to store it in a different format, and for all that purpose you can use a metadata, right? So since things will already be defined here, the work of metadata is just to get the data from the source defined and do the set of activities that is required and which is already defined. It will perform all those activities and it will store it in the place where you want it to. So that is the role of a metadata, correct? So metadata is very, very important. It's very, very highly used, and it's actually the most important, or the, let's say it's the epitome of data warehousing. Okay, this is probably the best thing that can happen to data warehousing, right? So that's the thing about metadata, guys. Now going to the next slide, we have the architecture. So now that you know everything, okay, these four terminologies are more than enough for you to understand the architecture. Okay, so let's understand what the architecture is. So this is the entire architecture diagram. Okay, so this is what, you know, data comes in from various sources. It can come from either a database or it can come from a flat file, and then that data, an action of ETL will be performed on that data, and it will go to the staging area. Okay, this is called the staging area, and this is the staging database. And the data that is stored over here, it is temporary data. Before the data completely moves to the data warehouse, it will be present in this area. Okay, and that is done by using the act of ETL. And also between moving to the data warehouse, the process of ETL continues. So ETL process starts over here and it ends over here. Okay, and between the conversion, it is temporarily stored in a staging area. and this is most often present inside the ETL tool itself, okay, like your talent or Informatica and all these things. And then this data will be stored in your data warehouse. So whatever is extracted, transformed, and loaded, it will be loaded into your data warehouse. And in your data warehouse, you'll have metadata, okay, and of course you'll have your raw data, and then you'll have your aggregate data, okay. And this is the reason why a data warehouse is generally, it's larger in size, because it has not just raw data, your database, which from where the data is coming in, it will only have your raw data, okay, but your data warehouse will have additional stuff here. It'll have also your metadata and your aggregate data, and together, all these three things together is what help in you doing your analysis sooner, okay. This is what powers your ability to do OLAP, online analytical processing, okay. So that's what a data warehouse is, and that's what it stores. And then this data warehouse, you can either your entire company can use a data warehouse, or if you want more of a security based access, then you can divide it into different data marts, where your sales team and your different teams, like here we have a purchase table, and then you have your stock table. So these are like three different marts, data marts for three tables, like sales, purchase, and stock. So you'll have different tables here, and different teams can access different set of tables, okay. Your purchase can be something that's used by your operations people, right, and then this may be something that's used by your sales people, and your stock may be again used by your operations or your sales group. So that's what each of these here defines. You have your user group 1, user group 2, and user group 3, and each group will be getting access to different parts of your data warehouse, because your data warehouse will be divided into different data marts, and your your different groups will get access to only that data which they want to, or which they can get access to, correct. So this way, no group can get access to every data that is present in a data warehouse, and there's there's a little more data security in this case, okay. Same thing over here. So this group gets access only to this data and this data in this table or this mart, right, and then this user group gets access to only the data that is present in this mart and in this mart. So that's what the entire architecture looks like, and this is how the data flow is, right. So if you guys have understood this much, then you're ready to get a demonstration, correct guys? And this is also my last topic in this presentation. So right now I can go to my demonstration, and what I'll be doing in my demonstration is I'll be using talent, okay. So I'll be importing data from my database. I'll be getting it from my Oracle database, and I'll be storing that into a data warehouse, which can be ready for any kind of analysis or visualization on any other visualization tool, okay. So this act over here, which I'm going to show you, this is what powers your business intelligence, right? So let's go to the next part of my session, and this is going to be a demonstration where I'll populate a data warehouse, okay. I'll be using talent for the data warehouse activities, and let's see how we can import data from various data sources and create a data warehouse. So for our hands-on session, I'll be importing data into my talent BI, okay. Like I said earlier, I'll be using my talent BI for my data warehousing and ETL processes, and I will create a data warehouse out of using talent BI, okay. Now the data set that I'll be using is that of a 10,000 row table and a 50,000 row table, okay. So there'll be one table having 10,000 customer details, okay, and then there'll be another table having 50,000 rows of transactions which each of those customers make, okay. Now based on this data, we have to find those customers who have the lowest number of purchases, okay. So right now my data set is present in my Oracle database, okay. So I have two tables, and both my tables, customers table and my transactions table, is present in my Oracle database. I also have them in my Excel. So first let me show you how they are present in my Excel file, okay. Okay, so this is my customer table. As you can see, we have all these details, right? We have all these fields here. So we have customer ID, we have customer name, we have the address of that customer, city, the country he's from, the contact number, and his email address, right? And if I do this, then you can see that there are almost 10,000 fields here. So 10,000 rows are there here. So this means that, it's a pretty big data set, and I can use this in combination with my other table, okay. So here we have customer ID as the primary key, okay. And if I go back to my other data set, that's my transactions table, you can see that I have furthermore fields here. I have those of invoice number, I have stock code, I have description, I have quantity, I have invoice date, unit price, customer ID, and product ID, okay. So there's a customer ID over here also. So the customer ID is the primary key over there, and this is the foreign key over here. So basically the customer ID is the same, and I will have to do a lookup to that table with the help of my customer ID. Okay. Since these are two different tables, I can create my data warehouse with the help of this particular primary and foreign key concept. I can create a link, and I can probably just link these two tables with the primary key foreign key concept. Okay. So any doubts, guys? I'm sure that you all know what a primary key and a foreign key is, and if at all anybody has a problem, please let me know. Okay, so Rodney says, I don't know what's a foreign key. Okay, so see, Rodney, the thing is, we have something called as a primary key and a foreign key. Okay, and we use these two columns when we want to use a combination of two different tables, right? So if you consider the example of this one, then you can see that there are a number of columns here, and not everything is matching with the details in that, but in the other table. Okay, so only customer ID is the only common field. Okay, so there's a customer ID here, and even in this table we have a customer ID. Now the thing is, the customer ID is a primary key because it's constant and it's unique for each and every single record over here. So each and every customer here will have a separate customer ID. Okay, so no two customers will have the same customer ID. Okay, and over here the transactions here, which has the invoice number, the description of the product that was purchased, the stock code, the quantity, all these things are sorted by the customer ID. Okay. So if you find a particular customer ID more than once, then, well, here you can find the customer ID more than once. That's because a customer would have made more than one transactions. He might have, come on to their, he might have bought from the same person more than twice or thrice or four times or something like that, right? So supposing I go back to this person and I buy his products. Since it's a retail store, I buy products, say 50 times, then I'll have 50 different times my customer ID will appear here. Okay, but however here it will not appear again because it's a primary key right here. So that's the difference. So here the uniqueness is there, that's why it's called the primary key in this case, and here there's no uniqueness for the customer ID. Okay, it can appear more than once, and that's why it's a foreign key over here. And what we're going to do is, for every customer ID over here, right, so for every customer ID over here, we're going to link it to this particular table with the help of this customer ID. Since the customer ID is a common field in both the cases, I can make a table which would show which customer, which would probably display all these details along with the other columns. Okay, now that's because I have customer ID which is common in both the tables, and using that I can link the fields that are there in this table and which are there in the customers table, right? So that's what I'm going to do. Now the similar thing is also there in my Oracle database. So let me show you that. So this is my SQL developer GUI. Okay. So I have two tables here. I have customers table and I have transactions table, right? And then I have a final table, but this is not something which is relevant. So this is not something we'll be using, but we have the same two tables, customers table and transactions table. As I showed you, we have these two here, and we have almost the same fields over here, right? Because if you see the customers table, we have the customer ID, we have the customer name, we have the customer number and the email address. Okay. And here we have additionally we have the address, city and country. Now what I did is, when I imported this Excel file into my database, I ignored these three columns, right? I didn't want these details because I was not going to use them in my data warehouse. So if you see our problem statement here, it only says you have to find out the customers who have the lower number of purchases. It doesn't mention that you need their country details or city details or anything for that matter of fact. So for that reason, using the country, city and address fields would be a waste. So that's why I've not imported these into my data warehouse. I have only the customer ID, the customer name, my contact number and my email address fields. Okay, this would be sufficient to find out the customer details. Okay, and to find the purchases, right, and to see who has all the lowest purchases, we can use the other table. So in the other table, that is the transactions table, we have this quantity field, right? We have this column. This quantity table basically represents how many products this particular person purchased. So this person with this customer ID purchased 71 products, right? And then you have another person who has purchased 67 products and so on. So you also have people who purchased only 7 or 9. Okay, now our problem statement is such that we have to find those people who have made a very less number of purchases. Okay, now if we define less to be 10, then we can extract the data such that the data warehouse gets the details of only those people who have made purchases of less than 10 items per order, right? So per transaction, whoever has made less than 10 purchases, so this person has made 7, and this person has made 9, right? So we can get a list of those customers, right? Using the customer ID, we can go to that customer table and get his name. We can get his email address, his phone number, and other details. Okay, and we can publish all those things, and we can probably export them to another CSV file like this, or we can put that into our database, basically into anything which would support data visualization, right? So that's what we want, and this function is what our talent is going to do. Okay, and what I'm going to do for that purpose is I'm going to do a lookup from this table onto my customers table, right? So this is my transactions table, and from here I'm going to use the customer ID field to do lookup to my customers table to obtain their name, email address, and phone number, and all those things. So first of all, let me introduce you to our talent interface. Okay, so this was the Oracle SQL database which I showed you earlier, and this one is the talent, right? So talent open studio. This is basically the data integration version of the project. Okay, now what I'm going to do here is I'm going to show you how talent works. I'm going to show you the layout over here first of all. So on the left here, you can see that you have something called as job design, you have standard, you have demo, and then you have various other projects here, right? So all these are the different projects that I have created. Okay, and when we say job design, so job design is what you use to create your jobs on the UI here. Okay, so in our case, in talent, whatever actions that we perform, right, we got to do it with respect to a UI. So we don't have a code. This is not a coding interface. Okay, so of course this talent runs on Java, but but talent is known for its GUI. Okay, so we can drag and drop the items on the job task. So this is the job design taskbar, and we can first of all create a new task. Okay, supposing I want to create a new data warehouse by importing details from another database, then we can start by creating a new job design. Okay, and then create a new project in that job design. So right now we are in my local project, so I'm going to create a new job design. Okay, I want to say create standard job. Let's give a name to this particular job. So let's say data warehousing BI session. Okay, and demonstration is the purpose. So I'm just going to copy paste the same details into my description field also, and I'm going to say finish. Okay, now what you can see here, this is the job designer. So this is where I can get all the data from my different databases or fields, files, and get them to my data warehouse. So I can write my projects over here. And then on the right hand side, you have your palette. Okay, so from your palette, you can choose the files or the database from where you want to import your data. Okay, supposing you want to import from a flat file, then you can just go to this heading file here. So under file, you have input, right? So under input, you have all these options. So if you choose any of these options here, and if you just drag and drop them over here, then you can use them as a means to import data. You just need to set the path where the Excel file is stored. Okay, and you can choose that, and when you just enter further fields, you can get the data in from these Excel files to your data warehouse. Okay, to your talent. Okay, but Excel files is a very simple thing, and I don't want to show you that. Let me show you how to import this large data from our database, right? So we have also other options here like big data, business intelligence. We have business, we have cloud, right? So we have integrations with numerous technologies here, and what we would be concentrating now on is that of databases, right? So I have my Oracle database, so I'm going to go to Oracle under databases, and under Oracle I'm going to say T Oracle input. Okay, let's see, where is it? T Oracle input is right here, so I'm going to just click on T Oracle input and paste it here. Okay, I'm going to drag and drop it here, and now that I've done this, I can use this as a means to get my data in from my database. Okay, so this is my Oracle database, right? So let me configure my input first. So first of all, I need to configure all these details with respect to my host, the port number on which it's hosted, the database name, the username, the password, and all these things. Okay, so let me first start off from the host. It's hosted on localhost, right? It's not on any server. It's not on any remote server, so I'm just going to say localhost, and the port number is 1521. So these are details that I got when I installed this Oracle SQL server, right? So you'll have to probably enter the same details when you create one. And 1521 is actually the default port on which Oracle servers usually hosted. So you shouldn't have any problem there. So database here is XE in my case. So okay, and then my username is Vardhan, and the password is something we have to set over here. Okay, all right, now I've done this. My connection type is Oracle SSID. My database version is 11.6. All right. So all these details here are correct. Now let's check my schema. The schema is basically what is going to map your fields from your database to your talent, right? So this is your data warehouse. So we have to define a schema here to add details here. Okay, so now that we have all these fields here, now let me go back to my database, right? So we are in my customers table, and in my customers table, I have 4 fields: customer ID, customer name, customer number, and email address. So let me add these 4 fields in my talent. Okay, first column is going to be customer ID. This is going to be customer name. This is going to be customer phone number. This will be customer email address. All right, so that's all fine. Basically the data type that it's coming from is all varchar. Okay, so if you see here, the data type that is it currently is in is varchar. Okay, they have different sizes though, but email address, be it email address or contact number or name or ID, all are in varchar2 type. So I'm gonna just say the input also to be as varchar, right? So it's all varchar2. Everything is technically varchar2. It's picking up the same data type by default. All right, so let's define the length over here though. Let's say the customer ID is going to be 5 characters in length. I'm going to say the length for the name is going to be around 30. The phone number to be around technically it's 10, so let's do a buffer of another 10 and say 20. Email address is going to be another 20 characters. Okay, the customer ID, let me just increase the length to 10. So these are the length of the fields which are going to be stored. Okay, so I'm going to set the length over here, and I'm going to say okay. Now what I'm going to do is I need to set the default query. Okay, so I'm going to say select star from customers. Select star from customers. Okay, because customers is the name of the table in my Oracle database, right? So I'm going to choose the table name here. I'm going to say the table name here also. Okay, there's something I forgot earlier. You got to mention the table name that you want to import from, and you got to specify the query you want to run. Okay, now let me run the same query in my Oracle, and let's see what details I get. So I'm going to feed the same query here. Okay, so it's going to be select star from customers. So when I say this, I have this table option here. Okay, now let me just run this query. Okay, so I've got the same details in here also, right? So my table name is customers. So let me go to my talent and set that it's set as customers already, and this is the query, same query I'll be running here by default. All right, I'm going to save this. So I have set my first data in, right? So I've got my customers data in here. So let me say another T Oracle input, and I'm going to configure another input for my transactions table, right? So I have another table for transactions, so let me set that also. And as you can notice, every time you add a new input or configure a new output, then you'll have to add these details, right? You have to add the host name, database name, username, password, and all these things. So instead of this, you have a shortcut here. So you have a shortcut with respect to metadata. So metadata is something that I explained earlier, right? So it basically contains data about your data. So under metadata tab, if you see, you have DB connections, you have file, all these things, right? So if you want to create a standard input for data coming in from a particular database, then you can just set it once over here. Okay, so under DB connections, you can set one connection, and it can be used in any number of jobs in this particular project. So instead of so this time probably I'll have to anyways enter the details of this particular table. Okay, but if I set the same thing through my metadata here, then I can use the same metadata every time I want to import data to my talent warehouse. So what I'm going to do is this time let me show you how to do it through metadata. I'm going to say create connection. I'm going to say the name of the connection is DB input. All right, let's say database input. Purpose to get data from Oracle to talent. Let's have the description also, and say finish. Okay, we got to choose a database type over here. Okay, now the database type that I want to import is that of Oracle, right? And I'm going to do it with the help of Oracle with the service name. So when you choose that, you have your login, you have your password and all these details. So in place of your login, give your username here. So in my case, it's Vardhan. Okay, password is this one. The server is localhost and the port is 1521. Service name is XE. Okay, now to verify if the connection is correct, you can click on check over here. So as you can see, the DB input connection successful message has come. Okay, this means that your talent is able to successfully communicate with your Oracle, which is hosted on port number 1521. Okay, so now that I have done this, I can straight away say finish and add this metadata over here. Okay, now I'm just gonna click on the drag and drop this DB input over here. When I do that, I can choose this to be for either input or output or anything here, because under Oracle you have all these options, right? So I have chosen this metadata for any of these options here. So if I want to use it as input, I can do that also. If I want to use it as output, I can do it even at that time. So I'm going to say T Oracle input and I'm going to say OK. Now, as you can see, my DB input here, this is the metadata which has these properties already inbuilt. Okay. So in case of this one, I had to give it manually, but here my metadata, I specified it once and it's already replicated. So the advantage here is that even if there are 10 different tables from which you want to get data in, then you don't need to add 10 different database connections in your talent, right? When you're creating your metadata, if you create the database connection once, and then using that one time, you can establish 10 different connections. You can get data in from 10 different tables or replicate the same thing again and again. So that is the advantage here, right? So that's the thing. So next, let's give the table name here, okay? So the table is transactions table, right? So that's what I'm going to enter here. And the query that we have to run is select star from transactions. IONS, transactions. Okay, now let me also verify if this query is running in my SQL developer. Okay, and let me run this query. And yes, it's able to fetch data from my transactions table also. Now going back to my talent. Now that I've set this, let me go and edit my schema now. Okay, so where do I have my schema option? Okay, it's right here. So I'm going to say edit schema and I'm going to configure all the different columns and fields over here. If I'm not wrong, there are 5 different columns here: invoice number, description, quantity, customer ID, and product. Right, so I'm going to rename everything here. I'm going to say invoice number, description, quantity. What else do we have? We have customer ID and product ID, right? All right. So even the details here have been set to varchar. Okay. Now this basically means that I'm getting the data from my database, and the data type of that is varchar, right? So as you can see from here, when I click on this, all my data, all the fields are of varchar2 data type. So that's why I'm setting them as varchar2 over here, and I'm going to set the default length for everything to be as well, not for everything. So for invoice number, let me give a length of 10. For description, I'm going to give a length of 100. For quantity, let's say 5. For customer ID, it's going to be 10. And for product ID, again, let me give a length of 10. So I'm going to say OK. So my schema is basically set for both of these files. Now what I've got to do is, now I have configured 2 inputs. Now I have to get these inputs into my talent. Now to check if my data is coming in from my data sources appropriately, let me just check the tlog row, right? So the component name is tlog row, but since I can't find it here, I can also search for it here. So tlog row, when I just put enter, I have these options, right? So just capture this tlog row and drop it here. Now you can create connections from here. You can say main and you can establish a connection over here. Okay, and similarly I can use another tlog row here. Okay, drag it, I can paste it here and check. Actually no, I won't do that. So I can check if my data is coming into my tlog row from here, right? So my component is added over here. So let's say, so let's just check the schema once. So as you can see, these are the details that I had entered in my source, and it's already been mapped since I gave a connection between my tlog row and my input one. These fields have been mapped here also. So I'll be getting my customer ID, customer name, phone, and my email details here. Okay, now let me just click on OK, go down, and yeah, the field separator would be this pipeline. I'm going to say print header, print content with log4j. All right, so now let me just save this and let me run this. Now you can see the button here, right? When I say run, it would build my job basically, and it should be able to import my data from there. As you can see, all my data is being imported to this. Let me just minimize my screen. So as you can see, all my details are here, right? So customer ID, customer name, customer phone, and customer email were the 4 different fields that I had configured to enter into my tlog row from my input, and they have come. They have the headers are these, and the details are here. So for customer ID, it's 1000, and the customer name is this one here, and then his phone number is right here, right? So this is his name here, this entire row, and things like that. So each and every field here is separated by a pipeline. So that's because I had in the component editor over here, I had set the field separator to be pipeline. Okay, so that is the thing. So since my component editor has a pipeline, so every field in my data that is coming through my tlog row, it has been separated by a field separator that is pipeline. Now if I just go back here, as you can see, by just clicking on run over here or over here, you can get your output. Okay, I've just done this to show you how the data comes in. Okay, so now that our data is coming in successfully, I'm just going to delete this tlog row, okay, because we don't really need it for our demonstration. So you can just click on this clear here to clear your log screen. So now that we've established our connection, what we got to do is we've got to merge these 2 tables, right? So we've got to create a lookup field, and I've got to make sure that my tables are joined. So for that, we have another component here called tjoin, and when you hit enter, you have this, right? So under processing, you have this option of tjoin. So you can just drag and drop here, and what this would do is it would basically join these 2 different inputs. So we have the source input of this one and this one, right? So it would basically merge the 2 of them. So let's first create one link over here to my tjoin, and similarly let me create one over here from my input to my tlog. Now if you can see here, since this was the first connection that was established, this took up the name of main, okay, and my second connection took up the name of lookup. Now that's because this table here, this will look up to the customer ID field in this table and match the subsequent rows or entities with this particular columns, right? So what this lookup would do is it would use the customer ID field in my in this table, and it would do a lookup to this particular table and match the remaining rows and columns, right? So let's configure the schema for that first of all. Since we are joining these 2, we are using this tjoiner. Okay, so tjoin, let's go to the component and edit all the other details here. So we have to check this include lookup columns and output. This means that at the output that comes out of this join, we want to also include the fields which are present in my lookup field, right? So that's why I've checked this column. So besides that, here it says column mapping, right? So we have to always map these 2 different tables using one lookup field, right? So it's either one lookup field or the primary key foreign key relationship. So both are the same. So that's what we got to define here. We got to define which is the primary key, which is the foreign key, or which is the lookup field here. Okay, so first of all, let's go edit the schema here. All right, so we have the 2 different fields here. We have the input field 1 and the input field 2 over here. So let's add all of these. I'm going to say Control A, and I'm going to move it here. All right, so I'm going to join all these things, and from the second table, I'm going to move my invoice number, my description. Well, I don't want to move description, so I'm going to move my quantity. Customer ID is already there, so I would then want to move my product ID. Okay, now the reason I'm not moving description is because I don't need description. As per my problem statement, there's no need for description. Okay, similarly, even product ID is not really needed for me, so I can actually remove this also, right? So I have these, so these will basically be my output fields: my customer ID, customer name, customer phone, customer email address, invoice number, and quantity, right? So these will be my output fields. And now that I've set my schema, even the length has been auto-picked, right? So this is the nice thing about talent. Things are pretty simple and it's all straightforward. So you can just click on OK. So guys, now that we've set our schema here, let's add the columns that we want in our output from our lookup table. Okay. So this is a lookup table, and from here, what all columns do we want in our output? So that we've got to include over here, right? So let me add the different entries. So I ideally want my customer ID to be there. So I'm going to say row2 dot customer ID. Row2 here basically means this table, right? So, and then I want my quantity to come, and that I'm going to set it as row2 dot quantity. I'm going to add another entry here, and that's going to be for invoice number. Okay, so I'm going to say this is row2 dot invoice number. All right, so now that we've done our column mapping here, this is pretty good enough. Now let's go down and set our key definition. So here we set our primary key and secondary key foreign key definition. Okay, so let me add an entry here. So the primary key is going to be customer ID. In the lookup table, it's going to be row2 dot customer ID. Okay, so with the help of these two fields, we're going to do our lookup. And another advantage here is that I can also go back to schema and edit the data type of my quantity. Okay, since I'll be using quantity as my differentiator for my problem statement, I can set the data type to be something else. I can set it to be integer. Okay, so I can do this and set the length to be either 5 or 10, right? I can give OK. So now this basically means that even though all these are in string format, my quantity can be an integer. And the best part about talent is I don't need to change anything over here. Okay, so I can get the data in from any data type. The data that comes in can be of any data type. Okay, but the data that I store or the data that I finally export, that I can change the data type of that particular data. So that's the advantage. So quantity comes in the form of varchar2 data type, and I'm converting it into integer from inside talent, right? So that's the thing about advantage with talent. So I'm just going to say OK now. All right, so now that I've done this, I think I'm done everything with respect to tjoin. Okay, so now let's go back to my problem statement for a minute. Now what they say is they wish to find out only those customers who have a low number of purchases. Okay, so it is quantity which defines how many purchases that they have, right? So I'm going to go back to my talent here. Now that I've added my T login over here, I will be getting all my details and all my data into this component, right? So my input 1 would be giving me those rows from customers, and this would be giving me those rows and fields and records from my transactions table. So I would be getting approximately 50,000 rows from here and 10,000 rows from here. Now that I have all these rows over here, what I have to do is I have to filter them based on the quantity. And our problem statement here says that we have to find out those customers who have a low number of purchases. And if you remember, we defined that if you want to find the low number of purchases, it's not exactly defined. So let's say we want to find those people who have less than 10 transactions, or whose quantity is less than 10, right? Who have purchased less than 10 items. So for that, we can just go back to our data warehouse and create another filter or component here, which would filter out those people who have purchased less than 10 items per transaction, right? So for that, let's again go back to my palette here and search for this component filter. So as you can see, there is T filter row and T filter columns. Okay, but I want to filter rows, so I'm just going to drag this one and drop it here. So T log filter. Okay, and I want to connect these two, right? So I'm going to give a connection here, and what I'm going to do here is I'm going to define the filter criteria. Okay, so I'm going to add an entry here, but before that, let me go to my schema. And as you can see, I have all these entries here, and the same fields are here also, right? And even the data type has been picked up by default. That's the talents functionality. So this will be the input that will come to my filter, and this will be the output that will go, right? So let's just click on OK. And now coming to my criteria for filtering, I want to filter my quantity, right? So the input column that I want to check is that of quantity. Okay, and the function that I would want to do is empty. Now for now, let's just leave it empty, and the operator is if it's lower than or equal to, right? So if it's lower than or equal to 10, that is the value that is present in this column. If it's less than or equal to 10, then I want to filter only those rows and I want to send only them. Okay, so basically my command is also set over here. All right, so even my schema and my function is set over here, and now what I have to do is I have to set the output for my data warehouse. Okay, now where do I want to extract these results and store these this data warehouse, right? So let's say I want to store it in an Excel. Then I have to just go back to files over here. Let me just type file and hit enter, and I have these options, right? I have T file input Excel, T file output Excel. So I'm going to choose T file output Excel and drop it here. This would essentially mean that the results that are filtered over here in this component, this would come and get stored in this Excel file, which I'm going to create now. Okay, so let me connect these two also. I'm going to say filter and put it here. And supposing if I want to also get a list of all those people who have more than 10 transactions, then I can do that also by using this option of reject. So whichever rows get rejected, right, whichever get rejected from moving to this particular file, those can go to another file, right? So we have that functionality also, that I'll show you even that. But before that, so let me just show you how this looks like. So I've said row filter T file output Excel, and let me edit the component over here, and let's say the file name is this one, DWHBI demo. All right, I'm going to say include the header. So header basically is the part which would say customer ID, phone number, and all those things. So I'm going to say include header. All right, and I'm going to say define all columns to auto size. That's just to auto size those columns, right? So it's all fine now, everything is set, and my file would be saved in this particular path. Okay, and this would be the name of my file, which would be stored when I run this. So I've copied this path. Now what I've got to do is I need to save this job and execute this. Okay, when I executed that, it's showing me an error over here. Okay, so the error it shows is that the error in the components properties type mismatch cannot convert from string to integer. Okay, not a big deal. I can fix this error. Okay, we can fix that by first of all checking our schema, right? So here, if you see the schema here, it says quantity is type integer, right? But over here, quantity is still type string. So that is what we need to change. We got to change the type over here to integer. So I'm going to say number, and I'm going to click on OK. Fine. Okay, so now let's go back to this file, right? And let me edit the schema and set the properties correctly. Okay, so it's not able to convert this, right? So the type is string and the DB type is number. So this is the problem. So I can change this also to integer, right? So integer is right here. So I'm going to choose this as integer database type. I'm going to click on OK. And now let me go back to the tlog join and check the schema over here. Okay, so this is my table and quantity. This is integer. This is also integer. It's coming here, and now it will get converted over here into this. So now it shouldn't ideally throw me any error. Now let me just save this and run this job. Okay, building job. Okay, it's showing an error again. Cannot convert integer to string. Okay, so let's see what the error is now. Okay, so we have a problem here, invoice number, right? So this is the problem. So invoice number, it should be row2.invoice number. So this was the type mismatch error that we were getting, right? So no problem. Okay, so again, it's changing, right? So all right, I'm going to save this now, and we won't have the type mismatch error now. Okay, great. So it says connected and disconnected. As you can see, the output over here, we've got around these many rows from this table and about 50,000 rows from the table here, and we've got it here, and then we would have probably joined these two with the help of the customer ID field, and then to my T log row, it would have filtered all the fields. So we've got the input has basically been 8342 number of rows, 8342 rows, out of which 841 rows got filtered and stored in this Excel file. Awesome, right? So let's just go to this path and check if our field contents are correct. So this is the path where the file is stored, right? So I'm going to copy this path. I'm going to go back here and paste this path. So this was the file that we created, right? And yes, as you can see, we've got customer ID, customer name, customer phone, the email address, invoice number, and the quantity. Okay, and the best part is the quantity here is sorted, and it's only that which is less than 10, right? So that was the criteria that we had set. We had filtered for those fields to be only less than 10. And to show you further proof, what I can do is I can do this. I'll add a filter. Okay. And if you can see here, the only options here are 1 to 10. Okay, that means nobody whose quantity was 90 or 100 plus has been added over here, right? So this is how simple talent is, and this is what data warehousing is in basics, right? So this is a very simple example that I've showed you, where you can get data into your data warehouse by filtering some data from the database, and probably you can use this data to make your analysis or visualization on Tableau or QlikView or any other data visualization tool. Okay, but there was another thing that I promised you, right? I told you that you will have a filtered row and you will have another rejected row. So if this was the filtered column, then I can probably have another Excel here. I can say T file output Excel. So okay, so T file output Excel, I'm going to paste it here, and what I'm going to do is I'm going to start one. I'm going to say reject, and here. So the rejected fields or rows and columns are going to go into this particular field. Okay, so I'm going to name this also as rejected data. All right, so this is also going to be present in the same path, and let me edit the I'm going to say define all columns size. I'm going to say include header, and yep, I'm going to save this and run it again. When I run it again, I'll have the same list of fields over here, right? I'll have the same rows over here, right? So as you can see, the same 841 rows have been added to this file. Okay, the filtered results are here, and the remaining ones which were rejected, they have gone to my new file, and this file is called the rejected one. So if I go back to that same path, this was the original one, and the rejected data is here. So when I open here, you can see that the only options here are those of above 10. Okay, so if I just show you with a filter column, right? So you can see that there is nothing less than 10. So that's the thing. So that's how you filter data. That's how you get data in, and all these things. So that's how you work with talent, guys, right? So you get data in. So the same thing here, you can also store it to some database, right? So instead of having a file to Excel for this, I can just delete this, and I can just delete this, and let me go to databases first of all. All right, so here I'm going to say Oracle, and T Oracle output. Okay, I'm going to paste it here, and now if I am going to say reject, or yeah, reject, right? So all these rejected entries would go into this particular file of mine. So let me add the components and edit the components here. The host details here, it's local host. Okay, port is 1521, database is XE, right? Yes, it is XE, and my username is Vardhan. My password is Edureka. All right. So, and then you have the action on table, right? So the action is going to be create table. Okay, so when we say create table, we've got to give the table name also, and the table name, let's say rejected output. Okay, well, I'm guessing there is nothing by that name. Yep, there is nothing here by that name. So we have customers, final table, and transactions, right? So we will have a new table that will be formed over there. So it's the action is going to be insert. Supposing you want to insert or update an existing file, then you can choose the various options, but in our case it would be create a new table, and the action would be insert. Okay, so let me just save this, okay, and run this now. So it seems like my new table has been created here. Let me just go back to my SQL here, Oracle table, and we need to refresh this. Yes, so as you can see, there's a new table that's been created, and when you see here, these are the different fields. Error message was another field that gets auto generated, and if you look at the contents of the field, you have all these, right? So guys, that's how you get your data back into your database, right? So earlier I showed you how to do it and store it in an Excel file. Now I've showed you how to create a new table and how to get your data warehouse data back into your database. So that's the end of my demonstration. All my queries have been passed successfully. Now let me just quickly go back to my slides for a minute. And yeah, this hands-on is what I completed. Showed you how to get data into your data warehouse.
Here's a simple question for you guys. Which component is essential for integrating and storing data from different sources in a BI system? Your options are A. Data warehouse, B. Web server, C. Mobile app, or D. Antivirus software. If you know the correct answer, please comment down below. We just learned about data warehousing in BI. Now, let's explore data warehouse concepts, where you will understand the architecture and components of a data warehouse.
The data warehousing concepts. Now let's understand the various concepts revolving around data warehousing, like OLAP, dimensions, facts, and schemas. So first of all, let me give you a brief about OLAP again. Let's go into details here. As it says, OLAP is a flexible way for you to make complicated analysis of multi-dimensional data. Okay, so when we say multi-dimensional data, then whatever data is stored in a data warehouse, it has multiple views, right? So they will all be stored in such a way that you can perform analysis. They'll be stored, all the different tables will be linked with each other, right? So there'll be different views, there'll be different categories of data, and all these things, to perform analysis, then you use the OLAP activities, right? So the OLAP queries you run on that data. And whatever data is stored in a data warehouse, that's called multidimensional data. And the very act of storing it is in the form of OLAP cubes, right? So you have OLTP on one side and you have OLAP on the other side. So as you can see this line, it says OLTP systems use data stored in the form of two-dimensional tables. Okay, an example of this would be any Excel. So you will have your rows and you will have your columns here. Okay, you'll have your rows and columns and you'll have your data stored over here. So this is your OLTP systems, and any queries you can run on them, and you can do all these things. Okay, but the difference with the OLAP is they'll be stored in the form of OLAP cubes, right? So there'll be multiple dimensions, there'll be multiple views that you can get of the same data with respect to the year, with respect to the number of sales, with respect to the different products. All these things you can get a single view of all these things. So as you can see, this diagram is more of a 3D view, right? So that's what OLAP here stands for. So we call it OLAP cubes. And whatever data that is stored inside your data warehouse, and whichever data you access with the help of OLAP activities, then that data is called as multi-dimensional data. So that's what the whole line here is all about, right? So your data basically is converted into a multi-dimensional form, and that particular data, to access that data, you use OLAP queries, and yeah, it'll be stored in such OLAP cubes, right? So these are the three different things. And the next point, it says data warehousing is modeled on the concept of OLAP. Yeah, this is again, this is what I told you, right? So whatever data is stored inside a data warehouse is basically stored in a multi-dimensional form, and it's stored in the form of cubes. And to run your queries on your cubes, you run OLAP queries, right? So that's why the entire process is called OLAP cubes, and processing multi-dimensional data on your OLAP cubes, right? Now that's what a data warehouse is. But with your database, however, are modeled on the concept of OLTP, right? Online transaction processing. So your databases are modeled on the concept of OLTP, and your data warehouse is modeled on the concept of OLAP. All right, so that's the key difference between the two, the basis on which these two are modeled. And your OLTP systems use data stored in the form of two-dimensional tables with rows and columns, and your OLAP will have multiple views, right? So your OLAP cubes and cuboids. So the OLAP is stored in that kind of a structure, but whereas your OLTP, here you just have your x-axis or y-axis or your two-dimensional data. right? So that's the thing about OLTP, and yeah, that's the difference between the two. And well, the advantages of OLAP over OLTP are, first of all, that when you can see data from multiple angles, right, from different angles, from different views, from different dimensions, then you will get new ideas, right? So you'll get new insights, you can think of different things, and your whole job of making analysis and getting insights will become simpler. It'll become easier with the help of OLAP activities, right? Because it supports activities like filtering and sorting of data. So maybe filtering and sorting of data may be possible even inside OLTP, okay, but there's a limit on that. So if when you have data stored in multiple tables, then you cannot do filtering and sorting of data, right? Now that is the advantage with a data warehouse. So even if you have data stored in multiple tables, you might have 4 different tables or 5 different tables, and you will have like thousands and millions of rows and transactions that will be stored in those tables, okay? In spite of all these things, you can perform filtering and sorting operations, or any mathematical operations like calculating, all these things, okay? You can do all these things and get the output inside one single new table. So that is the difference between OLAP and OLTP, right? All such activities cannot be supported on OLTP. And yeah, so it finally says that data can be refined. So when you can perform such kind of analysis, when your data looks much simpler for you to read, right? When you can gain some information out of your raw data, then we call it refined data. So that's the other advantage of OLAP. That's the other advantage that OLAP has over OLTP. So that's the thing about online analytical processing, right? So now I've spoken about these things. Now let's go to the next slide. So first of all, in OLAP itself, there are 3 different types of cubes, okay? So the first one is MOLAP, ROLAP, and HOLAP, okay? So we also call it MOLAP or MOLAP. So this stands for multi-dimensional online analytical processing. ROLAP stands for relational online analytical processing, and HOLAP stands for hybrid online analytical processing. All right. So guys, the whole topic here is OLAP cubes, right? So your OLAP cubes is where your data will be stored, okay? Now the analysis that you'll do, the kind of queries that you'll run, they will all be OLAP queries, and they will all be on the multidimensional data, okay? So the data that's going to be stored inside your cubes is going to be multidimensional data, okay? But your multidimensional data, where are they going to get stored, okay? So that is the whole topic here. So there are 3 different types of places where you can store your multidimensional data, okay? So they are 3 different types of OLAP cubes. So the first type is multidimensional OLAP cube. Okay, when we say multidimensional OLAP cube, then this is the default type of OLAP cube. So here MOLAP is a form of OLAP that processes and stores data directly into a multidimensional database. So you have a multidimensional cube, and then your data will be stored inside that particular database. Now the advantage here is that it will give you excellent performance, and it can perform complex calculations, okay? But the problem is only limited amount of data can be handled in your MOLAP, okay? But then there's a difference between MOLAP and OLAP, okay? Now that's where ROLAP scores over MOLAP. So ROLAP stands for Relational Online Analytical Processing. Now ROLAP is a form of OLAP that performs dynamic, multidimensional analysis of data stored in a relational database rather than in a multidimensional database. Now what this means is that in your MOLAP, you have your multidimensional data. You'll be storing it inside a multidimensional database, right? So this will be your OLAP cubes, okay? So what that means is you have your data that will be stored inside a multidimensional database, okay? Thus making it a multidimensional data, and that is one type of OLAP, that is multidimensional OLAP. But relational OLAP is getting that multidimensional data, converting it into a relational data, and then storing it inside a relational database, right? So that's what it says here. It's a process of storing data in a relational database. So in your ROLAP, you will have your multidimensional data stored inside your relational database, and then you will be running multidimensional analysis and multidimensional queries on a relational database. So that is the difference, right? So your queries that you'll be running, your data is basically going to be multidimensional, all right? Even your queries that you'll be running will be the same. It'll be OLAP queries, okay? But the difference is the place where it's stored. The data in case of a ROLAP is stored in a relational database, okay? But whereas in case of a multidimensional OLAP, it is stored inside a multidimensional database itself. Now that is different between the two. And speaking of the advantage and why ROLAP can be used instead of MOLAP is because a greater amount of data can be processed in this case, all right? But in case of MOLAP, only limited amount of data can be handled at any point of time. But however, the problem is it requires more processing time and a lot of disk space. Now it needs more processing time because you are going to convert your multidimensional data into a relational data, and once you've converted that, you have to then store it inside a relational database. Now this is certainly more time consuming than your multidimensional OLAP, right? So that is one disadvantage with your relational OLAP. And also your amount of disk space that will be occupied because of all these processes is going to be greater. Now that's the disadvantage, but of course that comes with the benefit, right? So you're getting something out of using this. So that's the difference between multidimensional OLAP and relational OLAP. And then these are the two basic differences. And then you have a third one that's called as a hybrid OLAP, right? So your hybrid OLAP is basically a combination of both your MOLAP and your ROLAP. So the positives and your advantages of both is used in your hybrid OLAP. So the advantage with HOLAP is that HOLAP can drill through from the cube into the underlying relational data, right? So what it means is you will have your cube here and you will have the underlying relational data, right? So using HOLAP, you can drill through into the relational data using your cube. So that's the thing about HOLAP, which makes use of the best features of both your multidimensional OLAP and your relational OLAP, right? So these are the three different types of OLAP cubes. So this is again one important question that you'll be asked in any job interviews, right? So if you guys are appearing for any job interviews, then you have to know the difference between these three cubes, because your work will primarily be revolving around these three aspects. So the next topic that we have for today is that of OLAP operations. All right. So we have 5 different operations, and they are roll up, drill down, slice, dice, and pivot. Okay, so these are the 5 different OLAP operations that we can do on our OLAP multidimensional data, right? So going to our first operation, that is roll up. Now, before I explain this, let me tell you why I'm explaining operations first of all. So I'm explaining OLAP operations so that you can understand what are the kind of operations that you can do on your data warehousing and things that you cannot do on your database, right? So with the help of OLAP, and since data is stored in such a multidimensional fashion, these kind of operations can be performed. Right. So first of all, let's get started with our roll-up operation. So let's read the definition first. So roll-up is something that forms the aggregation or data cube by either climbing up a concept hierarchy for a dimension or for a dimension reduction. Okay, so when we say climbing up a concept hierarchy for a dimension, it basically means you'll have a particular dimension here, right? So in this case, we have the dimension of cities. So we have 4 different cities. We have Chicago, New York, Toronto, and Vancouver. Okay. Now, supposing you want to go to the next hierarchy in this dimension. Okay. You want to add a couple of attributes here and more to the next dimension of countries. Then you can do that. So if you look at this example, here we have converted this dimension, which is in the form of cities, to countries. So USA is a country which has Chicago and New York as cities, and Canada is a country which has Toronto and Vancouver as cities. So we have converted this dimension into the city dimension of that is present in this cube into country dimension, right? So this is the kind of operation that we've done. So we've done that using a roll-up operation, right? So that's the thing. And let me first explain this concept here, this example. So first of all, we have this cube here, and we have different axes, right? We have x-axis, we have y-axis, and we have z-axis. So these are x-axis where we have stored the different items, right? So the different types of products that are there for sale. So we have mobiles, modems, phone, and security, right? So this is the 4 different items that are there for sale. And then we have the time at which the sales were done, like different quarters of a year, Q1, Q2, Q3, and Q4, right? And then we have the different cities, Chicago, New York, Toronto, and Vancouver. So this is the z-axis, y-axis, and this is the x-axis. Now, when we say we are doing a roll-up here, roll-up operation, we are basically converting this dimension into a different dimension with a different set of attributes, right? We are changing this whole dimension. So in this dimension right now, we have these 2 cities part of from USA and these 2 cities from Canada. So we are doing a roll-up such that we are doing a roll-up on location and converting the cities into countries. So if you look at this here, we are aggregating these 2 attributes, right? So these 2 different attributes together and these 2 attributes together. So when you do the roll up and when you convert this dimension, then what you get is for USA, you have the total number of sales as 2000, okay? Because it is the aggregate of New York and Chicago. So 440 plus 1560. But whereas for Canada, it's 395 because only Toronto adds to this and there is nil from Vancouver. All right, so that's what we say when we are doing a roll up. So we are doing a roll up on the items based on any particular dimension, right? So this dimension, we aggregated a part of this dimension, and we converted this dimension from cities to countries. So this is the kind of operations that you can do on the set of attributes that will be present inside your dimensions. So that's about the roll up. Okay, now the next operation that I want to talk about is that of drill down. Now drill down is something that is just the reverse of roll up. So what we did in rollup was we aggregated a set of attributes, right? So let's break down the entire attribute into smaller attributes. All right. So we can do that by either stepping down a concept hierarchy for a dimension, okay, and by also introducing a new dimension. So if you look at this example, it's a similar cube where we have similar details, where we have details for the quarter 1. We have the 4 different details. And basically the dimensions are the same, right? So we have the items or types for sale, we have the different time and the different cities. Okay, but when you look at this diagram, what we've done is when you say drill down, we've done a drill down operation on the time. So the time here, right, the time dimension, we have represented each of them by quarters. So quarter 1, quarter 2, quarter 3, and quarter 4. But the thing is, each quarter can be further broken down into different months. So in quarter 1, you'll have January, February, and March, right? So what we've done with the help of our drill down operation is we've broken down this quarter 1 into the different months respectively. So if you look at this one here, if you look at the security that has been sold 400 in quarter 1, then if you look at that, then that's been divided into 3 different months, right? So in January, February, and March, and how many products have been sold in each of those 3 different months. So this is the kind of example, right? So we've done a drill down on the time. So here it was in the form of a quarter, and we've drilled down this whole particular attribute into 3 different attributes, 3 further attributes, right, into months. And similarly, we have 3 other entries here, and each of those would be divided into different attributes. So instead of 4 different attributes here, we have 12 attributes, where each of these attributes have been further divided into 3 attributes, summing it up to 12 in total. So that's the thing. So that's the difference between a roll up and a drill down. So let me go back to the previous slide for a minute. So in this case, what we did is we aggregated these attributes and we reduced the number of attributes in that dimension, right? So we converted them from 4 number of attributes in the form of cities to 2, and those being countries. So 2 attributes in this dimension, all right? So in this particular dimension, we have 4 different attributes, and we've increased that to 12 different attributes by adding 3 attributes to each and every single attribute here, right? So that's the thing that we can do with dimensions. So that's the next operation that we can do on dimensions, right? So that is the difference between roll up and drill down. All right, guys. So the next OLAP operation that I'm going to talk about is that of slice operation, right? So the slice operation provides a new subcube from one particular dimension in a given cube. Now what this means is, in any cube of ours, we'll have 3 different dimensions, right? So we have our z-axis here, we have our y-axis, and we have our x-axis. So 3 different dimensions here. And what the slice operation means is, with the help of 3 different dimensions, we can use one of the dimensions and break it down into a 2-dimensional cube, right? So if you look at this example here we have only our y-axis and we have our x-axis, right? So the z-axis is missing. Now what we've done is we've taken the time and we've done a slice of the time. So we've done a slice for only quarter 1. So here we have different representations for different quarters, for quarter 1, quarter 2, quarter 3, and quarter 4. Now the data that is displayed here is with respect to only the quarter 1. And since we've drilled down into the quarter, and since we've taken time as reference, we've replaced the time dimension here with the location dimension, right? So this comes to the y-axis, and the whole representation here is only with respect to Q1, right? So that's what you mean with respect to slice. So you slice one particular dimension, and you get into the details of that particular dimension with respect to the other dimensions. So that's the slice operation. And then moving on to the next slide, we have our dice. Right, so the dice operation provides a new subcube from 2 or more dimensions in a given cube. Right, so in the earlier example, we saw we saw slice, right? So slice, what it does is it gives us a new subcube from one by using one particular dimension in a given cube. Okay, but the dice here, it gives us a new subcube from 2 or more dimensions in a given cube. So if you look at this example again, we have the location dimension, we have the time dimension, and we have our items dimension here. Correct? And what we're doing here is we're using the dice for a location. Okay, so we have 4 different cities. So we are dicing only for this location of Toronto and Vancouver, right? So because we are dicing only for Toronto and Vancouver, in our final cube, we have only Toronto and Vancouver here, correct? And then we are also slicing the time here. So we are doing a dice operation on the time with respect to Q1 or Q2. So we are only delving into the details of Q1 and Q2 here. And again, the item is the third dimension which we are dicing, and we are dicing it for mobile or modem. So here we have mobile, modem, phone, and security, right? So these two are ignored, and we are dicing the item only for mobile and modem. So here, if you see the x-axis, we have only mobile and modem, and after the dice, the y-axis has only Q1 and Q2, and the z-axis has only Toronto and Vancouver. So that is the 3 different dimensions that have been diced, right? So if you're going to get a new subcube by making use of 2 or more number of dimensions in your cube, then it's called the dice operation. But however, if you're getting a new subcube from your existing cube by slicing only one particular dimension, then it's called slice operation. So that is the difference between slice and dice. Okay, so we have the difference between roll up and drill down. Then you know the difference between slice and dice, right? So that's the difference between these two. And then finally, we have one operation called as pivot operation. So the pivot operation is also known as the rotation operation. Okay, it basically transposes both the axes, whether it's the x and y axis. It transposes them in order to provide an alternative presentation of data. Now, if you look at this example here, we have the location dimension on the y-axis and we have the item dimension on the x-axis, right? Now these two are transposed. Now that's what a pivot does. So when you transpose them, your item comes here and your location, it comes over here. Your location dimensions here and your item dimension is here, right? So even your data corresponding to them are transposed. So I hope you guys got the whole the concept of operations, right? So the 5 different operations which can be done with the help of OLAP data warehouse. So I hope you guys got the entire concept here, right? So the kind of operations that you can do using your OLAP activities, right, on your data warehouse. So that's the thing here, right? So these were the 5 different OLAP operations. And moving on to the next slide. So the next topic that I'm going to talk about is that of dimensions. All right. So the tables that describe the dimensions involved are called dimension tables. So first of all, to give you an example of what a dimension is, in database, you have something called as tables, right? So you have different tables which will be a part of your database. Now, similar to tables, we have something called as dimensions in a data warehouse. So we have dimension tables which will have a set of attributes. So our customer dimension will have the customer details like the customer's ID, the customer name, and the customer address. Okay, and your product dimension will have other set of attributes like your product ID, product name, and your product type. And similarly, you will have a date dimension which will have the order date, the shipment date, and delivery date, right? So each of these dimensions here, they talk about a different aspect of your entire data warehouse. So your data warehouse may be one for in this example, it is that of e-commerce company, right? And as you can see here, it says the e-commerce company here, this is the subject, and the dimensions are these, and these are the attributes, right? So first of all, why would we need dimensions? Why should we use dimensions, right? So we go to the trouble of having different dimensions inside our data warehouse. Similar to having tables in our database, we have different dimensions in our data warehouse. Why should we have all these things? You can have that kind of a question. Now, the answer to that is dividing your entire data warehouse project into dimensions provides structured information for analysis and reporting, right? So when you break down your entire data warehouse into different dimensions, like for your customer details, you'll have a separate dimension called as customer dimension. For your product details, you can have a separate dimension called product dimension. And similarly, for other things, you can have other different dimensions. And when you break it down in a structured form like this, your analysis and reporting can be very easier. Why? Because when you store data, it will be in this form, right? So you will have your customer here, you will have your customer ID, the name, address, and the product that particular person purchased, the name of the product, the ID of that product, the type of the product, and then the date as to when it was ordered, when was it shipped, and when was the delivery completed. So you have all these details in a structured format. So that's what the benefit that dimensions and data warehouse gives us, right? So end users can simply fire queries on this dimension tables which contain descriptive information. So you will be here as an end user, and you can just fire your simple queries on your data warehouse, and you will get the answer that you need. So that's what is the use of having dimensions, and that's the benefit, right? So any doubts here, guys? That's about the dimensions, and that's why we should have different dimensions in our data warehouse project. All right. So moving on to the next slide. So the next topic that we have here is that of facts and measures. All right. Now, in the previous slide, I spoke about dimensions, right? So we spoke about there being different dimensions in our data warehouse, and then we being able to sort them, filter them up using different queries, right? Now, how do you think you can run your queries and result? Because by the look of this table, you might not be able to get an idea of what kind of dimensions here to filter or which kind of dimensions here to sort. So you have that kind of doubt, right? So that's where the whole concept of facts comes into picture, facts and measures. So fact is something that helps you measure your dimensions. So what it does, let's look at the definition first. A fact is a measure that can be summed, averaged, or manipulated. Okay, and every fact table, it contains two kinds of data, a dimension key and a measure. All right, now what this means is you will have all your dimensions in your data warehouse, but if you want to perform any kind of query like any sorting or analysis or some kind of drill down or all these things, you can only do it if you have a fact. So for every dimension, you will have an associated fact, and using the fact, you can measure your dimensions. Okay, so that's what it says here. If you want to measure the data that you have in your data warehouse, if you want to measure any kind of data that is there, then you use the fact to measure your dimensions. And that is the reason why your fact table will have two kinds of data. It will have a dimension key, which will basically be the link to your dimension table, and then it'll have a measure. So your measure is something that's going to calculate the data that is there in your dimension, right? So the dimension key is going to let you connect to your dimension and the whatever data that you get from there. So whether it's any kind of addition or subtraction or any kind of average that you're going to take, or the summing or manipulation. So whatever arithmetic operation that you perform, that will be stored as a measure in your fact table, right? So that is the relation. So it will have one particular dimension key which will connect to the dimension, and the results from here, whatever the aggregates or whatever the operations performed, the results of that will be stored as a measure. So that's the thing. All right. And it also says every dimension table is linked to a fact table. Yes. Now that's the thing. Now if you want to perform any kind of query or analysis on any dimension, then you need a fact table. That's what we are talking about in the final line here. It is only if you have a fact table can you perform any kind of queries or analysis, right? So that's the thing. And it's also a rule that for every dimension table you have to have a fact table. So you cannot have any dimension table in your data warehouse without a fact table. And that is what is the whole process that leads us to having a lot of flexibility with respect to querying and analysis and all these things, right? So take this example. In your fact table, you will have one product dimension, and then that will have a dimension key and a measure, right? So your dimension key would be that of product ID, and your measure would be that of the number of units sold, right? So your product can be your fact table, and your dimension key might be that of product ID. So you'll have all the different products that you have in your repository. And if you want to find the number of units sold, then you can perform any kind of arithmetic operation there, and measure of that will be stored over here as the number of units sold. So that is the fact table. So that's the whole concept here, right, of facts and measures. All right. So moving on to the next slide, we have that of schemas. Okay. So if you remember what we spoke about here, right, of about dimensions, facts, and measures. So these are the important topics that will help you understand the whole concept of schemas. So getting back to schemas, a schema is basically that which gives the logical description of your entire database. Okay, it gives details about the constraints placed on the tables, key values present, and how the key values are linked between the different tables. Now what this means is you have different dimensions, or if you take the example of a database, you'll have different tables, right? So you'll have multiple tables, you'll have an employee table, you'll have a department table, and how do you link them? By using the whole primary key foreign key relationship, right? So that's the example that's showed over here. So you have one table here that is of employee table, and the other one is that of department table, and in your employee table you have a department ID which acts as the foreign key, right? And then you have your department table where department ID is the primary key, and you use the department ID to do any lookups, correct? So that's the whole concept of schemas here in a database. But whereas in a data warehouse, we follow a similar model of primary key and foreign key, okay? But we don't use the entity relationship model here. However, we use the star schema, the snowflake schema, and the fact constellation schema, right? So these are the three different schemas that you use to establish relationships. All right. So that's what a schema is. I'm pretty sure you all know what a schema is, right? So you guys should all have a good idea of what a schema is and what it does. But anyways, talking about the different types of schemas that you have in your data warehouse. And a couple of slides earlier, I told you that every dimension table will have a fact table, right? So that's what this diagram also symbolizes. So if I can recall, then over here I told you that a fact table contains two kinds of data, a dimension key and a measure. All right. And I told you that every dimension over here is supposed to have a fact table. It's supposed to be linked to a fact table, and it would be linked with the help of schemas. Okay. So that is the relationship between dimensions and facts. Okay. Measures is something that is going to aggregate the data that is present in your dimensions, and it will store it again in the fact table. Okay. But the fact table and the dimension table will be linked with the help of your schemas. And your schemas, if you talk about schemas in the concept of database, then it would be an entity relationship schema, right? Based on that entity relationship model, they will be linked, right? So that will be the relationship. But in case of a data warehouse, they will be using three different types of schemas, like star schema or snowflake schema or fact constellation schema. So let's just talk about these schemas and how the primary key foreign key relationship works over here, okay, in these three different schemas. So the first one is the star schema, and in our star schema, each dimension here in a star schema is represented with a one-dimensional table which contains a set of attributes. Okay, so when we say a one-dimension table, it basically means that there will be a primary key foreign key relationship between the fact and the dimension table only. Okay, so you'll have your primary key in your dimension tables, and you will have the associated foreign key in your fact table. Okay, so if you look at the example of dealer, okay, this is a dimension table and the dealer ID is a primary key. Okay, and in the fact table you have the dealer ID, which is the foreign key. Now similarly for your date dimension table, then the date ID, right, this is the primary key and this is the foreign key here. And for your product dimension table, model ID is the primary key, and here model ID is the foreign key. Okay, and similarly for the branch dimension table, you have your branch ID, which is the primary key over here and which is the foreign key over here. Now when we say primary key foreign key, it basically means your dimension table can have only one entry. So each of your primary keys, so whether in this case if it's your dealer ID, then each dealer can have only one ID, right? And there can be only one date. There can be only one entry for a particular date. You cannot have multiple entries for the same date. And similarly, you cannot have multiple products with the same ID, right? So you cannot have multiple products with the same model ID. And if you look at this example, you cannot have different branches. Supposing there are 3 different branches, then they should have different IDs, right? So they cannot have the same ID. So that's why we say that the primary keys, they cannot have duplicate values, right? So the primary key over here is branch ID, which cannot have duplicate values. The primary key here is model ID, which cannot have duplicate values, and here it's date ID, and here it's dealer ID, right? So these are the primary keys in the 4 different dimension tables, which cannot have duplicate values. But however, in a fact table, you can have duplicate values, right? Because you'll be making use of the foreign key. So using the foreign key, you will be referencing to the dimension table. You'll be looking up to the dimension table, and because of that, you can have duplicate values. There's no restriction on not having duplicate values, right? So we have a foreign key relating to all the 4 of our tables, and those are the 4 different dimension keys that we have. And along with that, we have 2 different measures, right? So units sold and revenue are the 2 different measures. So revenue, we use revenue to find the total number of products that we have sold. So we'll have a product ID, we'll have the name, model ID, and variant ID, right? So each of those products, how many have we sold? So all those things will be part of our revenue. And the same thing with units sold. So each and every product that we've sold, the number of those products will be present here, and the money that we've made out of selling those products will be present in our revenue, right? So that is the whole concept of measures here. Okay, so let me just go back to this slide here. As you can see, a fact table contains 2 kinds of data, a dimension key and a measure, correct? A dimension key and a measure. A dimension key is basically the foreign key here, which will be referencing to the primary key in your dimension table. So that is your dimension key, and your measure is basically the calculation or the arithmetic value that will be stored based on the operation that is performed on your dimensions. So that's what has been explained in this slide, right? So you have your units sold and you have your revenue, correct? So these 2 will be your measures, and these 4 will be your 4 different dimension keys for 4 different tables. So that's about your star schema. So if you understand your star schema, then it will be easier to understand the other schemas, because They are just a slight variation, okay? But what you got to understand is the main thing is that every dimension table will be linked to the fact table, correct? So that is the one thing which you have to remember. And talking about the next point, a fact table is at the center, correct? So the fact table is at the center. It contains keys to every dimension table and attributes, all right? So it has the keys to every different dimension table, and it has attributes like units sold, and it has revenue as the other measure, correct? So that's the thing about the star schema. That's how this works. Now, going to the next slide, we have something called as snowflake schema, okay? Now, it's just a slightly modified version of your star schema. When we say modified, in technical terms, we call it normalized, okay? And when we say normalized, it means split into additional tables. So if you have one table which is having a lot of attributes, then we can break down this table into further tables. So that's what is happening over here. So if you look at this table, you have your fact table, okay? Over here in a star schema, you had only your dimension table, and you had your country ID, you had your location ID, you had all these details, okay? But inside your snowflake schema, you have split this dealer table into two further tables. One is with respect to location, and the other is with respect to country, right? So you have your location ID foreign key and your country ID foreign key over here, and they will be referenced to your location ID primary key in your location table, okay? And to your country ID primary key in your country table, right? So that's how things work. So since your table is being normalized or split into additional tables, it's called the snowflake schema, correct? The same thing is done here, right? So you have something called as variant ID, which is again a foreign key, and that is reference to the primary key, which is inside the variant table, correct? As you can see, so these four were the dimension tables that were present in the star schema. And if you normalize these tables or this data warehouse further, then you'll get your snowflake schema, right? So it's further normalized into additional tables. So that's what the difference between a star schema and a snowflake schema is, all right? So I hope there are no doubts, guys. If there are any doubts, please put that in the chat box, all right? So that's the thing about a snowflake schema. And then now we have one more type of schema called as galaxy schema, okay? It's also called as the fact constellation schema. And the concept here is that the galaxy schema contains more than one fact table, okay? Now we saw star and snowflake, right? So here it had a single fact table, but the number of dimension tables were different, right? We had additional dimension tables, and there were additional dimension tables which are normalized in case of our snowflake schema. But in case of our galaxy schema, where you have two fact tables, right? So you have two fact tables, and you have your dimension tables such that some dimension tables can have more than one fact table, okay? So if you take the example of our branch dimension and your date dimension, so these two tables have two fact tables. They both have the fact table of revenue and the fact table of product, okay? But however, the product dimension table here, okay, this one has only one fact table, that is product, and the dealer dimension table here has only one fact table, that is revenue, correct? So to help you understand this in a simpler fashion, I've broken down this product into another dimension table, right? So earlier we had one product table here, and here we've broken down this product table into further product with respect to product ID, correct? So that's the whole concept here. If you have more than one fact table, then it's called a galaxy schema. So this would probably help you understand, correct? So the revenue and product are the two fact tables, and the dimensions which are shared are called confirmed dimensions. So that means these two dimensions which are shared by more than one fact table, these two are called confirmed dimensions, correct? So that's the whole concept of galaxy schema. So guys, any doubts? Okay, so guys, that was about the galaxy schema, all right? And those are the three different schemas that you can have in your data warehouse, all right? So if you're going to work on a data warehouse anytime in your future, then you can formulate your whole organization's data inside a data warehouse by using any of these schemas, okay? They are either a star, snowflake, or galaxy schemas. So that's it about the schemas.
In our previous module, we covered data warehouse concepts. Next, we will start with Excel tutorial for beginners, where you will learn the basics of Excel and how to navigate its interface.
So let's get started with Excel interface. So you can get started with Excel using Google Sheets or the Excel desktop app, which is included with the Microsoft Office subscription. So the version of Excel that I'm going to use in this tutorial is Excel 2016. So here, let's click on New. If we click on this blank workbook, a new workbook will appear. And below are some templates that will make your work easier. You can search for templates here as well. Okay, so now let's create a blank workbook. So now a sheet appears. Okay, this is a sheet in Excel. So a sheet refers to a single tab within a workbook where you can input and organize data. A workbook can contain multiple sheets, each identified by a tab at the bottom of the Excel window. So we can rename the sheet by double clicking. So let's rename it as sales revenue. Okay, we are going to work with sales data. So I've just renamed the sheet. So now let's explore the different sections of this workbook. So this section at the top is called the Quick Access Toolbar. So the Quick Access Toolbar in Microsoft Excel is a customizable toolbar that provides easy access to frequently used commands and tools. You can customize the toolbar according to your needs. So here you can click on this and customize the toolbar. You can click on whichever option you want to appear in the Quick Access Toolbar. So if I click on spelling, spelling appears in the toolbar. So below the Quick Access Toolbar, we can see tabs such as File, Home, Insert, Page Layout, etc. So each tab has specific functions, and when we click on a tab, a ribbon appears. Okay, so this is the ribbon bar. Ribbon refers to the top section of the Excel window that contains tabs, groups and commands for performing various tasks and accessing different features and functionalities. So ribbon consists of different groups. Okay, so this is a clipboard group, this is a font group, and this is an alignment group. Okay, each have different functions. And at the bottom, we have a slider function to zoom the worksheet. So I've zoomed the worksheet. And now we can also see multiple rectangles in this sheet, right? So these are called cells. So a cell refers to the intersection of a row and a column within a worksheet. Each cell is identified by a unique reference called a cell address. Okay, cell address is basically the combination of column letter and the row number. For example, cell at the intersection of column B and row 3 is B3. So you can see the reference number. Cell address is B3 here. Okay. So if we select multiple cells, it is called a range. Okay. So if you click on tab, it will go to the next column. And if you click enter, it will go to the next row. So now let's add some data to the Excel sheet. So let's create a sales report. Let's create columns and name them. So I'll create a column and name it product ID. The second column is product name. The third column is units sold. And the next column is price. Okay. And then we'll add revenue. Alright. So let's add the product IDs. 5. And let's add product name A, B, C. Okay. And let units sold be 100. So these are just random numbers that I'm applying. And let's just add price for each unit sold. Yeah. So now you can see that the column product name is not completely visible. So first let's add the spacing. So let's just, so we can adjust it like this. Okay. But there is another option. You can click on this button here. So it will select the entire sheet and click on the line that separates two columns and double click on it. So space is adjusted automatically according to the data entered. So if you want to insert a column before product name, select the column product name and right click and click on insert. Yeah, so you can see that a column appeared. In the same way, if you want to create a row, click on the row and insert. Okay, a row is created at the top. So now let's just delete whatever we created right now. So right click and delete, because we don't want the row and column that we created, right? So delete. Now let's do some calculations for the data that we have created. So here what we'll do is we need to calculate the revenue column. So we'll calculate it using units sold and price. It's nothing but the multiplication of units sold and price. So here let's use a simple formula. So formula is a mathematical expression used to perform calculations, manipulate data or automate tasks within a spreadsheet. Formulas in Excel always start with an equal sign followed by the expression that you want to evaluate. So let's put an equal sign here. Then whatever we type in the cell can be seen in this formula bar. Okay, so equal units sold into the price. Okay, and press enter. So if you want to apply the same formula to the below rows, either you can click on this plus sign, double click, or you can also drag them down. So the same formula will be applied to all the rows. So here we have used an operator to calculate revenue, right? We have used the multiplication operator. So apart from multiplication, Excel supports various operators such as addition, subtraction, division, exponentiation and concatenation. Okay, so now let's calculate the same revenue in this column using a function. So Excel provides numerous built-in functions to perform specific calculations or tasks. Examples of functions include sum, average, if, VLOOKUP, etc. So here we'll use a function called product to calculate revenue. So is equal to product. So this is the function. Number product, number 1 is the units sold, comma, the price. We'll close the bracket. So we can see that we got the same answer using the operator and sum. Alright, so now let's just delete this. So now let's calculate the grand total for the columns units sold, price and revenue. Okay, so to calculate the grand total, there are 3 ways you can calculate. So first is using an operator. So op is equal to, either you can add everything using operator plus 54 plus 2 plus 45 plus 12. Okay, this is one way to calculate the sum. Okay, next I'll teach you another way, that is using function. So to calculate sum, we have a function sum, double click and select the range of the cells and close the bracket. Okay, this is the second way to calculate sum. Apart from that, we also have auto sum. Okay, so here we have a function called auto sum, which will automatically calculate the sum of the column. Alright, now let's just drag this the same way so that the sum of price and revenue is also added. Yeah, now let's add a new column and name it product category. So let's click here and insert a new column. Okay, we'll name it as product category. Okay, so let's name it food, stationery. Let this be stationery, then we have food and clothing. So these are the product categories that we have added. Now what we'll do is, let's analyze sales trends by category. Let's add the name. Okay, here we'll add the product category and here the total revenue. So let's calculate the total revenue according to categories. Let's adjust the space. Okay, so first category is food. Let's paste it here. Second, we have stationery. Paste it here. Then we have clothing. So these are the 3 categories. So we'll calculate the total revenue. How do we do that? We'll do that using the SUMIF function. Okay, is equal to sum if. So the first argument is range. Okay, we'll select the range, that is the product category, comma the criteria. So food is the criteria. Okay, if product category is food, then we need to sum the revenue, right? Comma the sum range is the revenue. All right. Now let's just close the bracket. Yeah. So this is the total revenue for food. So I'm just double clicking here. Yeah. So we got the total revenue for stationery as well as clothing. So now we can see the revenue based on categories. Okay. Now let's do some formatting to the data that we have created. Formatting in Excel refers to the process of changing the appearance of cells, rows, columns and other elements within a spreadsheet to improve readability and enhance the overall presentation of the data. Before you share an Excel file, either for an assignment, submission or any work-related tasks, make sure you format it. Okay, so the first thing that we'll do here is we'll add a title. Okay, add a title to this table or this sheet. Now I'm going to add a row here. Click on insert and a row is seen here. So let's add the title as sales revenue analysis. Okay. Now you can see that the title is in the first column, but I want it centered according to this table. So I'll select these cells and click on merge and center. So now we can see that the title is in the center. Now let's just style this heading. So under styles, go to cell styles and choose a heading, heading 1 or heading 2. So here I'm choosing heading 2. Yeah. So heading is styled. Next, let's style the grand total. So this is the grand total, right? So let's select these rows and go to cell styles. And there's a default style for grand total. Let's just click on that. Yeah. Now let's format the entire table. So let's copy the entire table and format as table. We can choose any of these options. I'm choosing this one. Yeah. Okay, let's do the same thing for this one also. Let's add a heading under cell styles. Let this be heading 3 and we'll add some color to these cells. Okay, let's do one more thing, that is let's add border to the entire table. Okay, that you can do it under the font tab. Let's just do all borders. Yeah. Now we'll just adjust the column spaces again. Yeah. Now we can see that the table is well formatted. Next, let's take a look at data visualization. Now, we have categorized the revenue based on each categories, product categories, right? So, let's visualize the revenue according to the categories food, stationery and clothing. So, first of all, let's select this data range and go to insert. So, a bar chart is always suitable for visualizing categories. So, here we have different charts. This is bar chart, line, pie chart, scatter plots. So here I'm choosing bar chart. So I'm choosing the first one. Okay. So this is the plot that Excel has generated. Let's zoom out a bit. Yeah. Now this is the chart. Now we'll make some changes to this chart. Okay. First of all, let's change the title. Total revenue based on product categories. Okay. Yeah. Now, what is missing in this chart? Axis titles. Axis titles are very important for any chart. So, make sure you add them. So, this is the total revenue. Total revenue. This is the product category. Now, let's also add data labels. Okay. Let's just click on plus symbol here and add data labels. Yeah. Now, this plot shows us that the product category food had the highest revenue, followed by stationery, and clothing had the lowest revenue. So, this is how we create a simple chart in Excel and interpret from it. So now we are done with the analysis. So we just go to File and save it. Okay. And then you can go to File and also export it into PDF. Okay, and publish. So this is the PDF file of the analysis that we have done in Excel.
Let's take up another question. Which of the following is the correct formula to add the value in cell A1 and B1 in Excel? Options are given on the screen. If you know the correct answer, please comment down below. We just learned the basics of Excel. Now, we will move to Excel formulas and functions, where you will discover how to use formulas to perform calculations and automate tasks.
So moving on towards the first topic of this session, which is what exactly is a formula? A formula in general is a condensed way of representing some information in terms of symbols. In Excel, formulas are expressions that can be entered into the cells of an Excel sheet and their outputs are displayed as a result. Excel formulas can be of any type such as mathematical operators, values or texts, cell references, or the worksheet functions. Mathematical operators include the operators such as plus, minus, star, the divided by symbol, etc. When you enter values in an Excel sheet cell, Excel takes those values and returns the output. In case you want to compare two cells in Excel, you can do it easily by specifying an equal to sign between the cell references of both the cells that you want to compare. This will either return a true or false depending on whether the values are same or different. Worksheet functions are nothing but the built-in functions that are present in Excel, and I'll be discussing this later on in this session. Okay, so now let's move on and see how you can actually work with formulas in Excel. Like I've already told you before, here we'll be discussing how you can actually write, edit, copy-paste formulas, hide formulas, and the operator precedence of Excel formulas. So now I'll jump onto my Excel sheet. And the first thing that we'll be discussing over here is how to write Excel formulas. In order to write a formula to an Excel sheet cell, all you have to do is select the cell where you want the result to be displayed, type an equal to sign initially to let Excel know that you're going to enter a formula in that cell. After that, you can either type a cell address or specify the values that you intend to calculate. So for example, let me just enter some values over here. I'll say A1 is 3 and A2 is 2. And then I want to return the sum of A1 and A2 in A3. Now to do that, all I have to do is type in an equal to sign. And then I can simply type down the cell address, that's A1 and A2, with a plus sign in between and then hit enter. Okay, so as you can see, it has returned the output, which is 3 plus 2 is 5. Now in case you don't want to type the cell address, what you can also do is, let me just delete this. Type an equal to sign again. Select the cells whose values you intend to work on. So I'll select A1 and then I'll specify a plus sign and then I'll select A2. Now I'll hit enter. Okay, so I hope you guys are clear with this. So one more thing I want you guys to notice is that you can also enter the formula in the formula bar that is present over here. Okay, so now let's move on and see how you can actually edit a formula in Excel. In case you want to edit some previously entered formula, simply select the cell that contains the target formula and in the formula bar, you can make the desired changes. So as you all have seen, in the previous example, I have calculated the sum of A1 and A2. Now, I want to edit the same and change the formula in order to calculate the product of the values present in A1 and A2. So like I've already told you all you have to do is select the cell which contains the target formula, go to the formula bar, and over here make the desired changes. So in order to find the product, I'll just have to include a star symbol instead of the plus sign. So now I'll hit enter. Okay, so I hope you guys are clear with this. So now moving on towards something very interesting, which is how to copy paste a formula in Excel. Excel comes in really handy when you have to copy paste formulas. Whenever you copy a formula, Excel automatically takes care of the cell references that are required at that position. Now this task is taken care of by the relative cell address system. Here, the copied formula will have modified row and column addresses that will suit its new position. In order to copy a formula, select the cell that holds the original formula and drag it until the cell that you want to calculate the formula for. Okay, so what I'm going to do over here is add on some more values in the B, C, and D columns, and then I'm going to drag the formula present in A3 to B3, C3 and D3. So now let's move on and see how it works. I'll just enter some random values. I'll say 3, 4, and over here 2 and 9, 6, 7. So as we all know, the formula is present in A3. Now what I'm going to do is hold the left click and drag this down until that cell to which I want to copy the formula. Okay, so I hope you guys have seen this. The formula has been copied and the cell references have been changed according to the position. To know more about the relative cell addresses, absolute cell references and the mixed cell references, you can refer to the Excel tutorial video of Edureka. Okay, so now let's move on and see how you can actually hide formulas in Excel. In case you want to hide some formula from an Excel sheet, all you have to do is select those cells whose formula you intend to hide, open the font window, and from here, open up the protection pane. Now, check the hidden box and click on OK. Okay, so as you can see, I've checked the hidden box, but the formula is still visible over here. Now this is because I've not selected the protect sheet command. And if I don't do that, my formulas are not going to be hidden. So in order to protect the sheet, select Review from the ribbon tab. And then from the Protect group, click on Protect Sheet option that is present over here. So as you can see, it asks me to enter some password to unprotect the sheet. So I'll just specify some password. And I'll click on OK. So now it's asking me to re-enter the password. So I'll just do the same. And then I'll click on OK. So as you can see, previously when I used to click on these cells that contain the formula was visible in the formula bar. Now, when I click on any of these cells that contain formulas, the formula is no more visible over here, which means that the formula is hidden. So in order to undo what you've done, just select the unprotect sheet command that is present over here and then enter the password that you've entered previously. So as you can see, the formulas are now visible. Okay, I hope you guys are clear with this. So now let's move on and see what is the operator precedence of Excel formulas. Excel formulas basically follow the BODMAS or the brackets, order, division, multiplication, addition and subtraction rules. If you have a formula that contains brackets, the expression within the brackets will be solved before any other part of the complete formula. Say for example, I'll select a new cell and over here I'll just type in some formula. I'll say equal to A1 star and then I'll open up the brackets and within this I'll just say C1 plus C2 and then I'll close the brackets. So as you can see, I found the result for A1 star C1 plus C2 within brackets. So what exactly Excel is doing over here is, first it determines the result of C1 plus C2, which is 2 plus 9 and that is 11. Then it multiplies that result to 3 and hence we get the final result as 33. So I hope you guys have understood this. So now let's move on towards the next topic, which is what exactly are functions in Excel. In general, a function defines a formula that is executed in some given order. Excel provides a huge number of built-in functions that can be used in order to calculate the results of various formulas. In order to view all the functions that are available in Excel, all you have to do is click on the formula menu that is present in the ribbon bar and over here, click on this insert function command. Open up the category drop-down menu and over here, you can see all the various categories of functions that are available in Excel. In order to select some function, all you can do is select the category to which it belongs and then select the function that you intend to use. After that, just click on OK. Once you've done that, Excel asks you to enter the parameters that are present for that particular function. After entering the parameters, just click on OK. So I've got this caution message because I've not entered any values over there. So I'll just click on OK. So the next thing that we're going to be discussing in this session is the most important Excel formulas. So here are some of the most important formulas and functions that I'm going to be discussing in this section over here. So the first function that I'm going to be dealing with is the date function. Now this is one of the most important and widely used functions in Excel. So in order to show the syntax of this formula, all I'm going to do is select the date and time category and from here I'll select the date function. When I select the function, it shows me the syntax of that particular function and also specifies what it returns. So as you can see over here, the date function takes three parameters, which is the year, month, and day. This function returns a number that represents a given date in the MS Excel date-time format. So to make use of this function, what I'm going to do is go to the formula bar, and over here I'll specify an equal to sign. Then I'll type date. Now for the first parameter, I'll have to specify the year. So I'll just say 2019. Month, I'll just say 03. And the day, I'll give some random day, say 21. After I've done this, I'll just hit enter. So as you can see over here, Excel has returned the date in the Excel date time format. So now let me show you guys another example. So what I'm going to do over here is, for the same date, I'm going to subtract some days from it. So to do that, after I've written the date function, what I'm going to do is specify the minus sign, and then I'll just give some random value, say 5, and then hit enter. So as you can see over here, Excel has returned the date that comes 5 days prior to the date that is specified within the date function as a parameter. So I hope you guys have understood this. So now let's move on and take a look at the day function. Now just like the day function basically returns the day value of the month. So it can be anything between 1 to 31. This function basically takes one parameter, which is the serial number. The serial number is the date whose day you want to retrieve. It can be given in any manner, such as the result of some other function, supplied as a date function, or the cell reference itself. So what I'm going to do over here is select a new cell, and then I'll type down the equal to sign, and I'll use the day function. So I'll just specify a cell reference over here, and that is A1. So as you can see, it has returned the day value for this particular date. You can also make use of the date function within the day function, and to do that, just specify the equal to sign, and then use the day function, and within this, type down the date function, and specify the parameters to it. So first is the year, and then the month, and then the day. Okay, so I hope you guys are clear with how this works. So now let's move on and see how you can actually calculate percentage in an Excel sheet. Percentage, as we all know, is the ratio calculated as a fraction of 100. Okay, so mathematically, percentage is equal to part divided by whole multiplied by 100. Okay, so now let's move on and see how you can actually do this using Excel. I'll just erase these drawings over here. So I'll just clear the values that are present over here. So in order to calculate the percentage, I'll just specify some new values, say 4 and 6. And I'll just say that 4 is the part value and 6 is the whole value. So what I have to do over here is select the cell where I want to display the result, type an equal to sign, and then I'll say A1 divided by A2. Okay, then I'll just hit enter. Okay, so after this, what I have to do is go to the Home tab, and from the numbers group, click on the percentage symbol. So as you all can see, I found the percentage over here. So now moving on towards the next important function, that is the if statement. I'll just clear this from here. The if statement, as many of us know, is a conditional statement that returns true when a specified condition is satisfied, and it returns false when the condition is not met. Excel provides a built-in if function that serves this purpose. Now to show this function to you guys, what I'm going to do is go to the if function that is present over here, select the function, and over here you can see the syntax of it. So this if function basically takes 3 parameters. The first is the logical test, which is the condition that is to be checked. The second parameter will return some value in case the condition is met, and the third parameter will give a separate value in case the condition is not met. So I'll just take 2 values over here. I'll say 3, and over here I'll just say XYZ. Now I'll take a new cell, and over here I'll type the equal to sign, then make use of the if function. Now what I'm going to do over here is just check if A1 is equal to A2. So I'll say A1 equal to A2, and then I'll specify the value that is to be returned if the condition is met. That is, I'll say yes. And the third parameter will be when the condition is not satisfied. So that'll be no. You can give any values of your choice. So as you can see over here, A1 is not equal to A2. Okay, so I hope you guys have understood this. So now moving on towards the next very important function, which is VLOOKUP. The VLOOKUP function is used in order to look up and fetch some particular data from a column of an Excel sheet. V in the VLOOKUP stands for vertical lookup. This is also one of the most important and widely used formulas in Excel. Now to show you the syntax of this function, what I'm going to do is open the insert function window, and over here I'll just type in VLOOKUP. It basically comes in the lookup and reference category. I'll just click V, and over here you can see the VLOOKUP function. So here you can see the syntax of this function. So this function can take up to 4 parameters, where the 4th parameter is optional. The first parameter, or the lookup value, is the value that is to be searched. The second parameter specifies the table array in which the value is to be searched. The third parameter specifies the column index from which the value is to be retrieved. So the final parameter, or the range lookup parameter, is optional, and it returns true for approximate values and false for an exact match. So now, for example, if I want to find the ID that is present for this employee, which is Dave, all I have to do is select some cell, and over here I'll use the VLOOKUP function, and then I'll specify the name of the employee, which is Dave, and the table array will be from A1 till C3. So after this, I'll have to specify the column index. So the column index will be 2, and since I want an exact match, I'll use false. So now I'll hit enter. Okay, so as you can see over here, the VLOOKUP function has retrieved the ID of Dave. So I hope you guys are clear with this. So now let's move on towards the next formula, that is calculating the income tax. So to calculate the income tax, I've already created a table over here. And within this table, I've specified the total salary, the salary deductions, taxable income, and the percentage of tax on the income. So I've just specified some random salary over here and some random salary deductions. So the next thing that I'll have to do is find the taxable income. The taxable income will be the difference between the total income and the salary deductions. So that will be A1 minus A2. I'm sorry, it's B1 minus B2. Now I'll hit enter. So the total taxable income is $275. So the percentage of tax on my income is 10%. So in order to find the income tax, what I have to do is income tax will be equal to taxable income into 10 by 100, which is the percentage of tax applied to my income. So to do this in Excel, what I have to do is just select the cell, and here I'll type the equal to sign. Taxable income is present in B3, so I'll select the cell B3 and then multiply this with 10 divided by 100. And now I'm going to hit enter. So as you can see over here, I have $27.5 as my tax. Okay, so I hope you guys have understood this. So now moving on towards the next function, that is the sum function. The sum function, as we all know, calculates the result by adding the specified values in Excel. In order to show you guys the formula of this function, all I'm going to do is open up the insert function window, and here I'll just type sum, hit enter. So as you can see over here, the sum function takes in all the values to be added as its parameters, and then it returns the result after adding all the values. So in case I want to calculate the sum of all these values that are present over here, what I'm going to do is I'll just say equal to, and then I'll use the sum function, and I'll specify the range as B1 to B4, and then I'll hit enter. So as you can see, the sum function has calculated the sum of all the values that are present over here. Okay, so I'll just delete this off from here. So now moving on towards the next very important formula, which is finding the compound interest. Excel has a built-in formula called as FV that finds the compound interest. FV actually determines the future value of an investment on the basis of periodic, constant interest rate and payments. To show you guys the syntax of this function, I'll just open up the insert function window, and over here I'll just type FV. So as you can see over here, this function takes 5 parameters. Okay, in order to calculate the rate, you will need to divide the annual rate by the periods. Number of periods, or NPER, is calculated by multiplying the term or the number of years with the periods. PMT basically stands for periodic payment and can be any value including 0. So I'll just create another table over here. In case I want to calculate the compound interest for an investment of 500 at the rate of 10% for 5 years, assuming that the periodic payment value is 0, all all I have to do is make use of the FV function. Okay, I'll just increase the size of this column over here. So now what I'm going to do is type an equal to sign, then make use of the FV function, and the first value will be the rate. So like I've already told you all before, in order to calculate the rate, I'll have to divide the annual rate by the number of periods. So the annual rate over here is 10% and the number of periods is 12. So that will be C2 divided by C4. So I'll just click on this and then divide it by C4. So for the next parameter, I'll have to specify the number of periods. The number of periods or NPER is calculated by multiplying the term with the periods. So here the term is 5 star, periods are 12. Assuming that the periodic payment is 0, I'll just specify it to be 0. Finally, I'll be specifying the investment amount. And since the money has been taken from my end, I'm going to specify a minus sign preceding the amount that is invested. So the amount is present in C1. So I'll just click on this. So as you can see over here, the future value for $500 at the rate of 10% for 5 years is found to be $822.65. So now moving on towards the next very important formula, which is finding the average. Average basically depicts the median value of a number of values. In Excel, the average can be easily calculated using a built-in function called average. In order to show you the syntax of this function, I'll just open up the insert function window, and over here I'm going to type average. So as you can see, this function basically takes all the values and then it returns an average, which is nothing but the arithmetic mean of all the values that are supplied to it as a parameter. I already have a table for this. So now, in order to find the average of the marks scored by these two students, what I'm going to do over here is create another column and I'll name this as average. And over here, I'll type the equal to sign and make use of the average function. So now I want to find the average of all the test marks that are scored in the various tests. So I'll just select all these cells and then I'll hit enter. Okay, so as you can see, I found the average for Dave. Now in order to find the average for Ava, all I'm going to do is copy this function. Okay, so I hope you guys are clear with this. I found the average for both the students. So now moving on towards the next function, which is the count function. The count function of Excel will count the number of cells containing numbers in a given range. So in case I want to calculate the number of cells holding numbers in the table I've just created, all I have to do is select a new cell, then specify the count function. And within this, I'll specify this table as a range. So as you can see, it has returned the value to be 12, which means 12 cells in my table contain number values. So I hope you guys are clear with this. So now moving on towards the next function, which is the round function. The round function basically rounds off values to some specific decimal places. So as you can see over here, I have some decimal values that are present. Now in case I want to remove the decimal point from this, I'll just select a new cell and then I'll make use of a round function. And as you can see, it takes two parameters, which is the number and the number of digits that you want to round it off to. Now since I just have one number after the decimal point, I'll just specify the number of digits to be 0. So for the number, I'll use the cell address of G2 and the number of digits will be 0. So as you can see, 83.4 has been rounded off to 83. So now moving on towards the next formula, which is finding the grade. In order to find grades, you will have to make use of the nested if statements in Excel. So over here, we found the average. Now in case I want to grade these students, I'll have to make use of the nested if statements. So I'll just create a new column. I'll say grade. And within this, I'll use the if function first. So the if function, like I've already told you, will take one condition and it's going to return some value if it is true and another value if it is false. So now I just want to check if G2 is greater than 75. So I'll say G2 greater than 75. And in case this is true, I'll return the grade to be A. So in case this is false, I'll create another if condition within this. And I'll check if G2 is greater than 40. So if this value is true, I'll just return B as the grade. And if this is false, I want the return value to be F. Okay, so now I'll close this and I'll hit enter. So as you can see, the value of G2 is greater than 75, which means the grade is A. In case the value of G2 would have been less than 75, it would have gone to the next loop and then it would check for the condition if G2 is greater than 40 or not. If G2 is greater than 40, it will return B as the value, else it's going to return F. Okay, so I hope you guys are clear with this. Let me just copy this for the other student as well. So now moving on towards the next function, which is the rank function. So till now you've been seeing how to calculate the average of a student and then find the grade. Now I'll also show you guys how to give ranks to the students present in a class. To do that, you can make use of the rank function which is already present in Excel. The rank function basically takes three parameters, which is the reference, number and order. So I'll just specify rank over here. And as you can see, it takes number, reference and order as parameters. The order parameter is optional, and in case you do not specify anything, it is going to return the rank in the descending order, which means the highest value will get first rank, the second value is going to get second rank, etc. In case you want to specify in ascending order, you can specify any non-zero values. The number over here is going to be G2 and the range will be G2 and G3. Since I want it to be in descending order, I'll not specify any value to the order parameter and I'll hit enter. So as you can see, I found the rank, but it looks misplaced because I've not created the column name. So I'll just cut this and I'll paste it over here. I'll just name this column as rank. Now, in order to find the rank of Ava, I'll do the same. And then the value is present in G3 and the range is G2 and G3. And I'll hit enter. So as you can see, Dave is first rank and Ava is second rank. So I hope you guys are clear with this. Okay, so now moving on towards the next example, which is the COUNTIF function. The COUNTIF function counts the cells based on some given condition. It will return the number of cells that satisfy some condition in a given range. To show you guys the syntax of this function, I'll just write down the function, that is COUNTIF. So as you can see, it takes two parameters, which is range and criteria. Range is basically all the cells that you want to look into, and the criteria is the condition that they have to satisfy. So I'll just select all the cells over here. And the criteria is going to be if the values are greater than 70. So as you can see, it has returned 10 as the output, which means 10 cells contain values that are greater than 70. So now moving on towards the last function that I'm going to be discussing in this session, which is the index function. The index function returns a value or cell reference at some particular position in a specified range. The index function can be used in two forms. The first is the array form. In this form, if both the row and the column number are supplied, it returns the value that is present at the intersection of both the cells. If the column value is set to 0, it will return the values present in the entire row in the specified range. In case of the reference form, the index function returns the reference of the cell where the row and the column values intersect. Area number will indicate the range which is to be used in case multiple ranges have been supplied. So just to show you guys some example of this, I'll specify the array to be between A3 and I3. And for the row and column values, I'll just say 2, 3. You can give any values of your choice. These are just some random values. So as you can see, the value that is present in the second row and the third column in this table is 85.
Let's take up another question. Which Excel function is used to calculate the average of a range of cells? Options are A. Sum, B. Average, C. Count, D. Min. If you know the correct answer, please comment down below. Having covered Excel formulas, we will now look at VLOOKUP in Excel. This function helps you to find specific data within your spreadsheet efficiently.
What exactly is VLOOKUP in Excel? VLOOKUP is a built-in function that is used to look up and fetch specific data from an Excel sheet. The V stands for vertical, and in order to use the VLOOKUP function in Excel, the data must be arranged vertically. This function comes in very handy when you have a huge amount of data and would be practically impossible to manually search for some specific data. Okay, so how does this function work? The VLOOKUP function basically takes a value, that is the lookup value, and starts to search for it in the leftmost column. When the first occurrence of the lookup value is found, it starts to move towards the right in that row and returns the value from the column that you specify. As I've already mentioned earlier, this function can be used to return both exact as well as approximate matches. However, the default match is approximate match. Okay, so just to show you guys the syntax of this function, I'll jump on to Excel, and in this function bar over here, I'll just type an equal to sign, and then I'll type out VLOOKUP. Okay, so as you can see over here, the VLOOKUP function takes 4 parameters, that is the lookup value, the table array, the column index number, and the range lookup, which is an optional parameter. Lookup value is the value to be looked out for in the first column of the given table. Table index points to the table from which the data is to be fetched. Column index number is the column from which the value is to be retrieved. Range lookup is a logical value that determines if the lookup value should be a perfect match or an approximate match. True will find the closest match and false will check for an exact match. Okay, so getting back towards our presentation. So now let's take a closer look at the exact and the approximate matches. An exact match tells Excel to return a value from the specified table that corresponds to an exact match of the given value. The approximate match, on the other hand, allows you to retrieve values even when you do not have an exact match for the lookup value. When you want the VLOOKUP function to look for an exact match, you will have to set the range lookup value to false. On the other hand, to make VLOOKUP look for an approximate match, you will need to set the range lookup value to true. Okay, so now let's get back to Excel and see how this actually works. Okay, so as you can see, I've created a table with employee names and IDs along with their designations and salaries. So like I've already told you guys, the VLOOKUP function starts to look for a match of the given lookup value in the first or the leftmost column of this table. Okay, so I'll just select some cell over here. And the first thing that I'll have to do is type in the equal to sign. I hope you guys are aware that before writing any formula or function in Excel, you'll have to type in the equal to sign. Okay, so now what I'm going to do is type in the VLOOKUP function, and then I'll pass some reference lookup value. Say I'll pass in the ID as 103. Next, I should pass in the table array. So basically the table values starting from A2 and goes on till D10. Okay, so the next parameter is the column index number. Now this basically will be the column from which I want the data to be retrieved. So let me just retrieve the salary of this person. So I'll just say column number 4. Now the first example that I'll be showing over here is for an exact match. So therefore the range lookup value will be false. Okay, so as you can see over here, the salary of the employee having the ID as 103 is $1,300. So what exactly VLOOKUP is doing over here is, it starts to look for 103 in this column, and when it reaches 103, it moves towards the right. And it will go on till that column which you've specified in the column index value that you've given over here. So I hope you guys are clear with this. So to show you guys another example, what I'm going to do is type in the same function over here. And this time I'll pass some other ID, say 104. And the table index is going to be the same again. And the column this time I'll give as 3. And since it's an exact match, I'll type in false. Okay, so I hope you guys are clear with this. Now to show you guys an example of the approximate match, I've created another table over here which contains the marks, the grades, and the class to which they belong. So in order to find an approximate match between these values, what I'm going to do is use the VLOOKUP function along with the range lookup value as true. So first I'll type in VLOOKUP, and then the lookup value this time, I'll specify some value between this range over here. So for example, I'll say 55, and the table is going to be from A to C4. I'll specify the column to be 2, and since this is going to be an approximate match, I'll type in the Boolean value as true. So as you can see, the VLOOKUP function has returned C as the grade for marks being 55. Now what exactly VLOOKUP is doing over here is, it starts to look for an approximate match and stops at the next largest value that is smaller than the lookup value that you've given to it. It will start from here and it will stop at the next largest value. So my next largest value for 55 is 40 itself. So it will start from the beginning of the column, it will stop at 40, and then it will move towards the right. So I hope you guys have understood this. Now to show you guys another example, what I'm going to do is change the value from 55 to say 75. So as you can see, it has started from the leftmost column, moved downwards, and it has stopped at 60, which is the next largest value of the specified lookup value. Okay, so I hope you guys are clear with this. So now let's get back to our presentation and see how VLOOKUP behaves when you have multiple lookup values in a given column. So in case you have a table that consists of multiple lookup values, the VLOOKUP stops at the first match of it and retrieves the value from that row in the specified column. So for example, let me get back to Excel and I'll open up sheet 1. Okay, so as you can see over here, I have two values as 105 in the leftmost column. Now, if I specify the lookup value to be 105, what VLOOKUP will do is start from the beginning, move downwards, and it will stop at the first match of 105, and then it will start to move towards the right of this column. Okay, so just to show you all that, what I'm going to do is erase this value from here. Instead of 104, I'll just type in 105 as the value. Okay, so as you can see, the first match of 105 is for an employee named Leo and the designation being Hadoop admin. So I hope you guys have understood this. So now moving on towards the next topic, which is case sensitivity of the VLOOKUP function. VLOOKUP function is case insensitive. So for example, if you have a lookup value that is in uppercase and the value present in the table in the first occurrence is in small case, the VLOOKUP function will still fetch the value from the row in which the value is present. Okay, so as you can see on the screen, I have two values with the name as Rafa. So the first thing that I'll be doing over here is swap these two columns. So now to do that, I'll just select this column, I'll hold down the shift key, and then by pressing down the left click, I'll just shift that column over here. Okay, so now my leftmost column contains the names of all the employees. So now for the example of case sensitivity, I'll make use of the VLOOKUP function again. I'll specify the lookup value to be as Rafa in caps, and my table will be from A2 to D10. I'll give some random column index value, say 4. And I'll use false since it is for an exact match. Okay, so as you all can see on the screen, I've specified RAFA in caps and the first occurrence of Rafa is not in caps, but the VLOOKUP function has returned 900 as the value, which is the value for the first occurrence of Rafa. So I hope you guys have understood this. So now let's get back to our presentation. Okay. So now let's move on towards our next topic, which is something we all encounter, and that is nothing but errors. It is natural to encounter errors whenever you make use of any function. And similarly, you can encounter errors when you're using the VLOOKUP function as well. Some of the common errors that you'll face while using the VLOOKUP function are the name error, the not available error, the reference error, and value error. Name error basically is to inform you guys that you've made some mistake in the syntax. Not available error is returned in case no match is found for a given lookup value. The reference error is basically encountered when you give a reference to a column that is not available in the table. And the value error is encountered when you place wrong values to the parameters or miss some compulsory parameters. Okay, so now let's get back to Excel and take a deep look at each of these. So first talking about the name error. Like I've already told you guys, the name error informs you that you've made a mistake in the syntax. To avoid syntactical errors, it's better to use the function wizard provided by Excel for every function. This function wizard helps you with the information regarding every parameter and the type of values that you need to enter. To open up the function wizard, simply click on the f of x button present over here. So I'll just erase all these values. Okay, so as you can see, Excel is providing information about each parameter that you have to enter. So according to Excel, lookup value can be any value, and it is the value that is to be found in the first column of the table. So for now, I'll just close this function wizard over here. I'll select a new cell and I'll make use of the VLOOKUP function again. Okay, so now I have names or string values present in the first column of my table. Okay, so I'll not specify these string values within quotes. Specify the table array and the column to be 3. The value I'll specify as false. Okay, so as you can see, I've not given this within quotes. And now I'll hit enter. So as you can see over here, I've encountered a name error. Excel also gives you information about this. The moment you encounter any error, Excel provides a drop-down list in order to help you out to debug this error. So what I'm going to do is open up the function wizard, and over here, I'll just specify this within quotes. Okay, so I hope you all have noticed, before entering the lookup value within quotes, the function wizard was showing a name error in red over here. So as soon as I put this within quotes, the error has gone. Okay, so now I'll click on OK. So as you can see, the error has been debugged. Okay, so the next error that we were talking about is the not available error. So in case I specify some name that is not present in the table, say for example, Loris, and I hit enter. So as you can see, Excel has returned an error saying not available. So the next error that we spoke about was the reference error. So I'll just change this value from here. I'll say Sergio. And like I've already told you all, the reference error is encountered when you give a reference to a column that is not available in that table. So let me just change the column index value from 3 to 7 and hit enter. So as you can see, column number 7 is not present in my table, and therefore I've encountered a reference error. So the last thing we spoke about was the value error. Now this error, like I've already told you, is encountered when you place wrong values to parameters or miss some compulsory parameters. So let me just change the values from here. I'll change this to 3 again. And I'm not going to specify the first parameter. And I'll hit enter. Okay, so I hope you guys are clear with this. So now let's move on towards the next topic, which is two-way lookup. Two-way lookup refers to fetching a value from a two-dimensional table from any cell of the reference table. In order to perform a two-way lookup using VLOOKUP, you will need to use the match function along with it. Okay, so I'll just get back to Excel. And the first thing that I'm going to do over here is not use hard-coded values. Instead, I'll be using reference to some cell. So in this cell over here, I'll just type in some name. I'll say Ivan. And over here, I'll just specify as salary. Okay, so now I want the VLOOKUP function to fetch the salary value of Ivan. So like I've already told you all, in order to perform a two-way lookup, I'll have to use the VLOOKUP function along with the match function. So the first thing that I'm going to do over here is type in the equal to sign followed by VLOOKUP. And like I've already told you all, I'll not be using hard-coded values. Instead, I'll be using the cell reference. So I'll use the cell reference of H6, which is Ivan. And the next is the table array that is going to start from A1 to D10. Okay, so now I'll be doing something very interesting, that is making use of the match function. So the match function basically takes 3 parameters. The first is the lookup value. Now this value is the value to be searched for. The lookup array is the range of cells that consist of the lookup values, and the match type can be any number that is 0, 1 or -1, representing an exact match, less than or greater than respectively. Okay, so the first value of this parameter is going to be I5. And the lookup array will be from A1 to D1. And since I want it to be an exact match, I'll type in 0 followed by false as the last parameter of the VLOOKUP function. So as you can see, the salary for the employee Ivan is $800. So now what will happen in case I change the value of any of these two values present over here? So I'll just change from salary to designation and see what happens. Okay. So as you can see, the moment I change the value of I5, VLOOKUP has also updated the output. So similarly, if I change the value of Ivan, say for example, I'll change it to Sergio. So as you can see over here, if I change any of these values, the output is being updated. Now instead of typing in all the values each time and changing them manually, what you can also do is create a drop-down list over here. To create a drop-down menu, click on Data. And from the Data Tools group, select Data Validation. Okay, so from the Settings pane over here, select List. And for the source of the list, I'm going to give in all the names that are present over here. And then I'll click on OK. So as you can see, I've created a drop-down list with all the employee names present over here. So if I change any of these, the value is going to be updated accordingly. Similarly, I can also create a list over here. So I'll just go to Data. And then from Data Tools, I'll go to Data Validation, and from Settings, I'll select List. And for the source, I'll specify the name, ID, designation, and salary. And then I'll hit OK. Okay, so I hope you guys are clear with this. So now moving on towards something very interesting, which is making use of wildcards in VLOOKUP. In case you do not know exact lookup value, but only a part of it, you can make use of wildcards. In Excel, the star symbol represents a wildcard character. This symbol informs Excel that the sequence that comes before, after, or between must be searched for, and there can be any number of characters before or after them. Okay, so for example, let me get back to my Excel sheet. So the first thing that I'm going to do over here is type in some sequence, let's say ERG, and over here, I'll make use of the VLOOKUP function. Okay, so instead of typing in the whole name, what I'm going to do is make use of wildcard characters. So that is star or the asterisk symbol, followed by the ampersand symbol, and then I'll type in the cell reference, which is F12, an ampersand symbol again, and then the star sign. Next, I'll have to specify the table array, the column from which I have to retrieve the value, and the range lookup. So as you can see over here, ERG is present for the name Sergio. It has a number of characters present before and after that. Okay, so I hope you guys are clear with this. So now let's move on towards the last topic of this session, which is multiple lookup tables. In case you have multiple lookup tables, you can use the if function along with the VLOOKUP function in order to look into either of the tables based on some given condition. Okay, so as you can see on the screen, I've already created 3 tables over here. Now the main table contains data of 2 stores, that is store 1 and store 2, and the sales and the profit of each of these stores. Now for each of these stores, I have 2 tables which contains the sales marked with the profits. Now what I'm going to do over here is create named ranges for these 2 tables. To create a named range, select the table. From the ribbon tab, click on Formulas. And from this Defined Names group over here, click on Define Name. Okay, so the name I'll provide over here is Table 1, and then I'll click on OK. So the name of this table is Table 1. Similarly, I'll create a name for this table as well, and I'll just name it as Table 2. So now, all I have to do is click on this cell over here, and to calculate the profit, I'll make use of the VLOOKUP function. And the first parameter will be the sales that is present over here. So in this case, it's going to be C2, and then comes in the if function. So the if function is basically going to check if it is store 1 or store 2, and if it is store 1, it will return table 1, and if it is store 2, it's going to return table 2 as the output. So I'll just say if the value of B2 is equal to store 1. And if this is true, I'll make use of table 1, else I'll make use of table 2. Okay, so I hope you're clear with that. The value to be retrieved is the profit, which is in column 2, so I'll specify 2. And then I want it to be an approximate match, so I'll specify true as the range parameter. Okay, so I hope you're clear with that. So as you can see, for the sales of $400 and store 1, the profit value is 70, and therefore VLOOKUP has fetched 70 from this table. So in order to calculate the profit of all these values over here, all I'm going to do is copy this formula. Okay, so I hope you all are clear with this. This not applicable error is because I do not have any value corresponding to 200 in the store 2 table. So I hope you all are clear with this.
Moving on to another question. Which of the following is a correct use of the VLOOKUP function in Excel? Options are given on the screen. If you know the correct answer, please comment down below. We just explored VLOOKUP in Excel. Next, we will learn about Excel pivot tables, which allow you to summarize and analyze your data dynamically.
What exactly are pivot tables in Excel? A pivot table in Excel is a statistical table that condenses the data of those tables that have extensive information. The summary can be based on any field such as sales, averages, sums, etc. that the pivot table represents in a simple and intelligent manner. So moving on towards the features of pivot tables, Excel pivot tables have a number of remarkable features such as they display the exact data that you want to analyze. The data can be viewed from various angles. You can focus on any section of the data according to your requirements. Also, they make data comparison very easy, and pivot tables can detect different patterns, relationships, data trends, etc. Pivot tables also allow you to create instant data and also create accurate reports. So now that you're aware of what are Excel pivot tables, let's move on and see how you can actually prepare the data in order to create them. Before you actually start creating a pivot table, you will need to jot down the data for which you intend to create tables. So in order to create a table for this purpose, keep the following points in mind. The data must be arranged into rows and columns. The first row should have a short and a unique heading for every column. columns should hold only a single type of data and the rows should contain the data for a single recording. There should be no blank rows or completely blank columns. Also, keep in mind to separate the table data from other data that is present on your sheet. So for example, let me jump on to my Excel sheet and show you all the data that I've created. Okay, so as you can see on the screen, I've created a table that holds different information regarding the sales of fruits in different cities by various individuals along with its amount. There are no empty rows or columns in the table, and the first row has unique names for every column, that is the order ID, the date, name, etc. Also, please make a note that the columns contain the same type of data, that is for IDs, dates, names, etc. So now that our data is ready, let's move on and see how to create pivot tables using this data. So in order to create pivot tables for your data, all you have to do is select the data and then from the Insert tab, select Pivot Tables option. Okay, so now let me jump on to Excel and show you all how to do this. Okay, so the first thing that I'm going to do over here is select this data. And then from this Insert tab, I'll click on Pivot Tables. So as you can see, it shows me the range that I've selected. And also I have two options over here, that is new workbook or the existing worksheet. So what I'm going to choose is the existing worksheet. And then I'll select some cell as the location of this. And then I'll click on OK. Okay, so as you can see over here, an empty pivot table has been created for my data. Also, as you can see over here, a pivot table fields pane has opened, using which I can manipulate the data of my pivot tables. So this pane basically provides four options, that is filters, columns, rows, and the values. Filters allow you to filter out the data based on some criteria. Columns will represent the fields that you want to place in the columns. And similarly, rows will represent the fields that you want to replace in the rows. The values field can be used only for figures that are present in the table. Also, as you can notice over here, all the fields that are present in your table will be represented as a list in the Pivot Tables field pane. So now, in case you want to add any of these fields to these categories, all you have to do is select that field and drag it down to the area where you want to place it. So I'll just place the names in rows and I'll place the items in the columns. Also, I'll place the amount in the values section and I'll place city to be the filters. So I hope everyone's clear with this. So as you can see over here, a pivot table has been created. So this basically is a two-dimensional pivot table with the rows being the vendor names and the items as columns. Therefore, this table shows what each vendor has sold and the amount obtained by each of them. The final column shows the amount of each vendor and the last row shows the total amount for each item. So I hope everyone's clear till here. Now if you wish to create a one-dimensional pivot table, all you have to do is either keep the columns or the rows. So what I'm going to do is just remove the columns. So as you can see over here, I have a one-dimensional pivot table that has been created. So now let me put items back to columns. So now let's move on and see how you can filter the data that you require. In case you want to filter out the data of some particular city, so as you can see on the screen, I've chosen the city field to be the base for the filters area. Now in case I want to filter out the statistics for some city, all I have to do is open up this drop-down menu and then select the city that I wish to see. So I'll just select Texas and I'll click on OK. So as you can see, all the data for Texas has been retrieved. So what if you want to change some field present in the pivot table? In order to change the fields present in your pivot tables, all you have to do is drag and drop the fields that you wish to see in any of these four areas. So in case I want to change the rows from the names of vendors to items, all I have to do is drag this names back to this list area over here and drag the items to the rows. Okay, so as you can see, accordingly, my pivot table has changed. Okay, so this is a very important feature of pivot tables, which is pivot tables are dynamic unlike normal tables. So let me just select all cities and then I'll click on OK. So as you can see over here, I have a one-dimensional table that has row labels as the item names and the sum of amount that is shown for each of these items. So now in case you want to add something in the columns area, all you have to do is drag that field and put it in this columns area over here. So as you can see over here, I have all the items mapped according to the quantities and the grand total of each of them. So in case you want to filter out the cities, like I've already told you all before, open up this drop-down menu and select the city of your choice, then click on OK. So I hope everyone's clear with this. So now moving on towards something very interesting, which is the details of these pivot tables. So in the previous example, you've seen the total amount received by selling the items in each of these cities. In case you want to see the details for each of these statistics displayed, all you have to do is double-click on any of the desired statistic, and then you will be able to see a new sheet that's created where you will have the details of the table outputs. So let me get back to Excel to show this to you all. So in case I want to see more details about this grand total for apples over here, all I have to do is double-click on the same, and a new sheet will be created for me over here. So as you can see, this table contains all the details of the subtotal. So basically, Brad, Ivan, Chris, Sergio, Roger, and Rafa have sold apples in Texas and New York. Also, I have the quantities and the amounts fetched by each of them. So now let's get back to our original sheet. So now let's move on towards the next topic, which is sorting table data. Excel also allows you to sort the data according to your preferences. So in order to sort the data in ascending or the descending orders, all you have to do is select the row or the column labels, open up the drop-down menu, and select the options as smallest to largest or largest to smallest. Now this is because I have quantities in numerical order. So I'll just say largest to smallest. So as you can see, previously I had it in ascending order, and now I've changed it to the descending order. Let me also show you guys to change the row labels. I'll just sort them from Z to A. So as you can see over here, I've sorted the table according to my preference. Okay, so now let's move on towards something very interesting, which is the value field settings. So in the previous examples, as you all have seen, Excel shows the grand total by summing up the amount for every item. So in case you want to change this in order to see some other figures such as the average, counts, products, etc., all you have to do is right-click on the sum of the amount values and then go to value field settings. So let me get back to Excel. And what I'm going to do over here is right-click on this grand total and then go to value field settings. Over here, I'll just change it from sum to count. Okay, so as you can see, I've changed the grand total from sum to count. I have 20 entries and the total count is also 20. So I hope everyone's clear with this. So now, if you want to see the details of each of these, all you can do is double-click on them and a new sheet will be created that holds the details of each of these. So as we've seen, I had 3 entries for pineapples and all the 3 are listed over here along with the vendor names and the city in which they've sold. Also, it gives the quantity and the amount received by each vendor. So now let's move on towards the next topic, which is grouping. Excel allows you to group similar data while creating pivot tables. In order to group some data, simply select that piece of data and then right-click on the same, and then from the list, click on Group option. So let's get back to Excel. So what I'm going to do over here is group pineapples and oranges together. So what I'm going to do is select this, right-click on it, and then click on the Group option. So as you can see over here, Group 1 contains pineapples and oranges. Since bananas and apples are not grouped, it's showing them separately. So in case I want to group them together, all I'm going to do is select them, right-click, and then click on Group. So as you can see, Group 1 contains pineapples and oranges, whereas Group 2 contains bananas and apples. So I hope everyone's clear till here. So in case I don't want to see these individual group objects, all I have to do is collapse the group. Now in order to collapse the group, I'll right-click on it, and then from the Expand or Collapse option, I'll select the Collapse option. So I hope everyone's clear with this. Now to expand it, I should do the same, and then select the Expand option. So moving on, let's see how to add multiple fields to pivot tables. Excel also allows you to add multiple fields to each area present in the pivot tables field. So in order to add multiple fields, all you have to do is simply drag and drop the desired field in the respective areas. So now let's get back to our Excel sheet. So first let me ungroup these. Okay, so what I'm going to do over here is first open up the pivot tables field pane. And to do that, I'll just right click anywhere on this table and I'll click on the Show Field List command. Let me just increase the size of this. Okay, so for example, if you want to see the quantity of items sold in each city, simply drag the quantity field to the rows and the city fields to the columns. Also, let me change this from count to sum again. And I'll hit on OK. So as you can see on the screen, all the items along with the quantities and their amounts in each city has been shown in this pivot table. Similarly, you can also add more fields to any of these areas. So let me just drag the amounts field again to the values area. So as you can see over here, another sum of amount field has been created and Excel has also populated the columns accordingly. Okay, so let me just change this from sum to count again so that it becomes more clear to you all. I'll just put the city fields back to filters. Okay, now my table is much more clear for you all to see. So as you all can see over here, I have two sum of the values fields, one holding the sum of the amount and the second holding the count of each of them. So now let's move on towards something very interesting, that is formatting the pivot table. Excel allows you to format the table in order to make it look better. To do this, all you have to do is select the Design tab present in the ribbon, and from here you can choose any pivot table of your choice. So let me just change the pivot table style. So as you can see over here, I have a differently colored pivot table. Also, I can add banded rows and banded columns as well. So let me just remove banded columns. You can also choose between coloring the row headings or the column headings. In case you want to remove any of these, just unselect them. So I've unselected column headings and all the column headings have been changed to white. So that doesn't look good, so let me select it back again. So in case you don't want to see any of these grand totals, all you have to do is just remove them. So if I select the first option, that is off for rows and columns, both the grand totals present in the last column and the last row will be removed. So before doing that, let me just open up the fields pane and I'll add on item to the columns area. Let me just remove one of these summation values. So now I have a better looking table. I'll just change this from quantity to the names of the vendors. I think that should look better. Okay. So now what I'm going to do is remove the grand total present in the last column and the last row. So I'll just go to grand totals, off for rows and columns. So as you can see, both the last column and the last row have been deleted. Now in case I want to see only one of this, what I'm going to do is select either on for rows only or on for columns only. So let me select it for the columns. So as you can see over here, the grand total has been shown for all these columns. So similarly, there are many more options that you guys can check out for yourself. So now let's move on towards the last topic of this session, which is creating pivot charts using these pivot tables. Pivot charts basically help in visualizing the pivot table data. So in case you want to create a pivot chart for your data, all you have to do is click on this Insert tab present in the ribbon bar and then select the pivot chart option. So before creating a pie chart, what I'm going to do is go to the pivot fields pane again, and over here I'll just recreate a new pivot table. So I'll just remove the columns and filters and in the names, and in place of the rows, all I'm going to do is add in the amount. And for the summation value, I'll change it from sum of the amount to count, and I'll click on OK. So what I'm going to do over here is group this data into a particular range. So I'll just right click on this and click on the group option. So I'll start with 200 and I want it to go up till 500 and divide this by 100 each. So as you can see on the screen, I have three groups that have been created, starting from 200 going up till 500 with the difference of 100 each. So now I'll click on Insert and select Pivot Charts. So now let me create a pie graph for this. So as you can see, when I selected the pie option, Excel also provides other options that are present over here. So you can select any of these options of your choice. Okay, let me just keep the basic one and click on OK. So as you can see over here, I've created a pivot chart for my pivot table that's present over here. You can also format this chart by clicking on this Chart Styles option over here, and you can choose any chart of your choice.
Here's another question for you guys. What feature of Excel allows you to summarize large sets of data and easily create reports by dragging and dropping fields? Your options are A. Data validation, B. Conditional formatting, C. Pivot tables, or D. Spark lines. If you know the correct answer, please comment down below. After learning about pivot tables, we will now move to Advanced Excel. Here, you will dive into more complex functions and tools to enhance your data analysis skills.
Security is one aspect that we need in every application that we use. Excel provides three levels of security, that is file level security, worksheet level security, and workbook level security. File level security refers to securing your Excel file by making use of password so as to prevent others from opening and modifying your file. So now to show you guys how to enable this file level security, I'll jump onto Excel, and over here from the ribbon tab, I'll click on File and go to Info. From this Protect Workbook drop-down list, I'll select the option of Encrypt with Password. So as you can see over here, Excel opens up a dialog box wherein you'll have to enter a password. So I'll just enter some random password and then I'll click on OK. Re-enter the password as asked and click on OK. So as you can see over here, it says that a password is required to open up this workbook. Now what I'm going to do is just save this and I'll close this file. So now if I try to access this file, Excel will ask me to enter a password. So I'll just open the file again. So as you can see over here, it says I need a password in order to open this file. So I'll just enter the password that I had specified before and I'll click on OK. Okay, so as you can see over here, the file is now open. So there are a few things that you guys have to remember when it comes to passwords. Do not forget your password, as there's no password recovery available in Excel. No restrictions are levied, but Excel passwords are case sensitive. Avoid distributing password protected files with sensitive information such as bank details, and protecting a file with a password will not necessarily protect malicious activities. Avoid sharing your passwords. So now moving on towards the next level security, which is worksheet level. To protect the data present in a worksheet from being modified, you can lock the cells and protect the worksheet. Not just this, you can also selectively allow or disallow access to particular cells of your sheet to various users. Say for example, you have a sheet that contains the details for sales of different products, and every product is handled by different individuals. You can allow each sales staff to modify the details of only that product which he is responsible for and not of the others. Now to do this, all you have to do is first unlock the cells that can be edited by the users and then protect the sheet. So for the first step, all you have to do is select the cells and then open up this font window, click on Protection, uncheck the locked option, then click on OK. Now from the Review tab, select Protect Sheet option. From the given list over here, check all the options that you can allow users to manipulate, and optionally you can also enter a password over here. So I'll just give a password and then I'll click on OK. Okay, so I'll have to re-enter the password. So as you can see over here, the command has changed from protect sheet to unprotect sheet, which means the cells of this sheet have been protected. Okay, now in case I have to unprotect this sheet, all I have to do is click on this option and enter the password that I just gave. Remember guys that if you have not specified any password, any of the users can unprotect the sheet by just clicking on this option. So I hope you guys are clear with this. So now moving on towards the third level, that is workbook level security. Workbook level security will help prevent other users from adding, deleting, hiding, or renaming your sheets. So just to show this to you guys, I'll just add on one more sheet over here. And then from the Review tab, I'll click on this Protect Workbook option. So as you can see on the screen, a dialog box has opened for me to enter a password. Also, it's mentioned that this is optional. So if you do not specify any password, any user who wants to unprotect the sheet will just have to click on the Protect Workbook command again. Okay, so I'll just enter a password and click on OK. So as you can see over here, I've protected my sheet, and when I right click on any of these sheets, all the options such as Insert, Delete, Rename, Move or Copy, Tab Color, Hide and Unhide have been unselected, which means I cannot do this anymore. Also, you can see that this Protect Workbook command has been highlighted, which means that this workbook has been protected. Now in case you have to unprotect this workbook, all you have to do is click on this command and re-enter the password that you've just given. So I hope you guys are clear with this. So now moving on towards the next topic of this session, which is MS Excel themes. Excel provides a number of document themes to help you create formal documents. Using these themes, it will be very easy for you to harmonize different fonts, colors, or graphics. You also have an option to either change the complete theme or just the colors, fonts, etc. according to your choice. So using the MS Excel themes, you can make use of standard colored themes, create your theme, modify the fonts of themes, change effects, and also save your customized themes. So now let's get back to Excel and see how this works. Themes will be present in this page layout tab. So I'll click on page layout, and from here, to change the color of this theme, I'll just open up the colors drop down list and I'll select some different color. As you can see over here, the color of this chart has changed. Now in case you want to customize your own colors, all you have to do is open this drop down list and click on this customize colors option. From here, you can choose any color of your choice. So as you can see, all the changes you make will be reflected over here. So in case I want to change the color of the links, I'll change it to red. So I hope you can see this. The color of the links over here has changed. So in case I have any links in my Excel sheet, it will be reflected in this red color. Not just this, you also have an option called as more colors, using which you can customize your own colors. Once you're done with that, just click on OK, and you will see the changes are reflected in this sample pane over here. Excel also allows you to save your theme. So just give some name to your theme. I'll say theme 1, and I'll click on save. So I hope you guys are clear with this. So now coming towards fonts. Just like how you could change the theme colors, Excel also allows you to change the fonts. Now to do this, just go to the page layout tab again and open up the fonts drop down list. From here, you can choose any font of your choice. Not just this, you can also customize your own fonts for the headings and the body. I'll choose some random fonts over here. And then I'll save it with some name. I'll say font style 1. And I'll click on save. Okay, so as you can see on the screen, the fonts have changed accordingly. Apart from all this, Excel also provides a huge set of theme effects such as lines, shadows, reflections, etc. that you can add on. To add effects, all you have to do is open up this effects drop-down list present in page layout and choose any effect of your choice. So one final thing that I want to tell you guys is, you can also save your customized theme. To save your current theme, click on the themes list over here and then click on the save current theme option. Please make a note that the theme you save will be saved in the document themes folder of your local drive in the .thmx format. Once you're done with that, just click on save. For now, I'll just cancel this. So the next time you'll have to make use of the theme, you'll have to just go to the local folder and choose the theme of your choice. So now moving on towards the next topic of this session, which is templates. A template in general is a pattern or a model that forms the base for something. Excel templates help you increase your production rates as they help you save time and effort to create your documents. Now, in order to make use of the Excel templates, all you have to do is click on File, and over here, choose New. Okay, as you scroll down, you can see that Excel provides a number of templates such as the investment tracker, the seasonal photo calendar, etc. You can choose any template of your choice, and you will see that your workbook will be of that pattern. So now moving on towards the next topic, which is graphics. Unlike what many people think, Excel does not just allow you to play around with data, but also allows you to add graphics to it. So to add graphics to your Excel sheet, all you have to do is click on this Insert tab, and from here you can choose any graphic of your choice. So let me just go to Illustrations and choose some shapes. So I'll draw a square over here. So as you can see over here, I've added a shape to my Excel sheet. In case I want to format this shape, all I have to do is select the shape, and from here I can choose any fill color that I want, any outline. So for now I'll just say no outline, and let me give some shape effect. So as you can see over here, I have a shadow. I've changed the color of this, and also I've removed the outline of this shape. So there are many more graphics that you guys can check out for yourself. So similarly, you can also add in images, icons, smart arts, etc. to your documents. So now moving on towards the next topic of this session, which is printing options. Excel sheets provide a number of options to take appropriate printouts. Using these options, you can selectively print your sheet in various ways. Now to open up the Sheet Options pane, all you have to do is click on the Page Layout tab, and from here, open the Page Setup window. From here, click on Sheet, and you will see a number of options that are available to you. The first option, that is Print Area, will allow you to set the area that you need to print. The second option will allow you to set the rows and columns title to appear at the top and towards the left respectively. When you check the grid lines option, grid lines will be added to the printout. Black and white will print the document as black and white or in monochrome. The draft quality option will allow you to print the sheet using the printer's draft quality, and the row and column headings will allow you to print the row and column headings. So the next area deals with the page order. Down then over will print the down pages first, followed by the right pages, and over then down will print the right pages first and then the down pages. Not just this, the page setup tab also has margins. The unprinted regions along the top down and the left right sides are referred to as margins. All MS Excel pages have a border, and if you have selected some border for one page, then the border will be applied to all the pages. That is, you cannot have different margins for each page. So as you can see over here, you can also configure the margin values. So now coming towards the headers and footers. Headers and footers are used to provide some information at the top and at the bottom of a page. A new workbook does not have a header or a footer. In order to add it, all you have to do is open up this pane present in the page setup window, and over here you have a number of options to customize the headers and footers. Once you're done with this, all you have to do is click on the print preview option, and you will be able to see how your page will look like when you print it. So as you can see over here, there are many more options that Excel provides, such as the page orientation, which will be landscape or portrait. The portrait orientation is default and prints the page taller than wide. On the other hand, the landscape orientation prints the sheet wider than tall. Selectively, you can also add page breaks to your printouts. So to know more about the Excel printing options, you can check out Edureka's Excel tutorial video that is available on its YouTube channel. Okay, so now let's move on towards the next very important topic, which is data tables. Data tables in Excel are created to experiment with different values for a formula. You can create both one or two variable data tables in Excel. Data tables are one of the three types of what-if analysis tools available in Excel. So in this advanced tutorial, I'll be showing you guys how to create both one variable and two variable data tables. So as you can see on the screen, I've already prepared some data. Here, I have purchased 16 glasses at the rate of 20 each. So this way, I'll have to pay a total of $320 for 16 glasses. Now, in case I want to create a one variable data table that will show me the prices for different quantities, all I have to do is copy the value present in B3 to some other cell. So I'll just say is equal to B3. So as you can see over here, the value has been copied. Now, what I'm going to do is write down different quantities for this item. So I'll start with 16, 17. I'll just copy the series, guys. And now I'll select this newly created range. Click on the Data tab. And then from this What If Analysis tools, I'm going to choose Data Table. As you can see over here, a new window has opened wherein it's asking me to enter the row input cell and the column input cell. Since I do not have any row input cells, I'll specify the input to be as a column input cell. Since I'm dealing with quantities over here, I'll have to specify the target cell to be B2, and then I'll click on OK. So as you can see over here, I have a data table that has been created for different quantities at the rate of 20 per unit. So there's one thing that's missing over here, which is the dollar sign. Now to add a dollar sign, what I'm going to do is select all these cells, and then from the Home tab and the Numbers group, I'll click on the dollar symbol. Okay, so I hope you guys are clear with this. So now moving on towards a two variable data table. Just like how we created a one variable data table, we can also create a two variable data table. So now to create a two variable data cell, what I'm going to do is copy this value again. And for the rows, I'll specify some quantities again. And for the columns, I'll specify different price ranges. So once this is done, I'll have to select the range just like before, click on the Data tab, and from the What If Analysis tools, select Data Table. So now, since I have both row input as well as column input, my row input target cell will be B1 and the column input target cell will be B2. And now I'll click on OK. So as you can see over here, a data table has been created for two variable values. Now to add the dollar sign, I'll just select all these cells, click on the Home tab, and select the dollar symbol. So I hope you guys are clear with this. So now moving on towards the next topic, which is charts. Charts basically give graphical representation to your data. These charts can visualize numerical values in a very meaningful and easy to understand manner. Charts are a very essential part of Excel and they are improved greatly with every new version of MS Excel. So as you can see on the screen, I already have a table for which I want to create a chart. Okay, so all I'm going to do is select this table. I'll open up the charts pane. And from all charts, I'll select the column chart. Let me also change the design of this. So now I'll click on OK. So as you can see over here, a chart has been prepared for this table. So Excel will also allow you to filter this chart according to your preferences. So in case I want to see only the amount and not the quantity, all I have to do is just unselect this box. Also, I can selectively configure my charts for particular recordings. Not just this, you can further configure your charts by adding in different types of charts and giving it different colors. So as you can see over here, all the changes I'm making over here are reflected in this chart. So I hope you guys are clear with this. So now moving on towards the next topic of this session, which is pivot tables and pivot charts in Excel. A pivot table in Excel is a statistical table that condenses the data of those tables that have extensive information. These tables help you visualize your data based on any of the fields present in your data table. Using these pivot tables, you can visualize your data by changing the fields, rows and columns, add filters, sort your data, etc. So to create a pivot table, all you have to do is select the data for which you intend to create a pivot table, click on the Insert tab, and from here, click on Pivot Tables. So as you can see over here, it shows me the selected range, and also it gives me an option to create the pivot table in a new worksheet or in the existing worksheet. I'll create it in the existing worksheet, and I'll just give some target cell. So as you can see over here, an empty pivot table has been created. Also, the pivot tables field window has opened, which contains all the fields that are available in my table over here. Now, in case I want to add any of these fields to the columns, rows, values, and filters, all I have to do is drag and drop it in that area. So what I'm going to do is add in the amounts and values. I'll keep city as the filters, name of the vendors in rows, and the name of the item as columns. So as you can see over here, a pivot table has been created accordingly. So in case I want to interchange between the row labels and the column labels, all I have to do is drag and drop those fields in the required places. Okay, so as you can see over here, my pivot table changes when I change these fields. Also, in case you want to see any other figures other than the sum, all you have to do is go to the value field settings and choose any of the options that are available over here. So let me just change it from sum to count, and I'll click on OK. Okay, so I hope everyone's clear with this. Let me just change it back to sum again. Okay, and then I'll click on OK. So now, in case I want to create a pivot chart for this pivot table, all I have to do is click on this Insert tab, and from the Charts group, I'll click on Pivot Chart. So as you can see over here, Excel provides a number of pivot charts for me. I'll choose the basic type itself, and I'll choose a different style in this. And then I'll click on OK. So as you can see over here, a pivot chart has been created for me. Also make a note, guys, that the pivot chart created over here has a drop-down list for every field that is present in my pivot table. To know more about pivot tables and pivot charts in Excel, you can check out the pivot tables video of Edureka, which is available on Edureka's YouTube channel. So now moving on towards the next topic, which is data validation. One of the most important aspects of Excel is data validation. This feature, as the name suggests, allows you to configure the cells of an Excel worksheet to accept some particular type of data. Say, for example, you want certain cells in your sheet to accept only dates. You can do this easily using the data validation feature of Excel. So what I'm going to do is open up a new sheet. So what I'm going to do over here is select a few cells, and I'll make this specific to accept only one type of data. Now to do that, I'll have to go to this Data tab, and from the Data tools, I'll have to select Data Validation. So as you can see over here, I have a number of options. So let me just choose whole numbers, and I'll say whole numbers that are greater than 1. So apart from settings in this data validation window, you have two other options, that is input message and error alert. Now this input message section will allow you to enter a message for the user, giving him some details regarding the acceptable data. So here, I'll just type in message as the title, and I'll say enter whole numbers greater than 1. Okay, let me just copy this and I'll tell you why. And I'll paste the same as an error message. And with little modification, I'll just say please over here. Okay. The error message section will basically inform the user that he has made some mistake in giving the desired input. So let me just give the title as caution. And I'll click on OK. So now, if you select any of these cells, you will first see a message asking the user to enter whole numbers that are greater than 1. So in case if I enter a value, say 10, it has accepted this value. Now, let me enter a different value and see what happens. So now let me enter some decimal value and see what happens. So I'll say 2.1. As you can see over here, a new window has opened with caution as its title, and it says, please enter whole numbers that are greater than 1. So I hope you guys are clear with this. So now moving on towards the next topic, which is data filtering. Filtering data refers to fetching some particular data that meets some given criteria. So as you can see on the screen, I've already prepared a table. Now in case I want to filter out data only for Washington City, all I have to do is select this column. And from this data tab, I'll have to select this filter option. So as you can see over here, once I've selected this option, I have a drop-down list that has been created over here. When I open this drop-down list, you can see over here that all the cities have been selected. So I'll just unselect this and I'll just select Washington. And now I'll click on OK. So as you can see, the data only for Washington City has been filtered out. So here I've applied a filter just to one column. In case I want to filter data based on multiple criteria, all I have to do is select those columns and then I'll have to add filters to them. I'll filter out the data for New York. And the item I'll say should be apples. So as you can see over here, I've filtered out data based on the items as well as the city. So I'll just undo the changes. So now let's move on towards the next topic, which is sorting. Data sorting in Excel refers to arranging the data rows on the basis of the data present in the columns. So for example, you can arrange the names from A to Z or arrange numbers from ascending and descending orders. So for the same table that I've taken previously, in case I want to sort the names from A to Z, all I have to do is select this name column, and from the data tab, I'll have to choose the sort command. So as you can see over here, it has opened up a window asking me if I want to expand the selection or continue with the current selection. If I expand the selection, it will select the complete table, and if I have to sort based only on the current selection, all I have to do is select the second option and click on sort. Over here, next, it will open another window wherein you can add levels, delete levels, or even copy levels. So what I'm going to do is sort from A to Z, and the column will be C. Since I've chosen just one column, it's going to show only one column in the drop-down list over here, and then I'll click on OK. So as you can see over here, the names have been arranged from A to Z. So there's one mistake that I made over here. I shouldn't have chosen the name of this column, so I'll just put it back. So what I'm going to do is just undo this. So I'll just select this column again and I'll sort it. So as you can see over here, the changes I made have been reflected on my table. So now moving on towards the next very important topic, which is cross-referencing in Excel. In case you want to look for data present in multiple sheets of your workbook, you can make use of the VLOOKUP function. The VLOOKUP function in Excel can be used to bring forth required data from different spreadsheets as well. However, if you do not have the knowledge of this VLOOKUP function, you can refer to the VLOOKUP in Excel video of Edureka present on Edureka's YouTube channel. So as you can see on the screen, I've already created a table with the names of employees along with their IDs, designations, and the salaries. However, the salary column is not filled and the data for this is present in another sheet. So as you can see over here, my original table is present in sheet 7 and the data is present in sheet 8. Now what I'm going to do is use the VLOOKUP function to fetch the value from sheet 8 to the sheet 7. So over here, the first thing that I'm going to do is type in an equal to sign and I'll write down the VLOOKUP function. Now the first thing that I'll have to do is given a lookup value. In the first case, the name of the employee is John. So I'll write down John, followed by the table array. Now the table array is present in sheet 8, so I'll just go to the sheet 8 and over here I'll select this table. Once I'm done with this, I'll have to specify where the salary is present. So in this table, salary is present in the third column. So I'll specify 3. And since I want it to be an exact match, I'll specify the Boolean value as false. Just to remind you guys, if you do not have an idea of the VLOOKUP function and its syntax, please refer to the VLOOKUP in Excel video of Edureka present on YouTube. So once I'm done with this, I'll just execute this function. And as you can see over here, the salary for John has been retrieved. Now, I'll just have to include a dollar symbol. So I'll click on the Home tab. And from here, I'll select the dollar symbol. So as you can see over here, the salary of John has been retrieved as $1,000. Now, in case I want to retrieve the values for all the other employees, the first thing that I'll have to do is make a small change in this name over here. And instead of giving a name, I'll give the cell reference as the lookup value. So what I'm going to do is just delete this. And now I'll specify the lookup value to be as this target cell. Table array is present in sheet 8. Column will be 3. And it'll be false for an exact match. So as you can see over here, the value is still retrieved when I specified the cell address as the target lookup value. Now what I'm going to do is copy this for all the other employees. So as you can see over here, my table has been completed. Now moving on towards a very important topic, that is macros. Macros are a must to be learned in Excel. Using these macros, you can automate the tasks that you perform regularly by just recording them as a macro. A macro in Excel is basically an action or a set of them that can be performed again and again automatically. So in order to record a macro, all you have to do is click on this View tab. And from here, select Macros. From this drop-down list, click on Record Macro and give a name to this. I'll keep it as Macro 1. Also, you can specify a shortcut key for this macro. For now, I'm not going to give any shortcut key and I'll just click on OK. So now, Excel is going to record all the tasks that you perform. Be careful to record the exact tasks. So in this table, the first thing that I'm going to do is sort the names from A to Z. So to do that, I'll have to click on Data and select the Sort option. So now my names have been sorted. For the items and cities, I'll just add in some filters. And I'll filter out the data for, say, some 2 fruits, apples and bananas. Cities, I'll keep it as New York and Chicago. So as you can see over here, I sorted the data, I filtered the items and the cities. So now I'll just create a chart for this. So I'll just select this data. I'll open up charts. And then I'll click on OK. So basically, the first thing I did was sorting, then filtering, and then creating a chart for the filtered data. So if this is the final task that I have to automate, all I have to do is get back to this View tab. And from this Macros drop-down list, I'll have to stop recording. You can also see all the macros that you've recorded from this View Macros option that is present over here. And in case you want to run any of the macros, just open the Macros pane. Select any macro that you've already recorded and click on Run. So I hope everyone's clear till here. Now moving on towards the last topic of this session, which is language translation. Excel brilliantly allows users to translate the data into different languages. It can auto-detect the language present in your data and then convert it into desired languages that is present in Excel's list of languages. So now just to show this to you guys, what I'm going to do is open up a new sheet. And over here, I'll just type in Hello World. Now, I'll open the Review tab. From the Review tab over here, I'll select Translate. And as you can see, a translator window has been opened over here. You can see that Excel has detected that Hello World is in English, and I have a drop-down list for me to select any of the languages that I prefer to see this in. Let me just choose a few languages and see what happens. So when I select Arabic, I have Hello World shown in Arabic over here. There are a number of languages which you can choose from, and whichever language you want to choose, just select that option and you will see the required changes made over here.
Here is a simple question for you guys. Which of the following is an advanced feature of Excel for analyzing data? Your options are A. Conditional formatting, B. Simple addition, C. Cell merging, or D. Basic text editing. If you know the correct answer, please comment down below. We just wrap up with advanced Excel techniques. Next, we will start with a Power BI tutorial for beginners, which will introduce you to Power BI and its basic functionalities.
Now, why should you choose Power BI? Before I answer this question, I would like to answer something a little more fundamental. Let's start by addressing the most essential and fundamental question: what exactly is business intelligence? Now, in an age where business intelligence has become a bigger domain than most trending technologies, if you ask 20 different people what the term means, you're likely to get at least 10 different answers. So let me try and put it in the simplest of terms without having to lose the technicality of it. Business intelligence is a set of techniques and tools for the transformation of your raw data, meaning your data sets, into meaningful and useful information to take important business decisions. To put it simply, business intelligence is the technology which gets the right data to the right people at the right time so that they can take more effective business decisions. Over the years, the process of business intelligence has grown and adapted to help solve almost all the challenges while dealing with data by involving newer tools and techniques. The change that business intelligence has seen over years can be divided into 3 waves. So let us continue with our tutorial and take a look at the first wave, IT to end user, or the technical wave. During the first wave of business intelligence, the end user had to be dependent on the IT department for data insights. This is because it was not possible for end users to create visualizations or reports on their own, as tools available required some technical or coding knowledge. This dependence on the IT department for insights resulted in more efforts and time consumption to get the updates done. Now the second wave, which is analyst to end user, or the self-service wave. Now the second wave gave analysts access to BI. Now people with some knowledge of analytics could use BI tools. This meant more teams had the access to BI and more people could have better data insights. This eased the role of the IT teams. And finally, the third wave, which meant everyone, which means the power lied in the hands of the end user. The third wave made it easier to access data and create reports and visuals to get better business insights. The introduction of tools like Power BI, Tableau, QlikView, and Spotfire made this transition easy. Now, anybody who had a basic understanding of data could create reports to build intuitive and shareable dashboards. This was about the 3 waves of BI. And in the third view came a very important aspect: data visualization. Now, data visualization is nothing but the pictorial or graphical representation of information or data. It provides insights into complex data sets by communicating the key aspects in a more intuitive and meaningful way. Data visualization lies at the intersection of design, communication, and information service. Even though your data visualization has been termed as the key skill for research in the 21st century, it goes way, way back. It existed in the late 18th century and can be traced back to when William Playfair invented the geometrical charts. His bar charts were used to represent Scotland's imports and exports of 17 countries in 1781. These bar charts constituted a pure solution to the problem of discrete quantitative comparison. Now, obviously, we have grown to learn about more and more charts as the years pass by. We also have a few hybrid charts to make our jobs easier and our calculations more granular. The way our human brain processes the information is easier to use images, charts, and graphs to understand and visualize large amounts of complex data than going through tons and tons of spreadsheets on reports. Take the quote, "An image is worth 1,000 words," for example. This is completely true because as a human mind, images aren't just a mere collection of pixels. they hold a lot of information. This information in visual form is easy to understand than reading the same facts in text or number form. So let me give you an example. Suppose there's a company which deals with a lot of products, like Amazon, and it's widespread over the world and has many vendors that sell through this platform. So obviously, there's a lot of data being generated in a lot of different formats. People use Excel, Access, different databases, SQL Server, so on and so forth. Some people even make all these spreadsheets and upload it to the web. So obviously, all that has to be brought to a single platform to analyze. And then these are the reports that go to the CEOs, CFOs, and the CXO position, all the big people in Amazon. Now, you can't just take 1 million or 10 million rows of data to a person to look at and infer something, right? You need them to know what's going on. What is going on inside the company? How is the market outside of the company? And this cannot be done with hundreds and thousands of numbers. This is where data visualization comes into picture. It's about giving them an idea of what's going on inside their company in different departments without having to look at tons and tons of numbers. Well-designed graphics have the power to put this complicated data into simple pictures. And this is where modern BI wins. Data visualization is a quick and easy way to convey concepts or information in a universal manner. It can help to 1. Identify key areas and hidden patterns, 2. Get factors that give better customer insights, 3. Analyze and associate data and products properly, and finally, make proper predictions. And obviously, presentation has a big role to play in this. So pardon me for my analogy, but if this was a beauty contest, let's go ahead and look at our winner. Now let's see why we need Power BI. Now there are a few points that make Power BI one of the most prominent tools for data visualization. Now this tutorial would be incomplete without understanding these points. Firstly, Power BI can spot trends in real time. Traditional BI tools like Tableau or QlikView restrict you to historical analysis. By using Power BI, you can access real-time information so you can identify trends early. By doing so, you can identify issues and improve performance. Secondly, Power BI can automatically search hidden insights. With Power BI, you can auto-search datasets for hidden insights in seconds with quick insights. Users can simply ask questions and Power BI Q&A will answer their questions with an immediate effect. Third, advanced analytics and custom visualizations. With custom visuals, Power BI allows you to visualize data in almost every way possible. As long as you can imagine it, you can put it on your dashboard. Thus, you're not limited to something that lies in a box. Finally, Power BI is enterprise ready. With Power BI and Power BI Desktop, you can securely connect to your own on-premises data sources. With the on-premises data gateway, you can connect live to your SQL server and other data sources. It gives you a secure, scalable, and reliable enterprise-grade information technology. And these mentioned reasons make Power BI very important in context of data visualization. So who can use Power BI? IT professionals, developers, companies big and small, subject matter experts, and plain analytics enthusiasts. As long as you want to, you can all use Power BI. Now let's continue to understand this by knowing what is Power BI. Now Power BI as a name has been in the BI market for quite a long time. The Microsoft team has worked for a long time to build a big umbrella called Power BI. And this umbrella is a combination of strong visualization, data analysis, data sharing, aggregating, and cloud integration. To define it, Power BI is a business analytics service provided by Microsoft. It provides interactive visualization with self-service business intelligence capabilities where end users can create reports and dashboards by themselves without having to depend on information technology staff or database administrators. It also gives you cloud-based BI services known as Power BI services. along with a desktop-based inference called Power BI Desktop. It offers data warehouse capabilities using data prep, data discovery, and interactive dashboards. In March of 2016, Microsoft released an additional service called Power BI Embedded on its Azure cloud platform, which enables the user to analyze data easily and perform various ETL operations and deliver reports with Power BI. The Power BI gateways let you connect with Access, Excel, SQL Server databases, analytics services, and many other sources to your dashboard in Power BI. And reporting portals embed Power BI reports and dashboards to give you a unified experience. What you see on your screens right now shows Power BI's general workflow. You have thousands of data sources which are being connected to Power BI Desktop, which then can be published into the service and gives you an option of connecting your organizational data live through your Power BI gateways. In the end, this can all be accessed through your tablets, laptops, and cell phones with you, your colleagues, and everybody involved in your business decision. Now that you understand what Power BI is, let's go ahead and look at a few of its benefits and why are we using this. Firstly, it has pre-built dashboards and reports for popular software-as-a-service solutions. Power BI helps you create powerful visualizations in the form of dashboards and reports, and you can do them without any technical knowledge at all. All you need to do is have a little bit of analytical sense, and you can use this service to your advantage. Next, it has real-time dashboard updates. As I had mentioned before, Power BI works real-time and it can forecast trends in the coming few years as well. Third, secure live connection to your data sources on premises and in the cloud. Through the Power BI gateway, you can establish connections that are secure and your organizational data can be connected to live every time that you want to. The best part about this is it is scalable and very, very secure. Fourth, Power BI also provides you intuitive data exploration using natural language query. You do not have to know the query language to explore your data in Power BI. Just using your everyday English or your natural language, data exploration can be made possible. Fifth, integration with familiar Microsoft products to utilize commitment for scale. Power BI can integrate with a number of sources and a number of Microsoft products, which makes it highly scalable compared to other BI tools. And finally, immediate deployment. Power BI is known for its quick deployment, which makes your job quick as well as easy when you have to take critical business decisions. And that was all about Power BI. In the section ahead, we are going to discuss a few components of Power BI. Now, Power BI has a few components. You have Power Query, Power Pivot, Power View, Power Map, Data Catalog, Data Management Gateway, Power BI Q&A, and Service. Starting up, we have Power Query. Now, this is a component which can be used to search and access and transform public and internal data sources. It is the Microsoft's data connectivity and data preparation technology, which enables business users to seamlessly access data stored in hundreds of data sources and reshape it to fit their needs with an easy-to-use, engaging, and no-code user experience. Next, we have Power Pivot. Now, you can use this for data modeling, for in-memory analytics. It extends a local instance of Microsoft Analyst Services Tabular that is embedded directly into your workbook. It enables you to import millions of rows of data from multiple data sources into a single Power BI workbook. It helps you create relationships between heterogeneous data, create calculated columns and measures using formulas, and build pivot tables and pivot charts and further analyze the data. Then you have Power View, which is a data visualization technology that lets you create interactive charts, graphs, maps, and other visuals that bring your data to life. Now, Power View is available in Power BI, Excel, and other analysis services from Microsoft. Then you have Power Map, which is also another feature in Excel. It is for exploring map and time-based data. It lets you plot geographic and temporal data, visually analyze that data in 3D, and create cinematic tours to share with others. Next, you have Power BI Services. So this is a collection of apps, dashboards, and reports built to deliver key metrics for your organization. These apps are interactive with each other and helps customers work with their own content. Then we have Power BI Q&A. It's basically a feature which helps you ask questions and get immediate answers. Sometimes the fastest way to get an answer from your data is to ask the question using natural language. So you can use Q&A to explore your data using intuitive natural language capabilities and receive answers in the form of charts and graphs. Next, you have the Data Management Gateway. So basically what this does is it connects your on-premise servers with your Power BI in the cloud. If you want to refresh your data in the cloud with the data that is on the premise, you will need to have the Data Management Gateway configured and available to your tenant. And that is how this works. And finally, we have our Power BI Data Catalog. Now this contains the metadata for felicitated search functionality in Power BI. Now your metadata gets stored in Power BI Data Catalog in the cloud for a shared query. It gives you a search access list for the query to determine which users and security groups can find and use this shared query. Now that we've seen how the components work, let's continue with this tutorial and understand the architecture of Power BI. Now, broadly describing, Power BI's architecture has three phases. The first two phases partially use ETL to handle data, and then you have the presentation of your data. So let's take a look at these phases one by one. First, you have data integration. An organization can be required to deal with data that comes in from different sources, as I had earlier explained in my Amazon example. Now, this data comes from different sources and can be in different file formats. Now, the data is first extracted from these sources, which can be your different servers or databases, so on and so forth, from wherever you can pull in data. This data is then integrated in a standard format and then stored at a common area called as a staging area. Then we go to our second step, data processing. Now, the integrated data is still not ready for visualization because the data needs processing before it can be presented. Now, this data is pre-processed or cleaned, as we can call it. This is also known as transformation of data. For example, missing values or redundant values are removed from the data set. After the data set is cleaned, business rules are applied to the data and it is transformed into presentable data. Now, this data is then loaded into a data warehouse. And now that you have extracted, transformed, and loaded data, your ETL is complete. Finally, you have data presentation. So once all this data is loaded and transformed, it can be visualized much better with use of various visualizations that Power BI has to offer. You use reports, dashboards, and help one represent data in a more intuitive manner. These visuals, reports, help business end users take important business decisions based on these insights. With that, let's move on to the building blocks of Power BI, where we can talk a little more about these insights. Now, everything you do in Power BI can be broken down into the following building blocks. A good understanding of these building blocks would help you understand concepts and will let you create detailed and complex reports. So the basic building blocks of Power BI are the following. You have visualizations, data sets, reports, dashboards, and tiles. First up, you have a visualization. A visual representation in the form of graphs and charts and maps of a data is called visualization. For example, a chart or a graph can be used to represent data visually. Power BI gives you different visualization types which keep getting updated with time. Now, some of the commonly used visualizations are map representation, card visualization, stacked area chart, tree map, and pie chart. Now, these visualizations can be simple or complex. However, Visualizations aim at presenting data in such a way that it gives you more insight in the context, which is otherwise difficult to discern from simple data files. Next, we have datasets. Now we know that a dataset is nothing but a collection of data or information in the form of spreadsheets. Now Power BI can harness this data to create visualizations. It can be a simple dataset or a combination of many different sources which can be filtered and combined to provide a different dataset altogether. For example, you can pull together data from many different sources like different database fields, an Excel table, and online results of some email campaign to create your dataset. Having said that, you may want to filter your data before you bring it into Power BI. Filtering lets you focus on the data that actually matters. With your dataset ready, you are now free to create visualizations and display different portions of the data that's set in different ways. And with this, you gain insights. Next, you have reports. Now, a collection of visualizations that appear together on one or more pages is a report in Power BI. In a collection of items, these reports combine to form a workbook and are all related to each other. You can create visualizations on multiple different pages if necessary and arrange them in a way that best suits your interest. What you see on your screen is the image of a sample report. Next, you have dashboards. Now, Power BI dashboard is a single page interface. It is often called a canvas that uses visualizations to tell a story. Now, a lot of you might be confused within the difference between a report and a dashboard. Now, this is because it is limited to one page. A well-designed dashboard contains only the most important elements of your story or your report. The visualizations you see on your dashboard are called tiles and are pinned to the dashboard from the reports. So in a way, you can say that your dashboard is a compressed version of large reports that you are going to present. Now, because this is limited to just one page, a well-designed dashboard contains only the most important elements of that story. The visualizations you see on the dashboard are called tiles and are pinned to the dashboard from reports. In Power BI, a tile is a single visualization found in your report or on a dashboard. It's the rectangular box that contains each individual visual. Now, Power BI gives you the freedom to move or arrange tiles so you can present the data the way you want to. Even while you're creating a report or dashboard, you can make the tiles bigger, change their height or width, and snug them up to other tiles any way you want. So this was all about Power BI's building blocks. Now I'm going to take this Power BI tutorial a step further with a demonstration of creating a simple report using Power BI. Microsoft Power BI is a suite of business analytics tools that helps you create and share actionable, intuitive reports for business insights. And now I'm going to show you how you can put your data to work with Power BI. We'll go through the basics of data visualizations and dashboards, and we'll go through how to create and modify data visualizations. We'll also look at how to join data from multiple sources and build a dashboard report to share with our colleagues. So, what we're going to cover today, in part 1, we'll be getting started using it. Part 2 will talk about joining data from multiple sources, and part 3 will talk about building and sharing a dashboard. And at the end of this, we'll have a demo. So part 1, getting started. In this section, we'll learn how to install the application. We'll talk about importing data from Excel to Power BI. We'll create and modify simple visualization, and we will save our report and publish to Power BI service. Now let's talk about installing the laptop application. First, what you want to do is go to http://app.powerbi.com. Here you'll sign in with your credentials. You'll run a simple wizard to install the application. Then you'll look for the download icon. It is here. It's an arrow pointing down with a line underneath it. So run that wizard. And the Power BI will be ready to launch, and it will automatically launch the first time that you run it. When you run it, you'll get this start screen. It is black and yellow. and you'll have access to forums, the Power BI blog, various tutorials, as well as some videos that you can watch and learn. But you don't need any of that videos because you have this one video. So let's go ahead. You can also access the Get Data functionality here from this screen. If you decide that you never want to see it again, you'll notice a checkbox in the lower yellow part of the screen that says Show this page on startup. Simply uncheck that box and you won't ever see it again when you run the application. So next up, you'll want to install some data. After you've installed the application, you're going to go to the Get Data button and you'll be able to pull in data depending on what you're using. You may be using data from Excel like I'll be doing further in this demo, or you may be using data from an example, a SQL Server database, or an Access database. The options you have for pulling in data are a plethora. So there's a lot of available data sets, and we'll be sticking with the Excel for my demo, but keep in mind that you can pull data from a lot of different places. So after you have selected what data you're going to be using, you'll be given the option. Then in the navigation window, to select the exact data set what you want to pull, you'll check mark a box. For example, right here we have this box checked. And then you'll have the option to load the data or edit the data in the query editor. You'll probably want to edit the data in the query editor just to make sure that you'll pull in exactly what you want. Once you have pulled in the data that you want, you'll see that the data up here as a fields list on the right hand side of the application. As you can see here in the sample data, we have a budget business team delivery day, but whatever you've pulled in will appear in the fields list. And you'll be able to use that data in the fields list to create your visualizations. So let's start here by creating a simple visualization. This is a very simple visual. It's simply a column chart with one number. So it's one column right here. It's the budget field that we pulled in. Drag whatever field that you want from your data. There is no strict rule to it, and make a visualization. You'll end up with a column chart like this. You can also see that there are a variety of charts available there. And then in the visualization box, you will be able to make modifications to it. And like I said, this right here is a bar chart, but you'll be able to make pie charts, column charts, line charts, and a variety of other visualizations in Power BI. A variety of modifications are available for visualizations too right here. We've highlighted where you can click on the lower right hand corner of the visualization and drag it up to make the visualization bigger or smaller. For example, you might want to make it smaller because maybe you want to put more than one visualization on the canvas there, or you may be wanting to make it large so that it can take up the entire canvas. So you can drag around the corners of your visualization to make it the size that you want. The format that Power BI saves reports says .pbix file. This is not the best way to share a report, but it's definitely the best way to save your work. If you're in the middle of something, you can go ahead and save your report as a .pbix on your machine or your OneDrive. Maybe even your OneDrive for Business or a SharePoint online set, wherever you're saving it. And so that way you'll be able to pick up later. If you're in the middle of building a Power BI report now, if you want to share your results of someone, the best way to do that is to publish the Power BI service. And you'll be able to do that using the Publish button, that is the ribbon, and that button is on the Home tab on the furthest right. We have highlighted it on the slide there. And then when the publishing is complete, you'll be given a link that you can click on in order to go see your workbook or your report. This will be there on your Power BI website, and you'll probably want to do that just to make sure it looks as good as you wanted it to in your tool. So this is the PowerBI.com interface. The PowerBI.com interface gets changed from time to time. That is also the reason for this particular tutorial, because it got updated in 2019 recently. It is a cloud service, and when new features come, you may see things in a slightly different place. For example, the search bar here, I believe, is slightly different now. but the gist of it is what we want, and you'll be able to use that search bar once you've published a lot of reports and have a lot of data sets available on your workspace. You'll be able to find them easily using the search bar. Or you can use the functionality of define your recent reports, as well as when you'll be able to manipulate and share them using powerbi.com interface. We're now going to go into part 2, which is using multiple datasets. So now we are going to be using multiple datasets and joining together in this section. We'll talk about adding data from other sources, joining the data from multiple sources, creating more interactive visualizations, as well as updating that published data on the powerbi.com web service. So here we go with getting additional data. Now to get additional data, you do the same thing that you did before. You got your first data set, and it's really not very different from how you did it. You just are having some data you're working with. You'll go to the Get Data button, you'll push it, and our demo will be using Excel, but remember you can pull in data from a variety of sources. It is also good to keep in mind that they don't all have to be the same source. You could be using some data from an Excel spreadsheet, some data from, example, a SQL Server query, or from another database query. You can pull them all together in Power BI, create relationships, and manipulate that data, and create some great visualizations right here, just as you did before. You'll select the data that you want to load, and you'll probably want to edit your query before loading it, just like you did before. So whenever you're loading queries, you want to make sure that you have the data that you want and your data is in the form that you want it in. Before you pull it in, Power BI will load the data that you have selected, and there may be relationships in that data. For example, here we have some actuals and some budget information that we are loading in sample data. But you may have two different tables that you are pulling in, and they both have a month column. For example, in Power BI, the tool is actually smart enough to detect the relationship and join the data together. If it did not auto-detect your relationship, you'll be able to manually create it. But for most times, in my experience, it does it on its own. So I want to introduce here the Modeling tab. It's right next to the Home tab, and with the Modeling tab, what you can do is change some things with the format of your data. You might want to, for example, sort in a different way that then Power BI has already sorted your data, and you might want to change the format. If there's a number you want to change to a currency, or maybe you've accidentally formatted some numbers as text, and then it's important that you notice that you can't do any math because of course you can't do math with text, and your problem then is that it's formatted as text. You can easily go into the Modeling tab and change the format of the data over to the number format. So now you have pulled in data from multiple sources and you want to create some new visualizations. Well, keep in mind that the canvas view here, that's what we've highlighted. On the slide, that is the top of the three icons. You see there on the top, you've got the canvas view. Below that is the Modeling tab that we just talked about. And then there's also the relationship view, and we'll be talking about this as well. And in the demo, you'll be able to create visualizations using all of the sources of your data, and whatever you are using, you'll be able to create visualizations with all of your data combined. And that's one of the really powerful aspects of Power BI. As you create visualizations with your multiple data sources, you'll be able to modify those just like you did before. You can use the handlebars on the visualizations to drag and drop the corners around. Make the larger, smaller fit how you want to. Also keep in mind that you can have more than one canvas page. You certainly don't need to cram all of your visualizations onto one page. If you've used Excel before, it's kind of like making a new sheet. You'll see the bottom of the page and there's a little plus sign, and you'll be able to create a second, a third, a fourth canvas page and add more visualizations into the same report using multiple canvas pages. And made a couple of visualizations with Power BI. And right here, what I want is to highlight the fact that you can change the colors on your report to highlight certain things, for example. Right here, we've added some black to the columns, and Power BI actually gives you really strong granular control over, what your charts look like. For example, in a pie chart, you'd even have the granular control to change the color of one slice of the pie. So you really have a strong control on how your visualizations look right here. Now that you're done pulling in data from multiple sources, you're probably ready to publish. Now, whether you're publishing just for the first time or publishing again, it's just as easy. You simply go to the Publish button that's on the Home tab. Now, if this is your first time publishing, simply just publish it and then click on the link to go take a look at it. If it's your second time publishing, you'll be either given a choice to say overwrite a previous publication, or you're going to rename it and publish it again as something else. You'll get this wizard opening up, giving you the option to go to your published report. You'll go into powerbi.com's interface and view it. With that, we're moving into part 3. Now, this is the creation and sharing of dashboards. In this section, we'll talk about creating a dashboard, and we'll talk about pinning visualizations to that dashboard. We'll talk about modifying a dashboard, and we'll talk about sharing that dashboard with your colleagues or customers or business partners. So you obviously might be asking a logical question, what exactly is it? Well, most of you probably kind of know what a dashboard is, but what is it exactly? And at this point, it might be useful to make a distinguishing characteristic between data sources, reports, and dashboards. Now, we all know what our data sources are. Those are our Excel spreadsheets, SQL Server queries, or other data-based queries. When we've pulled in numbers and text and other types of data, then we've built a report on top of it using Power BI. Now, once we have created visualizations on that data, a dashboard is a really important aspect. It really is just a type of report, and what it is that visualizations from other Power BI reports are all pinned to one specific place that can be updated in real time so that your business partners and your business decision makers, your customers and your colleagues can look at the dashboard and instantly have the information they need to make those important business decisions. Basically, if you bring all your Power BI reports regarding that particular decision and put them into one canvas, that is when you have a dashboard. It is a compact form of your complete report. So now, how do you create a dashboard? The easiest way to create a dashboard is to simply click on the pin icon, which you'll see on your visualization, and we'll then give you the option to create a dashboard. You'll also see, as we show you on the screen here, there's a plus sign next to the word dashboards in the Power BI interface. You'll create a new dashboard there too. Once you've created that dashboard, you can continue to pin visualizations to it. Here we go. There's that pin icon there, and you'll be able to click that and attach visualizations to your dashboard. And once you've done that, you'll be able to move them around and make it look like how you want it to look like. Eventually, of course, you'll have to share that dashboard with whoever needs to see it. The pin icon will ask you which dashboard you want to pin it to. Do you want to pin it to an existing dashboard or a new dashboard? If you need a new one, go ahead and select that. But you're building one dashboard at a time, and you're probably going to be sticking with your existing dashboard for a few visualizations at least. You can view your new dashboard with your visualizations, of course, and you want to look at it before you share it. Just to make sure that it looks how you want it to, go ahead and click and share and send it to some of your colleagues. You can modify your dashboard anytime, and you'll be able to click on the corners of your visualizations to make them larger or smaller, just like you would want it. Now, you won't have quite the degree of freedom you did with the canvas though. There are certain size settings for these visualizations. They can be so big, but you can't choose exactly how big you want them, like you could in the canvas. When you're in the web view, the predefined sizes is what they are called. When you're finally ready to share your dashboard, go ahead and click the sharing icon. So you'll type in the names or email addresses of the people you want to share it with. If you're dealing with a circumstance where you've got an internal and the global address list, you'll be able to simply type names from that. Or if you're sharing externally, you may need to use email addresses, and you'll type those in and go ahead and click share. You'll notice you have some options here, and you can allow the recipients also to share your dashboard. And generally, you do want to send an email notification when you share something with them. So then they'll know that it's shared with them and they'll be able to go access it. There's an option you can check as well. You can also share your dashboard once again by simply copying and pasting the URL. Once you've clicked that share button and added the person's email address or their name and shared it with them, even if they lose the link or they forget about it, they will never have to go through that process again. You'll actually just be able to copy that URL and paste it, and they can view your dashboard. Apart from that, there is also a QR code generated for every report for the very same purpose. Okay, so now we'll be going on to the demo, and every step that I had just explained to you, I am going to do it on Power BI and show it to you. So now we're going to start out by showing you how to download the application. You could either go to app.powerbi.com, and this will take you to the organization site. You have to sign in, and you'll sign in using your own organizational credentials, or you can do the same by going to powerbi.microsoft.com/downloads. Here you are going to select sign up for free and use your organizational credentials to sign up here. Then you're going to go to products, Power BI desktop, click on it, and then it'll open the Microsoft Store, and you can download it from there, or you have the download option right here at the bottom of your page. You're going to click on it and it will open the Microsoft Store. You'll see a button like this, an arrow and a line below it. You can click on that. You can get it for free. And then once the product is installed, you can go ahead and launch it. Then you have to click a couple of nexts, and that is how you will download Power BI Desktop. I actually wouldn't go through it and install it on this machine, as I've already got it. As you can see, it says the product is installed. But what you want to do is click run, and a simple wizard will open up, and what you basically do is just click next several times and you'll be able to install the application on your machine. Okay, so I'll just go ahead and close this, and I'm going to open the Power BI desktop. And this is the Power BI desktop opened up, and when you start, you're going to get this bumblebee colored theme, yellow and black start screen. Here on your left, you have your Get Data button, your recent sources, and open other reports. Here you have a couple of tutorials which will help you guide you through how to use your desktop app. You can go to forums, read a couple of blogs, look at what other people are doing with Microsoft Power BI. And as I had mentioned before, if you do not want the screen on your startup, go down. I will uncheck this box, and then you can close it. And now your startup screen will no longer show when you open up the application. So we'll go ahead and move on. So this is your Power BI desktop application, and I'm going to start by pulling in some data because this is Power BI and data visualization, and it's kind of very useless if you have no data. So we'll go ahead and pull some in. So I'm going to pull in a few Excel sheets. I'll go to Get Data here, and here you see the most common options are here. You have Excel, you have Power BI datasets, data flows, SQL Server, Analyst services, CSV, web, so on and so forth. So I'm just going to go down here and click on More, just to show you the full list of options that you have to start out with this particular tool. Of course, you have your Excel, you have your text files, your CSV files, maybe XML, you have SQL Server, you have Access, you have a wide variety of databases. Here you can select Azure, you have Azure SQL Database, a bunch of other options. You have online services, you have Dynamics 365, you've got Facebook, Google Analytics. So now this is how your Power BI desktop's interface looks. This area over here on your left panel, if you can see where I am highlighting, shows the report, the data, and the relationship workspaces. By default, the report workspace will be open, which is this canvas looking thing right here. Below the report workspace is the data workspace, which is used to see your imported data set. And the last tab is the relations tab, which gives you the relationship between different variables in a data set. That is just in case you import more than one data set. On the right hand side, you will see your visualizations pane and your fields pane. So we are going to start out by importing data. So let us import a sheet. Here you will get the options for your most commonly used formats of spreadsheets. You have your Excel, Power BI datasets, data flows, SQL Server. But I just go down and click on more so you can see all the different options available to you. You have your basic Excel, CSV, XML, and JSON files. If you go to file types, these are the ones which you import from your system. Then you have databases, you have your SQL Server database, Access, MySQL, PostGRE, so on and so forth. Then you have Power BI's sample data sets and data flows. You can also connect to Azure. Here's a wide option of databases. You have your Azure SQL database, data warehouse, services database, so on and so forth. Then you can connect to online services. You have your Dynamics. You can even pull in data from Facebook. And here are a few formats of data which are still there in their beta phases, like Twilio, tyGraph, Web Trends, so on and so forth. And then you have your other data types. Apart from that, you can also connect to Spark, R, and your Python scripts and pull in data from there. So I'm going to go up and select Excel because my data type is Excel, but you can go ahead and connect to any data type that you want. Just going to go connect, and I have a financial sample. So I'm going to go ahead and add the finance data set. And it's going to lead you to something like this. It's going to show you a preview of what your data looks like. Then it gives you these options in the bottom. You can either choose to edit or load the data. I am going to load the data. It'll take some time to load the data onto your model. And with that, you are done. This dataset won't be needing any editing. But just in case it did, you could go right here to your data view and you can make edits to this dataset. It's always a good practice to name your columns according to what is contained in them. If you take a look at this data, you would understand it. It's a simple data set about a few countries and their sales in general. On the right, you can see all the fields that there are in this particular data set. So now what I'm going to do is I am going to go to my workspace and create a simple report. So the first step is to select a visualization. I'd be using a clustered column chart visualization. So it is this one right here. You can make it as large or as tiny as you want it to. I'm just pulling up the size so that it's easily visible to all of you. So now that we have selected a visualization, I am going to visualize sales and profit on the y-axis and the date on the x-axis. So I'm going to bring down the date to axis, which is my x-axis, and I'm going to bring my sales to the values field. Now you can even drag and drop these fields. Suppose I pick profit, I can just drag and drop it and it'll form a graph of its own. But that is a story for a different day. Now you can resize this visualization just how you want it. This is how I want it, so I'm going to keep it like this. Now I'm going to be making use of the clustered type and I'm going to bring in something else for the y-axis. So I'm going to bring in profit. So you can see that the black ones are the profit columns and the green ones are your sales columns, right? So you can also change the graphics based on the timelines just by clicking. I am going to be changing the yearly representation of data to the monthly representation just by crossing out the rest of the options. I'm going to keep it as month, and I'm going to extend this graph so that you have better visibility. Also below the visualizations panel, you have this paint roller sort of icon, which is your formats tab. You can use different color schemes to make your visualization more appealing and insightful. I'm just going to go to data colors and change this green to, let's say, yellow to match the Power BI color scheme. I'm going to keep it that way. And this image shows how you can basically change the color of the fields used in the visualization. Apart from that, if we went back to this particular fields tab, you can perform statistical operations like calculating mean, median, sum, and even filter the data by various parameters using this tab. You can go down to filters. You have your visual level filters, page level filters, report level filters, and drill through. It will help you aggregate your data before you use it in any visualization. And with that, we have successfully created a visualization. Now, creating visualizations in Power BI is as simple as this. You could either drag and drop. Because this is a smart tool, it will 9 out of 10 times get what you want it to. But for the remaining one time, you can always use the Fields tab. So I hope by now you might get comfortable with the idea enough to create visualizations on your own. I'm going to show a few other visualizations, so it will help you get comfortable with it. Now we have this. I'm just going to move this down here and show you some other fun stuff. So let me put in a pie chart over here. Let's see what we can do. I'm going to put in the different countries, and let me put in the sales values. And it will show me Mexico, Germany, France, Canada, and the United States, and how much sales have they gotten through the years. I can also click on each of this pie and see the value of the country's sales being reflected on this other graph. And this is called cross-highlighting. Now let's see what else. Now you can also use a tree map, so I'm going to go ahead and do that. And get your country and sales. Your tree map is basically like your pie chart, but it's much easier to visualize as it is more organized. And this is just about 5 countries, but if you had more countries, a pie chart wouldn't be of much help. In such case, you are going to be using a tree map. So you can choose the visuals that suit your requirement and experiment accordingly. There are a lot of visualizations to try and experiment. Also, when it comes to visualizations, no two individuals visualize data in the same way. So your reports may turn out differently than mine. But Power BI helps you create and edit reports according to your comfort and ease. Now here's a few tips before you get into visualization. For that, I'll have to go to this data view. First thing, you have to name the columns because you're building dashboards for a user. And all the naming conventions and data types are going to appear at the surface to your user, and you want it to be as interactive as possible. So if there's a column which has names of countries, name it country. If a column which has names of products, name it products. Units sold, manufacturing price, sales price, every column name should give you an idea of what is there in that particular field or column. Second thing, anything that's not absolutely necessary in the model, delete it. As you can see, I'm going to be using every possible detail that is there in this data set. If I had blank values or null values or a column which I was not going to be using, I would have deleted it by now. Because that's going to contribute to the size of the model and take up way more system resources while processing. Here I have nothing to delete, but I think if you do have columns to delete, go ahead and delete them. This practice might not seem that useful, but trust me, it is one of the best practices to own. Another thing I'll be doing is data types. Numbers have to be numbers and geographical data has to be geographical data. So go up to modeling and select the column country and change the data category from uncategorized to country. That way, Power BI knows what kind of data it's actually dealing with. So this looks good. And once you're done with all these transformations, you're pretty much good to go. Another good practice is changing the name of the page. Again, the same theory of renaming columns is renaming your sheet names. So I'm going to name this Introduction, because that is what it was. It was your introduction to using Power BI Desktop. Let us now move ahead and take a look at one last topic before I conclude the session. So we are going to take a look at this use case and understand how Wirepass used Power BI to visualize a massive amount of sensor collected data quickly, easily, and effectively. Now, Wirepass focuses on providing the most reliable, optimized, and scalable device connectivity to its customers. With Wirepass, customers can digitalize their current business processes and innovate for new disruptive models. It also has its headquarters in Tampere, Finland, and offices in France, Germany, South Korea, and the United States. It was established in 2010 in Tampere. Now, it's a big company. What challenges did it face? Now, Wirepass technology collects a wide variety of data through its connectivity service. Every wireless device built on Wirepass software technology can collect and send a huge amount of data. Now, this data is collected in several ways and then stored in a database. Visualizing this data is key to getting an overview of the current state of things tracked by the technology Wirepass. Now, there were a few obstacles to overcome. The data was collected from millions of sources and in different formats. There was difficulty in displaying the large sensor data collected for a parcel tracking service, finding which parcel was at what location and when. And finally, what was the parcel status and how could end users understand the collected IoT data? Wirepass used Power BI to overcome all the above mentioned challenges. So let's go ahead and look at their approach. First, they acquired the data. The data that was imported from different sources in different forms was cleaned up using Power BI and Query Editor. Second, they designed the report using Power BI Desktop. Now, after importing and cleaning up the data from 1 million sensors, Power BI was used to design a dashboard that enabled the customers to get overviews of all the data and enable them to drill down to one single parcel and the parcel history. Third, they created a Power BI workspace. Now, to create the Power BI workspace in Azure, the Power BI CLI was used. Back then, there was no UI available to create workspaces for Power BI in Azure. Therefore, they used the Power BI command line tool for managing Power BI embedded workspace collections. And finally, what they did was they embedded Power BI in a web app. Power BI Embedded enabled developers to embed reports in almost every kind of app. This was the easiest way to embed the report into a website. And the architecture you see right now was used to overcome the overall problem. So first, they acquired data from .csv files for online customers. Second, they acquired data from SQL Server on-premises of the customer not public. Third, they performed ETL on the data they had. Fourth, they designed reports on top of the data they had. Fifth, they created a Power BI workspace. Sixth, they uploaded the .pbix file. And finally, they used the Azure App Service and embedded Power BI to host the report. In conclusion, I would like to say that this was a smart way for Wirepass to bring their IP to the cloud in an easy and fast implementation. The whole project needed limited calling time, consultation, and implementation. For a Bosch connected world, this was an easy demonstration of the complex data based on Azure and Power BI embedded. Since the workshop, Wirepass has won several new customers who are using its products and dashboards powered by Power BI embedded. If you need a detailed understanding of this use case, you can refer to a link which I will leave in the description box below, which will direct you to a page where you can actually see the use case study. Now that we've come to the end of our demonstration, let's take a little look at the Power BI experience with Edureka. Now, as most of you might know, the job vacancy trend of Power BI is on the rise. Microsoft is recognized as a leader in the Gartner's Magic Quadrant for Analytics and Business again this year. Cognizant, Dell, KPMG, Hitachi, and over 45,000 MNCs across 185 countries use Power BI. And not just that, these professionals earn up to a lucrative $114,000 per year according to PayScale. Now, the Microsoft Power BI training at Edureka helps you achieve expertise in business analytics. At the end of this course, you'll master concepts like Power BI Desktop, Power BI DAX, Q&A, content packs, custom visuals, as well as Power BI integrations with the Azure Machine Learning and SQL services. This training introduces you to Power Pivot for data modeling, and this course helps you explore and visualize enterprise data using natural language. Not just that, here you learn at your own pace in your own time from a location at your choice. It helps you get completely industry ready by the end of your training.
Having learned about the basics of Power BI, we will explore how to build Power BI dashboards. This module will teach you how to create interactive and insightful dashboards.
What is Power BI dashboard? A Power BI dashboard is quite simple to understand. It's a single page story that is connecting multiple data sets, making it visually and conceptually meaningful. This one-page visualization in a dashboard is also known as a canvas. Dashboards gather data from multiple sources and systems, then combine them into a single interface for a detailed overview of the business. So to simplify, a single page visualization with multiple charts and graphs to tell a story is called a Power BI dashboard. Let's take an example to understand it more clearly. Suppose a business organization wants to gain profit more, so it can use customer segmentation dashboard. These types of dashboard will give the business organization a view of their customer details like most customer gender or age range to target in such an intelligent way that helps them to take beneficial decisions right away. They can share the dashboard with other departments like finance in a customized way that can ensure organization's most precious asset, that is data security. Why are dashboards powerful? Number 1, data transparency. Data is any company's most important asset. However, it's of no use if no one can understand or access it. A well-designed dashboard provides on-demand access of important metrics. Number 2, access to data. A dashboard gathers multiple data sources, including Excel, into a single interface, meaning to see a detailed overview of your business in one quick glance. It reduces time to compile reports, so overall saving your time. Number 3, interactivity. Some of the best dashboards provide a dynamic experience rather than a static, boring information. You can filter data, interact with charts to see changes over time. This means that you can get as much or as little detail on specific metric. Better decision making. Dashboards provide an unbiased view of each department. So each department can have access to the dashboard and can provide a foundation for further dialogue and great decision making. For example, the sales and marketing department can align their data and experiences to increase customer acquisition and improve demand generation. Hands-on on creating a Power BI dashboard. Now here we are going to create a Power BI dashboard, but number 1 thing to be remembered is we cannot create a dashboard in Power BI desktop. We can create a report there. So first step to do is to create a report. We have this following things going on in the Power BI desktop. Here is where we create the visuals. Here is where we can see the data. And in this segmentation, we can see the data relation. So the lookup table, the center table and everything. So that helps to understand the data. And here we can see the data in an Excel format, so you can see and analyze data, and here is where we are creating the visualization. So first you need to get the data. So here you can see there are many data sources. Although I'm going to be using Excel, but I want to show you there are so many data sources you can connect to. So data sources, there can be a lot of data sources like Azure, database, Power Platform, online services, and lots more. So you can connect to them and then create your visualization. I have my database already, you can see. So first I'm going to choose my chart that I want. So I want KPI, and I'm going to take sales, and for the trend axis I'm going to take date. So as you can see from this visualization that the area chart in the background represents trend of sales over time. So the back of there you can see this is the trend of sales with time, and the figure that is 12 million is the sales for the last month. So you can resize your visual according to your theme and your choice. Also what you can do is you can take advantage of format your visual, and you can change the call out value for the 12 million. So I'm going to change it to purple color. You can see I've changed it. It's just for the theme for your report and just to keep it aesthetically pleasing. So right now, after creating one chart, I'm going to show you how I create even more. So right now I'm going to go back to build visual and going to choose pie chart. And for the pie chart, I'm going to take discount by month name. So okay, so this was actually sales with date. I can just go back, let it be KPI format only. So if you click the visual, then if you choose any visualization, you can change it. Definitely you have to click back and then choose another chart. So I'm going to choose pie chart and then take discounts by month name, and here is my discount by month name. I can resize it, I can change the font color or anything. And now let's create even more visualizations. So let's take the scatter chart, and for this you can see the x-axis, y-axis, legend. I'm going to choose profit for x-axis. For y-axis I'll choose discounts. For the legend I'm going to choose product, and for the size I'm going to choose gross sales. So here you can see I have created this bubble chart, or you can say scatter chart. Going to resize it, and then that's how we are creating our visuals. You can create even more. Let's take line and stacked column chart and select country and gross sales. So we have our scatter chart. You can change the colors of it according to your theme. So suppose if you have yellow and black theme going on, then you might want to stay in a yellow and black theme. Although I have a colorful theme, so I would keep like that. It's just for aesthetics, and it's great if you have good aesthetics to your dashboard and reports. Now, after creating that, what we are going to do is we want to publish this report. So after you are done importing your data set, then choosing visualization, x-axis, y-axis, and then we are creating so many visuals. And then I'm going to show you a cool feature that we can do here is if you click on any single segment on this, every other segments of the other charts are going to correlate with that. And this process is called filter. This filter can only be done on reports. We cannot do it on a dashboard. So if you click on any segment, you can see how it's correlating with other data. So you can play around with the data, understand the data even more. It's quite interesting to do, and it's visual, so definitely it's easy to do. Very easily you can understand the data and how it's going on, and the modeling aspect of it as well. Now after this process, what we want to do is just double click on any chart, then you'll be back to your default. And after creating our visual, we want to publish our report. So all you have to do is click on the publish in the home button, and then you have to click on save, and then just give a name to your report. So I'm going to give it new report and then save it. After saving, you have to choose your workspace where you want to publish it. So I'm going to choose my workspace, and then it's going to publish it. So what's happening here is the online Power BI service is uploading my report in the cloud. So I'll be able to use it. So here you can see a link, right? If you click this link, then you'll be directed to the online Power BI service and you'll be able to open your report there. But one thing to remember is you need to already log in into your account. If you don't do that, you won't be able to access the report. This is just for the security aspect. Now, just because we are talking about this, I also want to mention the fact that why we are using dashboard, why not report? Because as you can see, our report has almost same aesthetics and look, meaning like dashboard. Then why are we using dashboard? So you may want to share your file to your colleague, but if we share our report, they have access to the data and then can make changes. So in other words, there is no security. So the best way to share your report is via the PBI service, that is the Power BI service. And to do this, we need to be logged in into our Power BI account in Power BI desktop. Then on the home button, we have to click publish and then select workspace. So what happens in this process is Power BI is uploading the data up to the cloud in Power BI online service, and you have to click on the link to open it, and you will be able to see your report in Power BI browser. And here we are. So I'm not going to click the link because it will take me to a browser where I'm not logged in. As you can see, it will take me to app.powerbi.com, which is the correct website for the online Power BI. But since I'm not logged in here, so I won't be able to access my report. See, I won't be able to access my report. So what I'll do is I'll just go to my browser where I'm logged in, and I'm going to show you where is my report now. So this is my account. I'm logged in here. It's very important you to have an account here. And then when I click my space where I actually published it, you can see new report. This is my report which I created. And if you look at the report, you can see it's as it is as what I created on my desktop, right? There is no changes. So this is my report, but I am in the online Power BI service website. And right now I'm going to show you how I'm creating dashboard with this report. So I hope you understood how we are publishing the report and how our report is getting directly accessed in the Power BI service directly by using a link. Now after this point, we are going to talk about creating a dashboard. So to create a dashboard, all you need to do is you can just click on edit on your report, and then you can change the visualization for any chart according to your choice. But if you don't want to change any visualization, you can let it stay like that. You can do a lot of things here as well. So after this point, what we want to do is we want to pin the chart. So here you'll see an option, right? This pin visual. So I'm going to click this and I'm going to create a new dashboard. If you already have any existing, you can go ahead with existing. So I'm going to name it It's New. Okay, so this is my dashboard and I'm going to pin this. Again, I'm going to pin more visuals here. So I'm going to pin this one as well. I'm going to pin this one as well. And this gorge visual as well. So after you're done pinning the visuals, you just go to your dashboard. You don't need to make any changes to your report. And you will be able to see your visuals, right? So here are your visuals. You can resize it according to your theme to make it more aesthetically pleasing, and it just helps you to make your dashboard more interesting. So here I'm going to resize it, and you can easily align it. There are so many advanced options to align it, and that's how I'm creating my dashboard. All right, so this is my dashboard. Now what I'm going to show you is some cool features that you can play around with your data on online Power BI service. So after creating the dashboard from the report, you might want to share your dashboard. So all you have to do is click on share, and then you have to enter the name or email address of the user, and then you can choose the options what you want to do with your dashboard. So allow recipients to share this dashboard. If you want them to share, you can check it or else uncheck it. So these are the options. And allow recipients to build content with the data associated with this dashboard. If you want the user to do this, you can let it be checked or else unchecked. But make sure that whomever you're sharing this dashboard with, they have online Power BI account, right? That's most important because there is some security aspect to it as well. So that's what the great thing about online Power BI service. So after sharing, I want to show you some cool features of online Power BI service. So first thing that is very good about it is the Q&A. Okay, so here you can see ask a question about your data. So this Q&A feature is very interesting. All you have to do is write a question. Probably I'm going to write total sales. So I want to know the total sales. So I'm going to enter that, and you can see there's a figure, right? So I don't have to understand the data model, the structure of the data and everything. I just have to write the question and I get the accurate direct answer to it. So that's pretty cool, and it definitely allows you to get quick answers to your questions without understanding the visualization or model structure. So definitely. Now another cool feature on the online Power BI service is that the quick insights. So for the quick insights, all you have to do is go to your workspace, and then whichever report you just created, you have to right click on that, and you have an option called Quick Insights. You have to click on Quick Insights. So let me tell you what Quick Insights does. So it shows us unfamiliar data, undiscovered data. It runs a sophisticated algorithm against your data set. So definitely things that we might not able to see are important. Quick Insights does that for us. So why not? It's a very cool feature. You can see there are so many data that actually we didn't create on our visualization, but these are so important. So Quick Insights does that for our report. Now we are going to be talking about how workspaces separate insights of report for each group. So workspace is another tool which is very interesting, helps us to do a lot of cool things like specifying the group. So let me tell you what it is. So workspace are where you will place your reports based on who you want to see it. So in other words, they are a group of certain people who will see certain piece of analysis. So some insights might only be for specific group. Workspaces can separate these reports for each group. So what you have to do this is go to workspace, create a workspace, and then you have to upload a picture for your workspace. Then name your workspace, give a description for what we can do here, and then save it. So that's how you're creating a workspace. It's quite great tool because it's actually specifying the department. Suppose if I only want my dashboard to be seen by the accounts department because it's all related to accounts, then I'm going to do that. The workspace helps me to do that. Now we are going to talk about how to direct access a user on workspace. So yes, this is another important thing that we can do on the online Power BI service. All you have to do is go to your space. I'll go to my space, and whatever report I created, right click on that, and then manage permission, go to direct access, add user, and then you can name or write the email address of the user who you want to give access to. And you can also check and uncheck these options according to your choice and then grant access. So this is yet another amazing feature on online Power BI. So these are the things that we can do definitely. And now I'm going to show you the PPT to summarize it to you, that what we did right now on the hands-on, so you get an idea what we need to do, but in a summarized way. So as I showed you on the hands-on, how to build a report. So on building a report, first is you have to import dataset in Power BI desktop. And to import dataset, all you have to do is select your dataset, choose your data source like Azure, Excel, etc. And then you can see the data modeling where we can see how data is related to other data like, the lookup tables. and then make changes to data. You can do some query change and etc. So yeah. And the next step is build visualization using dataset. So you have to choose visual. As we saw in the hands-on, we choose probably a KPI and then select x-axis and y-axis, or we can see the trend axis with that, like sales by date, and then apply visual. So we click on format visual. Here we have choices to change the font color, font size. We can do a lot of things there. Suppose we have a bar chart and we want to change the color of it to match with our theme. As I said, our visual has to be aesthetically pleasing. We can do that using format visual. Now the next is resize the visualization. So definitely this is very important in the process of building a report, because if you don't resize your visualization, it might look less pleasing aesthetically. So we need to follow the alignment, follow the theme, follow the order for that. And the last step to build a report is publish your report. So you have to select publish from the home tab and then select destination, the workspace where you want to publish. And then you get a link, right? And if you click the link and you already are logged in into your account, then you can open your report directly from there. But if you're not logged in, you have to log into your Power BI online service and then open the report, as I showed you in the hands-on example. So these are in a compressed way how to build a report. So it's what we discussed right now. And then we are going to talk about the difference between report and dashboard. So first is dashboards are one page, report are multiple pages. Dashboards has single or multiple data set, report has single data set. Dashboards can't be filtered, report can be filtered. As we saw in the hands-on, how we can click on one segment and other charts are also correlating with that each segment. So definitely it can't be done on the dashboard, but can be on the report. And the last is dashboard is not available in Power BI desktop, but report can be done in the Power BI desktop. So how to publish a Power BI report? These are the steps in a compressed way. We have to publish from the home tab and then select our workspace, log into Power BI online service, and then from there we have to open our workspace in the online service and then open the report. Why share dashboard, not report? As we saw in the hands-on example, sharing a dashboard can be a risk to the data for a company. So for any organization, their data is their most precious asset. So these are some points as to why share dashboard but not report. Number one is everyone you share it with can see your dashboard and interact with your reports, but they cannot save changes to existing reports. Everyone can see the changes that you make because we have this tool called refresh. If you make any change to the dashboard and refresh it, the other person whom we shared the dashboard with can see the updated changes. And number 4 is no one can see or download the dataset, which is a great thing for any organization, since for them, their dataset is quite important. Now to summarize, suppose a business organization strategies for annual sales monthly wise. So first it's going to import Power BI report, and then it's going to change visualizations as per choice. And then it's going to pin the tiles for the dashboard and then resize the tiles in their dashboard. So that's how they are building a dashboard and being able to strategy for annual sales monthly wise. Now these are some top features of Power BI service. As we discussed in the hands-on examples, the quick insights give us some unfamiliar and undiscovered data which are very important for an organization, and it's quite wonderful and cool tool to deal with in the Power BI service. And the next is raw level security. This is for the aspect where we want to share data to some aspect of the region and not to all. For example, if we want to share our dashboard with accounts department, so for those kind of customized security level, we use the raw level security. And number 3 is Q&A. Q&A is another cool feature where you'll be able to write your question and get direct answer to it. You don't have to understand the visualization or any model structure, but you will be able to get data from Q&A very easily. The next point is advantages of Power BI dashboard. So number 1 is it extracts insights and draw conclusion. So for the first advantage, as we saw in the hands-on example, Business organization wants to check which month has the most sales, so it's going to look after the month-wise data and extract the exact month out of the data set and thus have a conclusion. Number 2 is visualization from multiple data sets. So how amazing it is to have an aesthetically pleasing visualized data from a bulk of boring data set and have a single page visually, smartly and aesthetically telling you a story. And third is easily connects to many data sources. We can connect to multiple data sources like Excel, Azure, databases, etc., which leads us to have visual representation of the data. Now we are going to be talking about some examples of Power BI dashboard, but before that we also need to know the disadvantages of it as well. So the 3 disadvantages we have is we cannot slice it, we cannot filter it, and we cannot make a dashboard in the Power BI desktop. However, we can create a report in the Power BI desktop. So these are the 3 disadvantages of the dashboard. Now here we are with the examples, which is very fun to look at. The first one is customer segmentation dashboard. So as we can see from the dashboard, we have profit, sales, total cost, order returns. So we can see the visual graph of sales by region, which gives us a brief idea about which region to target more. We have total orders by city and return. So these visuals helps the organization make vital business decisions. And the next one is sales analytics dashboard. So it evaluates profit, sales, performance, etc. Here on this dashboard, we have net profit, fulfillment, income, and expenses. This is the same example we had in our hands-on example, just the same, almost different terms. And the last one is the finance dashboard. We have cash balance, day pay outstanding. These all are finance-related information and are amazing information benefiting to finance. That's why dashboards are very useful to any existing business organization. Why organizations use Power BI dashboard? So, marketing campaign insights dashboards are using dashboard to understand efficiency. Sales analysis dashboard are using it to understand the performance. Product sales dashboard are using dashboard to understand, visualize the profitability, and email engagement analytics dashboards are using dashboard to analyze the data.
We just covered building Power BI dashboards. Next, we will dive into Power Query tutorials, where you will learn how to connect, combine, and transform data from various sources.
In the Power BI desktop, a data set is basically defined by a single query that specifies what data to include and how to transform that data. Power Query is a data connection technology that enables you to discover, connect, combine, and refine data to meet your analysis needs. It basically helps you take your raw data source and convert it into something more usable, more workable, on which you can build your analytics and then draw insights from it. The query is made up of related steps that build on each other to produce the final data set. And once you've defined that particular data set, you can use it to create visualizations that you add to your reports, which then you can publish to the Power BI service. Now, the heart of the query is the Power Query M formula language, which is based off of a language called F#. And just like it, it is a case-sensitive data mashup language which is available to many of the Microsoft softwares, such as the Power BI desktop, Power Query in Excel, as well as the Get and Transform import feature in the Excel versions post-2016. As with many languages, Power Query statements are made up of individual language elements such as functions, variables, expressions, as well as values, both primitive and structured, that together define the logic necessary to shape the data. Now, each query in the Power BI desktop is a single Power Query let expression. It basically contains all the code elements that are necessary to define your data set. A let expression is made up of a let statement and an in statement, as you can see in the syntax before you. So the let statement includes one or more procedural steps that define the query. Each of these steps is essentially a variable assignment that consists of a name as well as an expression that provides the variable's value. Pretty simple, that is what a variable is in most cases. It's 5th grade math, right? Variable is a name to which you assign a value. Now, this expression defines the logic for adding, removing, or transforming the data in a specific way. This is where you will be doing the bulk of your work, as you are going to see in the examples I'm going to give you later in this module. Now, the variable can be of any supported Power Query type. Each variable within a let expression must have a unique name, but again, the Power Query is fairly flexible about what you call it. Just make sure it makes sense and it's easy to remember for you. Now, you can include spaces in the name, but you have to enclose it within double quotes and precede it with a hashtag. Now, that is a somewhat cumbersome naming convention and one that I particularly prefer to avoid. It's honestly a mystery to me, even now, why it is the way it is, but let's just move on. Now, the variable names are also the same names that are used to identify steps in the applied steps section in the query editor's right pane. So, I think it would be wise to use names that make sense. Now, strictly speaking, you do not have to define your procedural steps in the same physical order as the logical order. As in, for example, you can reference a variable in the first step of your procedure and then define it at the last step of your procedure. Now, this is something which is unlike the regular coding. However, this approach can make the code very difficult to debug, as well as cause unnecessary confusion amongst the coders. The accepted convention when writing a let statement is hence to keep the physical and logical orders in sync. Now, we spoke a lot about the let statement and none about the in statement. So, a little input here. The in statement is basically like a return function. It returns a variable value that defines the dataset's final shape. Now, in most cases, if not all, this is most likely to be your last variable that you defined in your let statement. You can specify a different variable from the let statement, but there's usually very little reason to do so. So if you simply need to see a variable's value at any specific point in time, you can select its related step again in the applied steps section in the query editor. If you are not familiar with what it looks like, I'm going to show you in just a while once we open the demo machine. Now, when you select a step, you're essentially viewing the contents of the associated variable. With that, let's move on to our problem statement. Now, this session is going to include a number of examples that demonstrate how to define the procedural steps necessary to build a query. All of the examples are going to be based off of a dataset, the link to which I will leave in the description box below. Now, the dataset I'm going to use is the Titanic dataset, which lists the passengers on the infamous Titanic voyage. It basically shows who survived it and who did not. Now, if you plan to try these examples for yourself, you need to create a titanic.csv file from the dataset that I'm going to link in the description box below and save it to a folder that you can access from the Power BI desktop. On my system, I saved it to a local folder in my C drive. Now, understand what we are trying to do here is to make this particular dataset a little more usable for you to lay analytics on top of. Yes? So now let's move on to Power BI and see how to do that. So the first step into building your own Power Query script is to add a blank query to the Power Query desktop. Now, to do that, what we're going to do is we have this Get Data button on the home ribbon in the main window. So I'm going to click on that. All right. Then I am going to navigate to the other section. And towards the very end, I'm going to find this option called a blank query. So I'm going to double click on this, or you can even click on connect. Now what it does is that it launches this query editor with a new query listed in the queries pane on the left. Now it's conveniently named query 1, or you might have a similarly numbered name with a different number depending on how many queries you've created. Now to rename this query, what we're going to do is we are going to right click and select rename and maybe give it a fitting name like survival log. Okay. And then we are going to press enter. As simple as that. On the right in properties, you see the name has changed, which earlier was query 1. Next, let's go to the view menu. It opens up this ribbon and then click on advanced editor. Then it opens the advanced editor. Now, as this editor opens, you can see that there is a new let expression here, which is already defined. The let statement includes a single procedural step in which the variable is named source and the expression is an empty string. As you can see, it is indicated by double quotes. Notice that the variable is also listed in the in statement, again, source. And if I move this advanced editor a little to the left, you can see that the variable is even listed as a step in the applied steps section. Now, this is the part I was talking about earlier when I talked about applied steps. Now, this is that section. Here you can see all the steps that have been applied to your query editor, and you can click on each step to see what that variable holds. Now, for this exercise, we'll be changing the variable name to get passengers. So the first procedural step that you'll add will retrieve the contents of the Titanic.csv file and save them to get passengers variable. Now, to add the procedure, we are going to replace the current let expression with a different one. Notice that this get passengers variable is specified in the procedural step in the let statement as well as in the in statement. Now, in this way, the variable's value will be returned when the let statement runs. It's as simple as that, as I had earlier mentioned, that the in statement is basically like a return function. Now, this expression in the procedural step includes everything after the equal sign. The expression uses csv.document as a function to retrieve the file's contents as a table object. It supports several parameters, but only the first one is required to identify the source data. As a part of the first parameter, you must also use the file.contents function right here to return only the documents data. And here you can see the location of my dataset. As I had already mentioned, it is saved in my C drive in a local folder called data files, and my file name is titanic.csv. Now, the second parameter can be specified as a record that contains optional settings. So in Power Query, a record is basically a set of fields which is made up of name-value pairs enclosed in brackets. Now, the record in this example includes a delimiter and encoding options for the values. Now, the delimiter option specifies a comma, as you can see right here, as the delimiter in the CSV document, and the encoding option specifies the text encoding type 1252, as you can see right here. This is basically the Windows Western European code page. Yes? And that's all there is to know and all there is to setting up a basic let expression in your Power Query. After you've entered your code, click on Done and close the advanced editor. And as you can see, that has run the procedural step, and the data set appears in the query editor, and it should look similar to what you can see right now. It's got a couple columns, it's got the survived, it's got names, it's got sex, age, passenger class, so on and so forth. Notice that the first step in the applied step section is now named get passengers, which is the same as your variable name. The procedural steps expression is also displayed in the small window above the data set right here. Now, you can edit the code directly in this window if you want to. Whenever you add, modify, or delete a step, you should apply and save your changes. A simple way to do that is to click on this little save icon at the top left corner of the menu bar. When prompted, if I click on this, I will be prompted to apply my changes. And here I am going to click on apply. And with that, my query is saved. Moving on, another important thing is removing a column from the data set. Now, the next procedural step that you are going to add to your let statement basically will remove your duplicate column or column 6 from your data set. Now, because your data set is saved as a table object, you can choose from a variety of Power Query table functions to update the data. For this step, you'll use something known as remove columns function to filter out that specific column. So again, I'm going to click on the advanced editor and I'm going to get back to the query. Now basically, to remove the column, I am going to add a comma, give a space, and on a new line, I'm going to define the next variable or expression pair. Now to remove the column, add a comma after the first procedural step, and then on a new line, define the next variable expression pair, as you can see on your screens. The table.remove function requires two parameters. The first parameter specifies the target table that you will be updating, which in this case is the getPassengers variable from the previous step. Second argument specifies a single column or a list of columns to be removed. This example specifies only column 6 from getPassengers table. The important takeaway here is how the second step builds on the first one and then returns a new result, which is assigned to the removeCalls variable. The new variable contains the same data set as getPassengers variable, just without the column 6 data. After you add this particular procedural step, replace the getPassengers variable in the in statement with removeCalls variable, and next click Done to close the advanced editor. You can then save and apply your changes. Your data set now should look something like this with 5 columns only. As you can see, the removeCalls step has been added to the applied steps section as well, and column number 6 is no longer included in the data set. To add more procedural steps, we follow the same logic as here, continuing to build on our growing foundation. The next step is to promote the values of the first row of your data set to the header row. So these values become the column names. So to carry out this step, again, go to the advanced editor. Now to carry out this step, add a comma after last step that you defined, and then on a new line, you can put the expression in front of you. This expression uses the table.promoteHeaders function to promote the first row of the column headers. The function's first parameter is required and specifies the table to use as the source data. This is just like you saw in the previous example, in which the new step builds on the previous step. The second parameter, promote all scalars, is optional but a good one to know about. By default, Power Query promotes only text and number values. When promote all scalars parameter is included and set to true, Power Query promotes all the scalar values in the first row to headers. The expression results are assigned to the promote names variable. Be sure to update the in statement with this variable name. Again, I'm going to click on Done. And as you can see, our entirety of first row has turned into this header row right now. The rename columns function requires two parameters as usual. The first is the target table, which is the promote names variable from the previous step, and the second is a list of old and new column names. This is a list of an ordered sequence of values separated by commas and enclosed in curly brackets, as you can see before you. It's this entire line. And in this example, you can see each value in the list is its own list containing two values, the column name and the new column name. So I'm going to click on Done. And voila, you can see all the names have been changed. Now the next task is to filter out rows that contain not applicable in the age columns, and then filter out rows with age values 5 or less. Now because the age column was automatically typed in as text when imported, you will need to filter the data in 3 steps, starting with the non-applicable values. Now to filter out these values, you will need the select rows function. Now, this function returns a table that contains only the rows that match the defined condition, age not equal to NA. As you saw the previous examples, the function's first argument is the target table, which is rename columns from the preceding step. The second argument is in each expression specifying that the age value must not equal NA. The each keyword indicates that the expression should be applied to each row in the target table. As a result, the new table which is assigned to the filter NA variable will not include any rows with the age value of NA. Clear? Now once you remove the NA values, you should convert the age column to the number data type so you can work with the data more effectively, such as being able to filter the data based on numerical age. While changing the type of the age column, you can also change the type of passenger ID column to an integer 64 type. This way, you're referencing to the IDs by integers rather than text, as you can see right here. Now to convert to the new data types, you should use this particular expression. Now this uses the transform column types function to change the data types. The first parameter is the name of the target table, which is filter NA, and the second parameter is the list of columns to be updated along with the new data types. Each value is its own list that includes the name of the column and type. Once the age column has been updated with the number type, you can filter out the ages based on numerical value. Your dataset should now include only the desired data as it exists in the filter kids variable. Now, another handy transformation you might need to do at all times is to replace one column value for another. For this example, you will be replacing the 0 value in the survived column with no and the 1 value with yes using the table replace value function. Now, kindly refer to the syntax that is shown to you and try to transpose the following elements that I'm going to discuss with the syntax on your screen. Now, the table replace value function requires 5 parameters in total. First, you have the table, which is the target table, in this case, the variable from the preceding step. Second, you have the old value or the original value, which has to be replaced. Then you have the new value, which you will replace the old value with. Then you have a replacer that carries out the replacement operations. And finally, you have columns to search. Now, the column or the columns whose values should be replaced. Now, most of the parameters should be self-explanatory except perhaps the replacer parameter. For this, you can choose from the several functions that work in conjunction with the replace value function to update the values. In this case, the replace text function is used because text values are being replaced. So first, what we're going to do is that we are going to replace the 0 values with no. And after you replace the 0 values, you can replace the 1 values with yes using the same construction. Here you have your old value, which is 1, your new value, which is yes, the table, which is the replace 0 table, the replacer, which carries out the replacement function in the column survived. And then finally, I'm going to change variable at in. As you can see, I have changed the variable for replace 0 and hence all the 0 values have become no. Now let's go ahead and do the same thing for 1. And there we are. Now another way you can modify your column values is to change how capitalized they are. For example, you will update the values in the gender column so that the first letter of each of the words is capitalized rather than all being in lowercase. To make these changes, again, let's go back to our advanced editor, add a comma, now again, this expression uses the transform columns function to update the two values. The function requires 2 parameters. The first is the table to be updated as usual, and the second is the list of operations to carry out. At times, you might need to provide additional information, but that's not the case always. For this example, there's only one operation, so you need to specify that the gender column and the text.proper function are enclosed in curly braces. The function converts the first letter in each word in the gender column to uppercase. At this point, your let expression in its entirety should look similar to what you see on the screen right now. The let statement includes all those steps and makes up your query to this point. Now, with each step building on the preceding step, let's click on Done, and you see the gender column with capitalized first alphabets. And on the right, you see the applied steps. And notice that the applied step section includes one step for each variable defined in the let statement, and all of them are specified in the same order that they appear in your statement. If you select a step, let's say this, the data displayed in the main windows will reflect the contents of that particular related variable. If I click on this, you see, we are back to the step where the ones were not replaced with yeses. Now, up to this point, each procedural step in your let statement represents a discrete action that is built on the preceding step. In some cases, however, you might need to structure your steps in a way that is not quite so linear. For example, you might want to create a calculated column that shows the difference between, say, a passenger's age and the average age for that person's gender. So for that, we need to first calculate the average age of the female passengers and save it to a variable, then calculate the average age of male passengers and save it to another variable, or you can do it vice versa as well. This is optional. Then you can add a column that uses the two variables to calculate the age differences and round the age differences to a more readable number of decimals. Now this step is purely optional. Now to carry out these steps, again, I'm going to put a comma, go to the next line, and add a couple of steps. Now, this suddenly might have caused a lot of confusion. So what I'm going to do is I'm going to walk you through these steps in smaller chunks so you can better understand how they work. Now, the first line, which is preceded by 2 slashes here, which says add calculated column based on average ages, indicates a single line comment. Anything after the slashes to the end of the line is purely informational and does not get processed. Power Query also supports a multi-line comment that begins with a slash and a star and ends with star and slash, just like the multi-line comments in the SQL server if you might be used to that. It's up to you whether you want to include comments or not. Whether or not you do, the next step is to calculate the average age of female passengers. So these are the two steps. The first step uses the select rows function to generate a table that includes only rows with a gender value of female. The function is being used here in the same way you saw earlier, except that different data is being filtered out and the results are being saved to female variable. Notice that the source table for the function is the change case variable from the preceding step. The second step uses the list average function to calculate the average for the age values in that particular table, which is the female table. The expression returns a scalar value which is then saved to the average female variable. The function requires only one parameter. The parameter includes a second function, which is the table.column, which passes the values from the age column to the list average function. All right, so let's run these two and see. Now you can see we have the average female age right here, which is 30.7, a lot of 2's and 1. Moving on to the next two lines. Now we're doing the same thing for the male passengers, and for this you can use the same construction with a few minor changes. Notice that you must again use the change case variable for the source table when calling the table.selectRows function. Even though it's no longer the step directly preceding the new one, you can in fact use any of the previous variables in your expressions as long as it makes sense to do so. With the average female and the average male variables in place, you can now also add a column using the add column function, which is this one. The table.addColumn function requires 3 parameters. The first is the target table, which is again change case, and the second is the name of the new column, of course, which is the age difference column or age diff. So let's run all of that and see. And now you can see the average male age is around 32 years old. Finally, let's run our add column variable. And if we go to the extreme right, we see our new column with age difference is right here. But then there is an issue, isn't there? Let's go back to the advanced editor. Now, as you can see, this particular argument, the third argument, is the expression used to generate the columns values. The expression starts with each keyword which iterates through each row of the target table. Now, this is followed by an if-then-else expression that calculates the row's value based on whether the passenger is male or female. If the gender value equals female, then the age difference value is set to the age value minus the average female value. Otherwise, it is set to the average male value. But as you saw, all the values are in negative and have way too many decimal values specified. So after defining the new column, the final procedural step rounds off the age difference values to 2 decimal points. The expression includes the transform columns function, which you saw earlier, but it uses the number round function to round off the values rather than changing their case. The number round function takes 2 parameters. The first value is an underscore, which represents the column's current value, and the second is the value 2, which indicates that the value should be rounded off to 2 decimal places. That completes the steps necessary to create the calculated column. Your let expression in its entirety, after you change this to round diff, your let expression in its entirety should look something along the lines of this. Alright, it should look something like this. This code I will also leave in the description box below. I'm going to click on done, and here you can see the age difference in plus and minus, whether people go above the age average or below. Now notice that the applied steps section includes variables used to find the average ages, even though the add column step in the code builds on the change case variable. You can view the contents of these variables by selecting each step as I had done before. And if you select one of the variables used to store the actual average, the query editor will display it on its scalar value, as again I had shown it to you before, but again if I click on average male, it shows a scalar value. Now the query only shows the contents of the average male variable, a rather lengthy number, and now you can see why I included the final procedural step to round the values in the calculated column. Not surprisingly, there's much more to Power Query than what was covered in this particular module. But this should give you the foundation you need to start building your own queries in the Power Query desktop. It should also give you a better understanding of how these queries are constructed when using a point-and-click feature to import and transform your data. In this way, you can examine the code to better understand why you might not be getting the results that you expect. You can also start building your own query by using point-and-click operations, and then use the advanced editor to fine-tune your datasets or to introduce logic not easily achieved through the interface version. To make the most out of Power Query in the Power BI desktop, you'll need to dig a lot deeper into the M language's various elements than what we've covered here, especially the built-in functions. Keep in mind though, the Power Query was built with Excel in mind, so you might run into elements that don't transfer easily to Power BI desktop environment. Even so, the basic principles that define the language and its syntax are fairly the same, and the better you understand them, the more powerful a tool you have for working with the data in the Power BI desktop.
After learning about Power Query, we will focus on data visualization using Power BI desktop. Here you will discover how to create impactful visualizations to communicate your data insights effectively.
What is data visualization? Now, data visualization is basically the graphical representation of information and data. There can be many visual elements like charts, graphs, and maps. Here, data visualization tools really provide an accessible way to see and understand different trends that can occur in this data, or outliers and patterns. Anything that could be in this data could be visualized and found using data visualization tools. Now, in the world of big data, data visualization tools and technologies are very essential to analyze really massive amounts of information and then make some data-driven business decisions to help their organization. Also, with the technological revolution that's occurring, data really went from being expensive, difficult to find, and collect to abundant, cheap, but incomprehensible. It is audacious to store, understand, and analyze increasingly large volumes of data with traditional softwares and tools. However, as individuals or even as an organization, all of this data is only as good as what we can make out of it. And this is where big data comes really into the picture. It is used for predictive analysis, analyzing user behavior, or any other data analytics processes to bring value to the data that is present. Yet the raw details about this can remain uncertain due to lack of knowledge and lack of skills. Data visualization really helps to tackle this particular issue that we are facing. It is basically the process of transforming data into visualizations like charts, images, graphs, and even videos that really explain the numbers and allow us to gain some insights from it. So, in short, you can say that it makes information more coherent and really adds value to it, discovers new patterns, spot trends, etc. Now, let me explain this with a really simple example. How do you explain the various rows and columns of data in an Excel spreadsheet to your boss or customers? You obviously will create a chart like, a line graph or scatter plot and even a bar chart of the same data. So what it really does is it gives meaning and purpose to the original raw data that was present initially so that you have a visual representation of it and you can start analyzing it and integrating it with colors and really integrating it with colors and giving more meaning to your data. This has really empowered many businesses and organizations by providing a much more clear and actionable insight to programs as it can keep you ahead of the game. Let's move ahead and download our data set that we will be working on today. So for this, I'm just going to go to my Google search engine and I'm going to click on Kaggle. So Kaggle is a very big platform for people to work on various data sets, and people from all over the world upload their data sets that they work on. So you can download any of theirs and work on it in your own projects. So I just click the data option on the left hand side and I'm just going to scroll down. Today we'll be working on the COVID-19 data set. So we'll just download any of the data set that is available. Here you can see once I scroll down, so there's a separate option for COVID and I'm just going to click the novel coronavirus 2019 data set. This has been uploaded by SRK and I'm just going to scroll down and check out all of the available data sets. So you can see that there is one COVID-19 data set. There is also confirmed cases, confirmed US, deaths US, and finally the recovered cases. I'm happy with this data set, so I'm just going to download it. Because this is in a zip format, I'm just going to click on extract all and I'm just going to click extract. So that's done. Okay, this is great. So I'm going to quickly move back to my Power BI desktop and I'm going to click get data and I'm just going to click text to CSV file. I'm going to click archive one and I'm just going to upload the data set. The first data set is the COVID-19 data. Currently, this is a CSV file and you can see that Power BI has prompted a window with all of the available data in the current data set. You have observation date, you have the state, you have the country or region, the last update, confirmed, deaths, and recovered. I'm happy with this data. I'm just going to load it into my Power BI. It'll just take some time to load all of the data. You can see in the field section, you have the data set COVID-19 data, you have the confirmed cases. So the various columns that were available, the confirmed cases, country, the deaths, the last update, the observation, the province, state, recovered, and the serial number for each of them. So this data set is what we'll be working on. We'll just build some visualizations, some really simple visualizations, and we'll create dashboards. So this is just one data set that we'll be working on. Okay, so what we're going to do is we will learn how to create a few charts and understand how you can analyze the data. So we'll be creating visualizations now. So on the first page, let's create and work on bar charts. Okay, so what I'm going to do here is I'm going to select a stacked bar chart. That's the first icon that's available. And I'm just going to click on country or region. And I want to plot or view the confirmed cases of different regions. So I'm just going to track the confirmed field and I'm just going to drop it in the values add data fields here. Okay. And what it really gives me is it gives me an overview of all the countries with the confirmed cases. As you can see, US is on top. So this is 2019 data. So that is pretty old data. We are in 2021 right now. So as you can see, back then, US was on top, followed by India, Brazil, Russia, France, UK, and so on. So these are all the confirmed cases. You can also really add filters. You can just scroll down. You can add is less than some certain number. You can see that there is so many confirmed cases, and the least is South Africa. So you can just add less than or greater than some certain amount, and only those countries which is greater than that number will be displayed. I'm just going to put is greater than some number. Okay. And I'm just going to click apply filter. Okay. You can see that the regions with values greater than this number will display on your bar chart. On page 2, so this is stacked bar chart that we've just worked on. In the second one, we'll create visualizations using line charts. So again, I'm just going to click a line chart, and I'm going to click the country or region because that's important. So I'm just going to click on province or state here now, and we'll check out the number of deaths, and I'm just going to drag and drop that in the values field. And you can see the number of deaths that have occurred in England, and then Maharashtra, Cambodia, Rio de Janeiro, Texas, Florida, and all of that is given in your line chart. Again, you can just add some filters if you'd like to. I'm not going to add any filters as of now, and I'm going to create a new page. So if you click on the 3 dots that are available, you can export data. You can show this as a table too if you'd like to. So that's pretty nice. And you can also sort them accordingly, according to ascending order, according to descending order. All of that can be done. So that's great. So if I scroll down, you can see the number of death cases in each of the state that is present. Okay. And I'm just going to click back to report. So this will just take me back to the visualization. Okay. Now I've created a new page, that is page 3. And here what we're going to do is we are going to create a pie or donut chart. Okay. So pie charts are quite well known. However, when it comes to displaying a lot of data, it is not recommended that one uses a pie chart because it can be really difficult to identify tiny differences between each of these categories. So what we're going to do here is we are going to click a pie chart. You can see the icon that's right here. I want to check out the recovery. So I'm just going to drag and drop this values here. And I'm going to click on the province and state. Okay. So as we've already mentioned, there can be a lot of problems using pie chart because each of these tiny differences cannot be figured out in a pie chart. So what I'm going to do here is I'm just going to look for states in India. I'm just going to look for some major states: Maharashtra, Karnataka, Delhi, Tamil Nadu, Uttar Pradesh, Uttarakhand. I'm just going to mention all of the states that I can remember from India. You have Andhra Pradesh. I've just picked up a few states from India, and I have represented them in this pie chart. Now you can see that it's much more simpler, and you can see that Maharashtra has the most number of recovered cases, followed by Karnataka, then Tamil Nadu, Delhi, Uttar Pradesh, and then finally Uttarakhand. So it's pretty nice to represent tiny data sets in pie charts. You can also use donut charts if you'd like to. So I'm just going to click a donut chart. A donut chart is also a very pretty visualization that you can use. Moving on, you can use KPIs, that are key performance indicators, which are really a measure of the company's performance, and it evaluates its success. We can display this in Power BI using the card or gauge. You can use the gauge, or you can also use the card panel. So what I'm going to do is I'm going to create another page. So I'm just going to click on the gauge option, and what I'm going to do is I am going to add the number of deaths. Okay. So you can see that this is given in a gauge format. If you want it in a card format, you can just pick the card option. So these are the KPIs that you can work on. And now if you want to delete a chart, you can simply click on it and just click delete on your keyboard. If you want to add a new page, as I've already mentioned, you can just click on the plus icon. So now we will learn how to create a dashboard. What you can do is you can just copy paste all the visualizations that we've created so far onto the same page. And this basically gives a dashboard. That's how easy it is. Okay, and I can move this. So I can just click on the visualization, copy, go back to page 1, and then paste it. I can also resize each of these visualizations as I'd like to. And that's it. That's how easy it is to create your own dashboard. This is your dashboard on page 1. And you can also obviously change colors if you'd like to. So if you even want to change colors in your visualizations, you can do that. You can just go to this format icon and you can just click data colors and you can switch colors. Okay, we'll switch to something light maybe. Okay, you also want to change the colors in your legends of your bar chart. You can do that. You can just go to, again, the format option, go to data colors. So just click on for show all. You can see that different countries can be chosen with different colors. So you can choose France of one color and you can represent UK in another color and Colombia in another color and so on. You can do that. And all of the changes will be reflected in your visualization immediately. Okay. So now what we're going to do is we're going to learn how to save. Okay. Just click on save, name your file as anything you'd like to. I'm just going to name this COVID-19. I'm going to save this file. And if you want to publish your work, you can do that too by clicking the file option. You can see the publish option and you can just publish to Power BI. Okay. Here you have to enter your email address and then once that is done, you can just publish it. So let's move ahead and check out one more use case of Power BI. So as in the case of most modern technologies, Power BI is also likely to embrace the law enforcement agencies, which are benefiting immensely with the use of big data analytics and other technological innovations. Power BI dashboards can be used very effectively to get insights into aspects such as deployment of personnel at critical locations during specific periods of the year by plotting various parameters such as the types of crimes that occur, the incidences, the crime patterns, etc. Like many other factors and parameters can be involved in really finding the crimes that take place in a certain area. This is really helping the police and the other forces into getting a better insight into where crime can occur over a certain area and how it can be also prevented. So this is just one use case. Power BI can be used for many instances and many use cases to find and make better decisions in our daily lives and in our organization too, if you are working in any.
We just explored data visualization with Power BI Desktop. Now we will start with Introduction to Tableau. You will learn about Tableau's features and how it stands out as a data visualization tool.
In the prevailing world, every organization relies on taking data-driven decisions. But have you ever thought, how does data lead to decisions? In order to make a data-driven decision, data needs to be studied and analyzed to identify the factors that may influence your business on the run. And to make things easy for you, here comes Tableau. The renowned IT research firm Gartner has deemed Tableau to be one of the best BI tools for data visualization. But why is it so popular? What does it actually do? Imagine this. Your boss gives you a sheet with millions of rows and columns. He then asks you to find patterns from the data. It is going to be a hard time for you to even go through it. Forget finding patterns. Traditionally, you would be dumping this data in your database and would be writing SQL queries to refine your data to gain insights from it. And no doubt that you need to be really good at it. Then you would be plotting charts to make it look presentable. Now imagine doing all of this with just a simple drag and drop. And that's what Tableau does. With its simple drag and drop user interface, Tableau writes optimized SQL queries at the backend to fetch data from your data source in the desired way. talk about visualizations, with its high-end graphics and color schemes, Tableau makes the charts look as apt as possible. You can plot bar charts, pie charts, bubble charts, heat maps, tree maps, and even scatter plot on a real geographical map. With Tableau, you can even drill down your data using filters and visualize your data at a granular level. That's the power of Tableau, and that's how easy it is to harness the power. Just clicks, drag and drop. From large-scale corporates to small-scale organizations, Tableau is used and preferred by everyone, everywhere. Tableau product suite includes tools for development like Tableau Desktop and Tableau Public, and sharing tools like Tableau Server, Tableau Reader, and Tableau on Cloud, which is Tableau Online. A company called allrecipes.com was successful to harness this power, which in turn helped them to improve their user experience and gain an even bigger consumer base. With Tableau, allrecipes.com can understand every stage of the customer journey. From analyzing web analytics to tracking content engagement, visual analysis allowed them to spot and stay on top of emerging trends. By leveraging Tableau analysis, they were able to see an immediate improvement in their business and scaled up to 1.5 billion annual visits, making it a top media food brand worldwide. This is how every organization is using Tableau. Time to find out what you can do with this ever-rising tool.
Having introduced to Tableau, our next topic is getting started with Tableau. This module will guide you through the initial steps of using Tableau, including connecting to data sources and creating basic visualizations.
So what is Tableau? Well, Tableau is known to be a groundbreaking data visualization software created by Tableau Software. So with Tableau, you can easily visualize your data. Now, your data mostly lies in form of spreadsheets, in rows and columns, with numbers and text. So it is hard to just identify problems and come up with solutions just by viewing numbers and text on a spreadsheet. And that is why you need to visualize that data in order to understand how your business is going, what are the problems, and how can it be solved, and also identify the interdependencies as well. What Tableau does is that at the backend, it writes optimized SQL queries in order to fetch your data from the database and then present it to you in a visual form, which is very attractive and also very insightful. So in order to summarize, it's a data visualization software that makes our work very, very easy. And plus, it is also very easy to use. For example, let me connect to the Superstore data in Tableau. So there are measures and dimensions in Tableau, which are nothing but different fields that you can use to create your visualizations. Measures are usually numeric entities or numbers, and dimensions are text. So let us see in our Superstore which is the customer segment that makes the huge or most purchases. So just drag and drop the segments to the columns, and we want sales in rows. And you can see here directly that the consumers or individual buyers are the ones who purchase most of the products as compared to corporate or home office customers. Now let us see what are the products that they purchase. And there you go. It has listed out different products they buy. So these are the items that are purchased on the Superstore with the bar chart indicating their number of sales. Well, you can also sort it according to your own convenience. And this is how you do it. Now, if you just hover on a bar, you can see the details as well. Now let's just find out which are the most profitable items. Just drag and drop the profit to colors. And the color legend over here indicates the darker the orange, the more is the loss, and darker the blue, the more is the profit. And here we have phones with the darkest blue, and if you see in this case, tables, which is one of the highest selling products, is under loss. Now these are the things that you can understand by visualizing, and Tableau is a very good tool for that. Moving on, Tableau is also a leader among all the BI tools. Now this is Tableau's 5th year to be on the leaders chart or in the leaders quadrant in the Gartner's Magic Quadrant. Now it is among the leaders and it has beaten other BI tools like Microsoft, Qlik, Salesforce, etc. Now let us take a look at the Tableau product family. Now the main development tool in this Tableau software suite is the Tableau desktop. So with Tableau desktop, you can connect to numerous amount of data sources. You can connect to your data in your local system. You can connect to cloud databases. You can connect to cloud applications. You can even connect to big data with Tableau desktop. And this is a very good development tool. This is where you create all your visualizations and your dashboards that you want to share across your organization or with your friends. Then we have got Tableau Reader. This is again just for viewing purpose. If someone has created a dashboard or a workbook in Tableau desktop, you can view it in the Tableau Reader. Now you can interact with the visualization with filters, but you cannot make any changes to it. Then we have got Tableau Public. Well, Tableau Public is also used for creating dashboards and worksheets. The only difference is that you cannot save your workbooks in your system. You have to publish it in the Tableau server where it will be available publicly. And it has also limitations to connect to data sources, unlike that of Tableau desktop. Then we have got Tableau Server, which is an enterprise level sharing tool. So if you want to share all the dashboards across your enterprise or organization, you can use Tableau Server for that. It is secure and reliable. Then we've got Tableau Online. Now this is just Tableau hosted in cloud. So you can view your workbooks and your projects that you have created in Tableau desktop in your Tableau Online. Moving on, let us understand the need of data visualization. So there is a very good example to make you understand why do we need to visualize this data, and this is the Anscombus quadrant. Now these are the X and Y points that you can plot on a graph, and it is there for 4 different quadrants. Now if you take a look here, the numbers are almost the same. The sum, average, and standard deviation are completely equal. So you might be thinking that when we plot these points on a graph, the graph will look pretty much the same. But when you actually plot it, you can see it is completely different. The lines formed by these points are completely different from each other. And you wouldn't have known that unless you have plotted it and visualized it. And that is why you actually need to visualize your data in order to understand the differences in situations, and that is how you come up with different insights and solutions to your business problems. And that is how Tableau exactly helps you. Now let me show you a sample workbook, and I will let you know what ways you can make visualizations with Tableau. So here is a workbook on the world indicators. So before making the workbooks, first thing you need to do is connect to your data source. Now this is a world indicator dataset. In the first worksheet, we're going to find the relationship among the population and birth rate. You can create a new sheet from over here. You can click here and it will open a new worksheet for you. Now I have dragged and dropped latitude and longitude over here. These measures help you to plot an actual map in a Tableau worksheet. If your dataset contains any geographical location, Tableau detects it and it can plot a map just like this. For example, we have country here. Well, this is just a simple visualization, like a simple scatter plot with varying colors and sizes, but it gives you a lot of information. Here, bigger the circle means bigger the population, and the color legend description is over here. So if the birth rate is above 3%, it is red. If it's between 1.5 to 3%, it is gray. And similarly, the description is over here. So clearly we can find out here that even if China has a huge population, the birth rate is quite low because it's blue. You can see in countries in Africa that even though the size of the circle is quite small, it is red, which means birth rate is quite high over here. Here you can get an indication that the population is low even though the birth rate is high. And this could only lead to the fact that the mortality rate in these countries is very high. So you can identify threats just by visualizing the data. And you can conclude here that there might be fatal epidemics or famines spread in the countries because of which the population is less but birth rate is high. Similarly, if you want to view the infant mortality rate in different countries in Africa, you can visualize it like this. The color legends are over here. For birth rate, it is blue. For infant mortality rate, it's orange. For health, it is yellowish, and for life expectancy, it is purple. Similarly, you also want to see the care spends. So if you want to check which countries spend more than 14% of GDP on healthcare, you can edit this part, edit the text of the question here. You can even add filters to adjust the threshold value, which is 14% in this case. Let's drag it to 8%. You can see that the text also gets changed here because I've included the variable in the question. And it looks like every country spends at least 8%, just leaving the African countries, which explains the health situation. Now let's check the technology worksheet. You can use filters to drill down a single country view. This is for Argentina. Now you can make dashboards to combine all the worksheets together. Just drag and drop sheets to create your dashboard. Dashboards in Tableau are interactive as well. You can make changes directly in your dashboard, which will reflect in your worksheet too. Finally, you can also sum up everything in the form of a story, just the way we found out that there was an imbalance among birth rate and population in Africa. And the best part in Tableau is that in order to tell a story, you don't need a storyteller. You can view the story just by clicking ahead. And stories are also interactive. But let me tell you, even if you make any changes here, it will not reflect in your actual worksheets like that of dashboards. So these are the kind of things that you can do with Tableau.
A simple question for you guys. Which of the following is one of the first step in getting started with Tableau? Your options are A. Writing a blog post, B. Connecting to a data source, C. Designing a logo, or D. Editing audio files. If you know the correct answer, please comment down below. We just learned how to get started with Tableau. Next, we will compare Tableau versus QlikView, highlighting the strengths and differences of these two popular BI tools.
So let's look at the features based on which I'm going to compare these two tools. So first of all, we're going to talk a little bit about the ease of use and ease of learning these two technologies. Then I'm going to talk about the license cost, base price of both of these. Then I'm going to talk about the connectivity of both of these tools to various other tools, databases, languages, etc. Then utility and system requirement, followed by insight generation, user experience, security, and finally scalability. So without much ado, let's get straight into the module. Now, QlikView is very easy to use and explore given the hidden trends. To search, just type any word in any order into the search box and associative results will pop up. It will also show connections and relationships across your data. It is difficult for the user to design their own views though, due to the menu-driven properties. As per Tableau, its interface is pretty simple, not filled with too many features at one page. It has a drag and drop interface, which does not provide feature to search content across your data, but the user can easily create their own stories using various objects, and it is very easy because of the well-designed GUI surface. Let's talk a little bit about the license cost. Now, QlikView's personal edition is free with limitation of document sharing. Each named user license has a base price of $1350, and it will charge you $15,000 for a concurrent user. Now, server license is $35,000 per server and additional $21,000 for PDF distribution. As for Tableau, the private versions come with a fixed fee of $999 or $1,999 depending on your data access. The Tableau server anecdotal evidence says $1,000 per server user with a minimum of 10 users plus maintenance. Apart from these, both of these have their free versions, which you could try out before investing this kind of money. Next, let's talk a little bit about both of these tools' connectivity with other tools, languages, or databases. Now, QlikView integrates with a very broad range of data sources like Amazon Vectorwise, Redshift, Cloudera Hadoop, Impala, CSV, DataStax, and so on and so forth. It can connect with R using API integration and also connect to big data. As for Tableau, it can integrate with a broader range of data sources, including spreadsheets, CSVs, SQL databases, Salesforce, Cloudera Hadoop, Firebird, Google Analytics, Oracle, Pivotal, Greenplum, and Windows Azure Marketplace. It can connect with R that powers the analytical capabilities of the tool and also with big data sources. Now let's talk a little bit about the deployment process and the system requirement. Now QlikView has its own data warehouse with the addition of scripting feature that adds more value to it. We can use multi-level layers in QlikView deployment. As it is very easily deployable and configurable, it starts producing stunning reports within minutes of installation. This product does not use cubes, hence loads of tables and charts in the memory enable interactive queries and creation of reports, a technology that is not yet found in other products. It can be developed on both 32 and 64-bit, and its associative technology makes data modeling way easier. As for Tableau, it does not have its own data warehouse. It cannot create layers while connecting with the dataset, but it is much easier to deploy because it requires more structured data. With that, let's move on to the insight generation of each of these BI tools. Now, most of the people use these two tools for this specific purpose. For all the data analysts out there, QlikView's associative technology makes it way more powerful and helps to read association between variables easily. This feature sometimes helps businesses to understand hidden relations between data points as well. For Tableau, the storytelling feature helps you create a presentation using your available data points. Let's just say if this were a beauty contest, Tableau would definitely win. Next, let's look at the UX of both of these. Now, QlikView has great options available to visualize information. It is loaded with various objects, and we can play with their properties easily and customize it. We can also create custom charts like waterfall, box plot, geospatial charts by customizing properties. While inserting objects, it has a layout and formatting options similar to the theme of the document. Here, we need to work on formatting options to make it more visually appealing. Apart from this, QlikView will also suggest bits and pieces of a dashboard that you could pick up and throw it in yours. Tableau has great visualization objects as well, but with better formatting options. It has very good visualization for geospatial graphs and numerous options for visualizing data. Now, these graphs are always in the best of quality in Tableau. This is why Tableau wins this round. Now let's talk a little bit about the data security. Now QlikView has various security options for script documentation, section access, and user authentication. Direct access to the QlikView document using QlikView Desktop is always governed by Windows NTFS file security. Access to the web-based QlikView Enterprise Management Console is restricted to Windows users who are a member of a particular Windows group. Tableau has great security features as well and is highly handled by the Tableau server. It is a modern enterprise analytics platform that enables self-service analytics at scale through governance. Security is the first and most critical part of the data and content governance strategy. Now, Tableau server provides the comprehensive features and deep integration to address all aspects of enterprise security. This helps organizations promote trusted data sources for all users, so the right data is used to make the correct decisions. And finally, we have scalability. Now, you may have heard that Tableau offers better scalability than QlikView, or that QlikView can scale faster than Tableau. The truth is that both the vendors can handle very huge amounts of data. In fact, the majority of organizations are not even producing that much data, which either solution cannot handle. So with that, let's move on to see how the basic charting works in both of these tools. So this is the QlikSense desktop app, and it is used for its dashboarding functionalities. It's got a great layout. It's very user-friendly. And so we're going to see how we're going to create an app here. So this is a button here which says create new app. Pretty self-explanatory, I'm guessing. So I'm going to go here, name this Edureka demo, and create. Now we can see the Edureka demo app was created successfully. I'm going to open app. This might take some time to load. Yeah, so I'm going to go to this option right here. It's going to initialize the data. So what I'm going to do is I'm going to go here to my computer and select the location of the file that I'll be using. So this is the file that I have picked for this particular demo. Here we basically have the average income of all the countries in the world. So we have Southeast Asian countries, Sub-Saharan countries, Europe, Central Asia, Middle East, North Africa, a bunch of different countries, and they are divided into low income, middle income, and upper income categories. All right, now I'm going to add data. And as we see, the data was loaded successfully, so I'm going to close this, and it opens up a new sheet for us. Now there is this amazing feature in QlikView which is called Insight. Now the button is right here, but as soon as your data is ready, you can go ahead, click on this button called Generate Insights, and it's going to suggest plots and graphs for you to put on your dashboard. So basically here we have a bunch of different graphs. We have a tree map here, and we have bar graphs and scatter charts and maps and whatnot. So from here, I can choose whether to add these graphs to my sheet or not. So I'm going to add this to the sheet, go down, add this to the sheet, and add the comparison chart to my sheet. Now that we've added 4 of these to our sheet, let's go see what the sheet looks like. So here we are on our sheet. So after I've made my dashboard, I can basically cross-highlight, which is very popular in most of your BI tools. Here, if I select it, you can see the corresponding parts being highlighted in your other graphs, right here and right here. And if I want, I can also cut out all my filters. Then I can edit it, let's say, put in a name for the sheet, call it Tableau versus QlikView demo, because that's what it is. And then you can go ahead, give an expression, create a thumbnail, so on and so forth. But for me, this is enough, so I'm going with done. And then I'm going to save this as my sheet. Now this is as simple as it gets in QlikView. So let's go ahead to our Tableau desktop and see what it has to offer. Now let's try to do the same thing with Tableau. So what I'm going to do is I'm going to connect to a Microsoft Excel file, the same as I did before. It's going to be the same spreadsheet that I had used earlier. Okay, so if I had to say something about Tableau, the first thing would be that straight off the bat, you can see it did not pick up on all my column names, which, if you remember in the QlikView, it had done on its own. Yeah? So then I'm going to open up my sheet and let's try to make a few visualizations. Okay, so I'm going to bring the country names and I'll put up, say, some values. I'm going to turn this into a bar graph per se. I am going to select this and I'm only going to keep, say, our A's. Alright, so select this. I'm going to open up a next one. I'm going to put in, say, a map. So first what I'm going to do is I'm going to take this F1 dimension and convert it into a geolocation. So I'm going to put in country/region, and then I'm going to pick up this dimension and throw it straight here. And it automatically turns into a map. Now, the Tableau desktop might not suggest many insights, but here you have the freedom to create whatever you like. Now that we have 2 sheets, let me go ahead and create a dashboard. So here we have a new dashboard option. I'm going to go there and drag both my sheets. Now this is definitely not the best dashboard that I could make, but my purpose here is to show you how easy it is to use this Tableau desktop, right? I've put it right here. I'm going to take this and let's say I'm going to edit the title, put in map, edit the title again, put in bar chart. And again, I can do the same. I can just drag these many points, select keep only. And as you can see, these maps are as interactive as any other BI tool. You can choose to save it or put it up in the Tableau server where you can share it with your other colleagues and friends. But this is what creating a standard dashboard on Tableau desktop would take you. If I want, I can change the location of both of these. I can make like a horizontal marking here, add something else to the box right here. But I choose not to do that and keep it just the way it is. You can add text, image, a web page or anything right here. Extensions if you will.
After comparing Tableau and QlikView, we will move to what is Tableau Server. In this module, you will learn about Tableau Server's role in sharing and collaborating on data within organizations.
What are Tableau products? So Tableau has a number of products like Tableau Desktop, Tableau Reader, Tableau Public, Tableau Server, and Tableau Online. Tableau Desktop is a paid desktop application where developers create charts, formulas, dashboards, actions, and other visualizations. The dashboards which are created here can be published to Tableau Server or Tableau Online or Tableau Public Server. It can also be opened in Tableau Reader. So that's about Tableau Desktop. Now, Tableau Reader is a free desktop app which can help us to view the Tableau dashboards created in Tableau Desktop or Tableau Public. So Tableau Reader is basically a reading tool for the existing workbooks. But the security level in Tableau Reader is pretty low, as anyone who gets the workbook has an access to it. Next, we have Tableau Public. So in Tableau Public, workbooks cannot be saved locally and it gets saved in Tableau's public cloud, which can again be accessed and viewed by anyone. So it is specially built for the cost-effective users. So next, we talk about Tableau servers. So Tableau Server is basically designed to share workbooks and visualization that are firstly created in Tableau Desktop or Tableau Public. But Tableau Server is highly secured and only the licensed users can have access to it. The admin of the organization has the control over the server and both hardware and software are operated by the organization itself. Next, we have Tableau Online, which is again similar to Tableau Server only. So Tableau Online is also a sharing tool and the functionalities are similar to that of Tableau Server, but here the data is stored on the servers hosted in the cloud, which are maintained by the Tableau groups. So that's about the products of Tableau. Next up, let's discuss what is Tableau Server. So Tableau Server is basically a web-based platform where we can share our workbooks, reports, and dashboards made in Tableau Desktop. But these dashboards can be accessed only by the licensed users. So the data security is very high in Tableau Server. Now let's look into the difference between Tableau Server and Tableau Online. So when we create a dashboard on Tableau Public or Tableau Desktop and we want to share it across our colleagues, on the front end, there's absolutely no difference between Tableau Public and Tableau Server. So the main difference is where the data is being stored in the backend. So Tableau Server is hosted by the customers or the organization itself and their data engineers. So that way the data is accessible to only the users with licenses and only the admin will have the control over sharing the data. Whereas Tableau Online is hosted by Tableau itself and it's a software as a service. So the organization do not need to purchase and maintain a new hardware for Tableau Online. Whereas for Tableau Server, organizations need to manage everything on their own. Upgrades, facilities, hardware optimization, everything is managed by Tableau for Tableau Online, whereas Tableau Server is for organizations who focus on data security and complete control over the data workloads. So that way Tableau Online is a bit costlier than Tableau Server as Tableau itself manages everything in Tableau Online. So next, let's look into the components of Tableau Server. So there are total 8 components. The first being Gateway. So Gateway is basically a kind of web server that helps clients to communicate to the server via HTTPS. So the server receives incoming client requests and directs them to the appropriate server for action. A gateway handles processes such as load balancing, traffic routing, URL rewriting, serving static files to clients, serving multi-thread processes, and things like that. Next, we have application server. So gateway interacts primarily with the application server, which is also known as work group server. The application server basically deals with login processes, domain authentication, data authorization, user or group permission management, content searches, etc. It basically works association with the server's repository and handles data access operations. Then we have repository. So the repository in Tableau Server stores server metadata related to user permissions, assignments, groups, and projects. So along with the metadata, it also stores visualizations in flat files and performance data for auditing. So whenever a server service or component demands for metadata, it is provided from the repository. Also, it cooperates with the Active Directory to provide useful information to the app server for login verification process. Next, we have VizQL Server, and it is a very important component of Tableau Server as it is responsible for loading all the visualizations that you see and work on with Tableau. So basically, it has an inbuilt caching for performance improvement and editing tasks. Whenever a user requests a visualization or wishes to update an existing one, a request is received by the VizQL, and then it is converted into SQL statement and sent down to the data sources via respective data source drivers. So that's the job of VizQL Server. And next we have Data Engine. So the Data Engine is another efficient component which handles processes related to Tableau data extract. It is invoked only when a query is short, which involves data from TDE. The data engine stores multiple TDEs and can run on multiple servers. Then we have Backgrounder. Backgrounder is an essential multiprocess and a multiprocess element that manages schedules for information refreshing and ensures proper functioning of the Tableau server and data engine. Penultimately, we have data servers, so which helps in centralizing the metadata management, driver deployment, and extract management. And lastly, we have search and license. So these are two very important components again. The search component manages the search indexing for the data in the repository, whereas the license component is responsible for licensing and configuration of the Tableau server. So that's about all the components of Tableau server. Now let's look into the architecture. So let's see how all these components work together. That's about the architecture. So here we have multiple layers. We have 5 layers or sections in the Tableau server. Firstly, the customer data, next the data connectors, then main components, then gateway, and then clients. So in the customer data layer, we have all sorts of data sources available for a Tableau user like the data warehouses, data marts, files, cubes, and relational databases. Then in the second layer, we have the data connectors. In this layer, we have data engine, SQL connector, MDX connector, and the repository. So the data engine processes the data requested by the user and assigns the data type, decides whether it is a measure or a dimension, and then create TDEs. So at the background of the data, engine runs an SQL connector, which creates an SQL query for all the user requests and interacts to the data sources. The SQL connector primarily deals with the data marts and flat files. Similarly, the MDX connector deals with the multidimensional cubes. In the third layer, we have the main components that are the data server, VizQL server, and application server. So the application server takes all the user requests coming from the Tableau desktop, mobile, and browser for accessing the visualization. While the VizQL is a patented component of Tableau, which means visualization query language. It basically works behind the logic of Tableau visualization and creates the visualization as per your instructions on the dashboard. In the fourth layer, we have the gateway. So the gateway is the gatekeeper of the Tableau server, and any request or query sent by the client first hits the gateway or load balancer. So basically a gateway is nothing but a primary server which receives the queries and redirects it to an appropriate available secondary server. That is the worker server. So finally, the fifth layer consists of the clients where we can visualize the dashboards in desktop, mobile, or browser. So that's about the Tableau server architecture. Next, we will see how to install the Tableau server. So the setting up a Tableau server is a fairly easy process. There are multiple ways to install it on your system, such as automated installation or jumpstart installation, or installing Tableau in an air-gapped environment, cloud installation, and Tableau Online. However, in this slide, we will discuss how to install the Tableau server from the website. So firstly, you will have to open the Tableau website on your browser and click on the Tableau server from the products drop-down menu. As you can see in the slide here, from the products drop-down menu, you have the Tableau server. So once you select Tableau server, it will lead you to a page where you'll have this option of try it for free. So once you choose try it for free, you can download the setup as per your requirements. So here after this, you'll be led on to a page where you'll have multiple options. Here we will choose on-premises version. So once you select on-premises version, you'll get a pop-up where you'll have to put your business email address and download the setup file. So once the setup file is downloaded, you open it and select the location for the installed software files and leave the default. You open the setup file and select the location for the installed software files. And then you click on the next button. So after that, you will have an option of create new Tableau server installation. So you click on the checkbox for the authorization to run to activate the server. So then you click on the install button and wait for the installation to be finished. And finally, you can enter the product key that you've received in your mail and follow the registration process and complete the setup. So that's about installing the Tableau server from the Tableau website.
We just covered Tableau server. Next, we will explore Tableau Online, the cloud-based version of Tableau, and how it facilitates data collaboration and sharing.
Now the question is, why do we actually require this Tableau Online? So this Tableau Online, if I want to define it in a few sentences, I can say that this Tableau Online is a powerful way for the organization to build, share, and collaborate around the data analysis. Okay, so it will help the people of that organization to share and collaborate in the cloud, which means the people who are users of the Tableau, especially the Tableau Online, so they don't have to worry about setup in their personal computer. So it's an analytics problem, analytics product or a platform, and this analytics platform, which is Tableau Online, so it is fully hosted in the cloud. And by using this fully hosted on the cloud, so the users of the organization can publish dashboards, share their discoveries and the insights with anyone, especially in their own company, and they can invite colleagues or they can also invite the customers to explore more hidden opportunities by creating beautiful visualization with accurate data. And the best part is it's easy accessible from the browser, or the users can actually access the data or the visualization on the go with the help of mobile apps. So that's the benefit of using this Tableau Online. So it's fully hosted on cloud, which means people do not have to worry about server setup or software setup. That's actually the second advantage or second reason as why we require this Tableau Online. So by skipping this setup time and the hardware cost, so we can actually get up and running in minutes, and we can actually seamlessly add multiple users as per our need and as the organization grows. And by using this Tableau Online, which is a fully hosted solution, so we never have to worry about configuring the server, managing the software upgrade, or even when I think about scaling, I don't have to worry about scaling my hardware capacity, because this Tableau Online is a fully hosted solution. And another reason why people or companies prefer to use this Tableau Online version is, more specifically, whenever we are working with this data source, so we can ask the question in a natural language. Now, when I talk about this natural language is the language that we humans speak. So currently, to converse with you or to explain what exactly is this Tableau Online, I'm speaking in English language. And I'm speaking in a way where we are comfortable with, where we are familiar with. Now, the best part about this Tableau Online is this Tableau Online supports natural language, which means I can empower my organization to ask the question from any published data source. So I can have any published data source. Data source is something where I have my data set present. Okay. So I can empower my complete organization to ask questions from any published data set using natural language. That means using the language which we are comfortable with. An example can be saying it as, hey, what's the average sales per day, or what's the average sales in the last week? So I can just type this question over here in this Tableau Online, and I can get the necessary output in the format of visualization. And I can also control as how the visualization should look like, whether I need a bar graph or whether I need a scatter plot, depending on the question that I'm asking over here for my data source. So here what happens is, with the help, we actually call this feature as a ask data. Okay, so with the ask data, so we can just type a question and we can get the answers in the form under the hood with the help of powerful visualization. But what happens in the backend is it actually makes use of powerful natural language algorithms to automatically profile, index, and also optimize the data sources. And along with these benefits, or along with these features, with the end-to-end web authoring capabilities, it's always easy to add additional data sources, or even if I want to create an interactive dashboard as well. So that's the feature about Ask Data. Okay. Now, the another important advantage or important feature when we talk about this Tableau Online is, so we can have the AI driven explanations for the given data. Okay, so which means I can leverage the power of AI, which is the artificial intelligence, to explain the data points with a single click. Now here, on the basis of statistical model, I can explain the data, which in turn helps me to uncover the insights which I may not have found otherwise. And the another best part is, while working with Tableau or Tableau Online, so I can also embed the Python code with the help of TabPy add-on, and I can also make sure that during the execution, I'll be doing the statistic-based analysis as well. So which in turn helps me to explain the data in a much more efficient as well as meaningful. So it will help me to explain in much more efficient as well as in a more meaningful format. And the best part, especially when it comes to normal users, is so it will help the users to interact, edit, and author on the web page itself. So by doing like this, the users can spark new insights even on the go. That means they don't have to install anything. They can just log into their tabs or in their company provided laptop, no matter where they are in. They can just spark insight even on the go when they're traveling. They can just create the visualization and try to get the insight that is present in a given data set. So which means here we are going to give the people the power to explore these interactive dashboards from anywhere. And by giving this ability, the users can drill down, and they can also highlight, and obviously they can also do the filter the data on the fly. Now by doing like this, they'll be customizing the views with robust web editing, as well as by authoring the new workbooks from the published data set which they already have in their organization. So that's another advantage when it comes to Tableau Online. And not only this, so especially while working with the data, so the users can connect to any data anywhere. That means they can actually connect to databases like Amazon Redshift, Google's BigQuery. So they can connect to databases like these other databases, and from these databases they can actually refresh the data automatically. And while refreshing, they can actually make use of web apps like Google Analytics and Salesforce. And while refreshing, they can also perform the like query on on-premise databases, or even we can actually schedule and extract the refreshes from the Tableau bridge. So the power is always in our hands as where exactly that we want to keep the data and from where I have to fetch the data. And when we talk about security, so security is one of the important thing whenever we are dealing with enterprise data, because that contains the day-to-day information, day-to-day transactions, and it contains the gold mine. Because as I mentioned at the start itself, some of the important asset of any company is data and its people. So here we are giving the power, that is the power of data, to the people, and it's very important that we keep it secure. And coming to Tableau, so Tableau has highest level of security standards, and by default it is present, and by design it is set to make sure that the product that they have built is very secure. So here we can actually empower the site admins to easily manage the authentication, and we can also set the permission for the users, content, as well as the data as well. And here, like when we talk about Tableau, so it's easy knowing that Tableau's online, it's worth noting that this Tableau's online infrastructure, it actually meets some of the suggested highest level of security practices. So last I've seen, it actually supports SOC 2 requirements when we talk about the security of Tableau product. And another best part of working with Tableau Online is we can effectively manage the data environment. So which means I can actually make use of Tableau data management which will help me to better manage the data within my Tableau Online. And by doing like this, I'll be ensuring that the trusted data is always used to drive the decision. Now, from data preparation with Prep Conductor, that's one more product from Tableau. So from data preparation with Prep Conductor to cataloging, search, and governance with Tableau Catalog, the data management add-on will actually build the confidence in the data that we are working with. Thus, it's going to accelerate the adoption of self-service analytics, because that's what we want to drive, isn't it? So we want to give this ability to do the analytics or to derive the insights from the data to the people that we already have. So by enabling the various products that are present with the Tableau, and which we can combine it with Tableau Online, so we'll be giving the power to the users itself directly. And not only that, so by doing like this, we'll be empowering the organization with insight. So as I mentioned, so it will help us to accelerate the adoption of self-service analytics. And not only that, so this Tableau Online has dashboard starters. So when I talk about this dashboard starter, so it's actually designed to help you hit the ground running with actionable data in a matter of few minutes. So with just few clicks, I'll be able to connect to popular web applications and create pre-built dashboards in a seamless manner. So that's another advantage of working with Tableau Online. So whenever we are empowering this organization with the data, so it actually helps me to enable everyone in my organization to see and understand the data with offerings for every user type. So the user type can be many things. So I can have an end user, I can have an business analyst, I can have a data scientist. So we can control what is the data and what is the depth of data that will be shown for each and every users. Now, as I mentioned, it could be end users like casual users who are just looking to make a data-driven decisions from a published dashboard. So these users, you can think of them as the end users. So who can be like a salespeople who just looks into the published dashboard, and on that basis they are going to decide, okay, which product should I sell to the next customer, which will help me to boost my sales. Or it could be data enthusiasts in the organization who actually want to use the web authoring to ask new questions from a published data source. Or it could be data geeks who actually want to create and share the wizards and the data sources with the rest of the organization. So this Tableau Online, it enables everyone in the organization by giving all this flexibility and all these features. Now here, whenever we are talking about this Tableau Online, so it's our data which will be powered by the cloud. So here under the data management, this Tableau Online centralize the access to the data in the cloud, and it will help us to publish the data models, and it actually makes it everyone like which is an easy to work with from a curated and a single source of truth. And if I'm using this Tableau Online, so this would make sure that the version that I'll be using, it's always up to date, because it's a managed by Tableau and it's a complete end-to-end solution. So which means we don't have to worry about deployment, we don't have to worry about updation. So everything will be taken care by the Tableau automatically. And the best part is, even when the latest version releases, so we'll not have any downtime during the upgrade as well. And this Tableau Online, it's a subscription based service. So it actually gives the power to the companies to subscribe anyone on our website and choose when people receives any update. And last but not the least, the reason that we would prefer this Tableau Online is, so when we talk about Tableau, the innovation comes as a part of the standard offering. So it has been noted that this Tableau, they actually invest more in R&D than any other businesses in that data visualization industry. So there's always some or the other updates which are coming around, and each update will actually is actually what we have seen is like each and every update that is being released by Tableau. So it is actually making the product a better and better one. So now that we have understood why do we actually require this Tableau Online? So let's understand what exactly is this Tableau Online. So as I mentioned already, it's a cloud hosted SaaS platform. So SaaS is nothing but software as a service. Okay. So which will help us to perform the data visualization and business intelligence. So this will help us to build, share, and collaborate the data that we have in the organization and help us to derive the insights from it. Now that you have understood about the importance of Tableau and why do we actually require this Tableau online, let's look at the structured learning when we look into learning this important topic that we have just seen, that is the Tableau. So I'll give you a demonstration as how does a structured learning path would look like if you're learning with us. Okay. So in case if you're planning to have your own self-paced learning journey, we recommend you to follow the same learning approach because this learning path is curated by the industry experts as well as the professors from NITW. So this this learning path is actually curated by the experts and the industry leaders. So as a part of your module 1 of this Tableau certification training, so you'll be understanding how you can perform the data preparation using Tableau. And this is followed by an hands-on session, followed by a module 2 where you'll be learning how you can create a connection with Tableau. The reason because as I mentioned already at the beginning, we'll be using the data and this data can be present in various sources. It could be in my Redshift or it could be in Google BigQuery table. So it could be in multiple sources. It's very important that we understand as how we set up this connection. And this is followed by an hands-on activity. And as a part of your module 3, you'll be understanding about the basic visual analytics, where you'll be learning how to create a basic plots, which will help you to derive the insights in a matter of few clicks. This is followed by a hands-on session, which will reinforce the learning that you'll be learning as a part of your module. And this is followed by module 4. Here you learn how you can perform the calculations on the data because not every data that you will be having can be directly used. So we'll have to do some kind of aggregation, some kind of mathematical operation to summarize the data that is given to us. Just to give you an example, suppose as a user, so or as a someone who is traveling to the Bangalore city after such a long time. So if I go to the Bangalore city and if I drink, if I stay in Bangalore city for 1 month and I drink coffee in 30 different places, and if I list down the coffee prices that I paid in each time, so it will be just collection of numbers. So just to let you know, give you the intuition as what I'm trying to say. So let's say on day 1 I've drank a coffee, it costed 20 rupees, and day 2 I've drank 30 rupees, and day 3 I have paid 50 rupees. Likewise, I'll be having 30 different numbers which talks about my coffee prices that I have paid. Now, by simply looking into this column of numbers, it doesn't make sense. So what it would make sense is if I try to find some average of this 30 data points, I'll be able to say, okay, on an average, I have spent, just to give an example, I've spent close to 40 rupees on a coffee. So calculation in Tableau is very important, which will help me to derive the insights from the data, which cannot be seen by simply looking into the tabular, or it could be in the tabular structure. So once you learn about these calculations in Tableau, you'll be performing an hands-on activity to practice the same. And as a part of module 5, so you'll be learning how you can create advanced visual analytics. And this is followed by a hands-on session. And as a part of your module 6, so you look into LOD expressions in Tableau, which is called as level of detail expressions. And this is followed by another hands-on session. Now, as you can clearly see, so each important topic is followed by the respective hands-on session. And all this will be demonstrated to you by the industry expert. And as a part of module 7, you'll be learning how you can create the geographic visualization in Tableau. And this is followed by an hands-on activity. And as a part of module 8, you'll see how you can perform advanced charts in Tableau, followed by an hands-on session. And module 9 is all about creating the dashboards and representing the data stories, followed by the hands-on session. And this is one of the very important module, guys, that is creation of dashboards and the stories. And at the end, as a part of module 10, so You'll be an industry ready Tableau specialist, and at the end you'll also be given with a project which will help you to practice and recap on all the topics that you have learned, and that project will be on the same standard that we will be working with the enterprise data. So whether you're joining the course with us or whether you're taking your self-paced learning journey, we recommend you to follow this approach. Now, the benefit of joining with us is you'll have the expert support who will be with you throughout your learning step, who will make sure that you'll not only understand the topic, but you'll understand from his experience as how exactly that will be used in the industry. Now, let's see how we can create our first setup using this Tableau Online. Now, before we actually go ahead and create our first site using this Tableau Online, the step one is we have to first plan our site. So this planning plays an important role. The reason because as an organization, I might have the data with me. So while creating the app or while creating the site, it will be like a blank sheet. So I have to first plan it. How does my site would look like, and who are the actual end users, and for what purpose we'll be using those sites. So as a part of step one, so planning the site is very important. So here you actually need to know where exactly the data will be hosted, because we will be having the data present in various scenarios. I can have in AWS, or I can have my data in GCP, Azure, or it could be from the on-premise database. So it's very important that we understand where exactly the data will be hosted and how will I be setting up the connection, and what will be the latency of data. So what will be the speed in fetching the data, and how exactly the data will be utilized, which means who is going to use this data, and also how will they use it. Will it be used for day-to-day monitoring, or will it be used for real-time monitoring? So these are the important three things that we have to consider before we build any site using Tableau Online. Okay, now once this plan is complete, so we can actually decide, and it will actually give us many advantages. So here when we are planning the site, so if I come back over here, I have mentioned that one thing that we need to understand is where exactly the data is hosted and who will be using it. So let me do one thing. I'll just open up my Tableau. Okay, now this has various information. I have created some visualization. Some visualization is not visible, but when I post it to Tableau Online, you'll be able to see the complete visualization. I'll just open up this tourism. So you can clearly see that I have some collection of visualization which I have done with the help of the data source, which is called as word indicators. Now I'll do one thing. I'll come over here and click on my data source. Now the data source which I'm currently using is actually called as word indicators. Now here in this word indicators data source which I'm currently using, I have various columns. So I have the birth rate, I have the business tax rate, I have the carbon CO2 emissions, country, year, and ease of business, energy usage, GDP, health expectancy. So I have the information about various columns for each and every instance. So when I say instance, it actually refers to my individual row. You can clearly see this is the collection of data that I'm having. Now on top, if you look at the connection, so connection, I have two types. One is live connection and the another one is called as extract connection. So here when I talk about live connection, so my data will be present in my source system. That means where exactly the data will be there. So the data will be fetched in real time, and using the data in real time, I'll be creating the visualization. And that's what happens when we talk about live connection. Now, as I mentioned already, whenever I have this connection set as live, so the speed in which I'll be creating the visualization, or the speed in which I'll be fetching those data, it depends on many things. It depends on what's the server speed, or what's the network speed which I have in my current server when I'm communicating with my third-party system. It could be my AWS Redshift or this Amazon Redshift database. So what's the speed in which I'm able to connect to that Amazon Redshift database, And if I'm fetching some data from there, so what's the data transfer rate that I have? So which means my network speed is going to play an important role over here. Now, along with that, if I have thousands of users who are interacting with my plot or interacting with my site, and if I'm using the live data, it means 1,000 times or 1,000 different users is interacting with the live database that I have, which I have set up. So this is going to cause performance issues when I have more number of users, and definitely not a recommended one if I have more number of users are using it. Now, unless and until we actually require the live data, so we normally prefer to use the batch data. To give you an example of live data, like suppose if I'm dealing with an bank related transaction, if I want to understand as how the transaction is taking place, so in such scenarios live connection would actually make more sense. The reason because I want to monitor the transaction in real time. So if I'm doing some kind of activity where I don't require the live connection, I just need refresh at every intervals. It could be 1 hour, or it could be 1 day, or it could be few hours. So in such scenarios, we actually make use of the connection that is called as extract. Now here, extract is nothing but we'll create a snapshot of my current existing data and we'll store it somewhere, and we'll use that stored information in order to access the same. So that is called as creation of extract. Now by doing this approach, so one advantage is, so I'll not be worrying much about network connectivity between one server to another server. So because I'll be having the data stored somewhere. Okay, now with the data stored, so there will be very less latency when I'm accessing the data. So to give you an example where exactly that we can use this kind of connection of extract is like whenever we are working with report. Just to give you an example, so if I'm worried about as what is the sales at the end of the day, so I'm okay if my data gets refreshed at the end of the day. So I can create the visualization maybe after that particular business day transaction is complete, and then I'll take a snapshot or I'll take an extract, and then I'll go ahead and try to find the insights on the same. So that's one of the example, and to help you differentiate between live connection and the extract method. So as I mentioned, if by using my extract, so I'll be able to work with very large data set with very less latency. And if I'm working with extracts, it will be very fast for me to create the visualization and derive the insight from the data. And obviously, it will help me to improve the performance. And not only that, it will actually provide the offline access to my data because I've already created a snapshot from the given data set with me. So that's the advantage of using my extracts instead of live connection. So once we plan the site, the next step will be building it out. So we'll just have to go ahead and build it. Now, I'll do one thing. I'll show you the steps as how you can create an account with Tableau Online. So in my scenario, I've already created an account with Tableau Online and I have logged in. I'll be showing you once I've logged in. So before that, let me just share you the steps as how you can actually create an account from your end as well. Now, in order to create a trial account, do note that you need to use the business account and you cannot use your personal account over there. So when I say business account, it could be the account email address that you have got from your company which you're working with. Or in case if you're associated with an academia, so if you have an email address from your education institution, you can also use the same. In order to access this Tableau, so I'll do one thing. I'll click on Tableau. I'll just search for Tableau Online, and from here I'll show you. Okay, I'll go to this URL online.tableau.com. Okay, currently it's asking me for login. I'll click on sign up button. All right, so using this link, you can actually create an account with Tableau. See, it says what are the reasons that you have to start with Tableau Online. So you can connect to data sources without leaving the web browser. You can build notebooks and the visualization with web authoring capabilities. You can share interactive dashboards, visualizations, as well as curated data sources with anyone in your organization or in your team. You can seamlessly integrate with Tableau Desktop So Tableau Desktop is the desktop application which I currently have over here. And I'll show you in a bit as how you can share this visualization that you have created with Tableau Desktop to your Tableau Online. So we can seamlessly integrate the same, and we can take the full advantage of the cloud architecture. The best part is it will be taken care by themselves. So they'll handle the hardware as well as the setup. And the best part is, as I mentioned, the data will be secure in the cloud, and they have the highest level of security standards, and all the Tableau trial sites includes data management add-on functionality. Now what you can do is to create a free account, just click on start your free trial and fill up this form. Okay, and once you fill up this form, so you'll be getting the access. That means you'll be receiving an email using your email address. Once you click on request free trial, so you'll receive an email, and once you receive the email, just activate your Tableau account, and you'll be required to enter your page name, and you'll be required to enter your password. And once your account setup is complete, so you just have to use the same URL, online.tableau.com, and then just log in with your email address and the password. So you just have to specify your email address, click on sign in, and then you'll have to enter the password. And once you are logged in, so you'll be redirected to a home page of Tableau Online. So let me show you how does the home page of Tableau Online would look like. Okay, so this is the home page of the Tableau Online. So I've just created I think yesterday or a few hours back, I don't remember. So I have logged into my account. So this is the home page that you'll be redirected once you logged in to your Tableau Online. Now here for that page, I have mentioned the page name as My Learning Tableau 666. Now you can mention your own name during the account creation. All right, now this is the home page, and in the home page, let me just give you a quick walk around on this home page of Tableau Online. So here it says, welcome to your Tableau site, and here using Tableau, you can actually harness the power of your data, unleash the potential of your people. So the main focus of Tableau is data and the people who are actually using it. Now you have the options to create new workbook, new project, new flow, new published data source, or you can also create the virtual connection. And if you have your own workbook, you can also upload the same over here using this button of upload workbook. And you have some other links as well. You can upload a workbook, you can manage projects which are already created, you can manage the users who are actually using your website or this Tableau site, and you can download the Tableau desktop if you require, and you can also download the Tableau prep builder. Okay, so this is about the home page. Now on top, you can click over here. Now once I click over here, it is going to display the personal space, my content, my account settings, and what is the start page that I have to use whenever I'm starting out, and I can sign out. So I can click on my content. So this is going to display the contents that are created by me or which have been made accessible to me. So for now, I'll click on home. Okay, now apart from that, here on the left hand side, I have something called as favorites. Now using this favorite, in case if I have set some workbook or something as favorite, so it will appear over here under the favorites, and I can access my recents. So whichever the sheets or data source which I've used earlier, so it would open over here. And in case if someone has shared some assets to me, it could be sheets or it could be data source, so it would appear over here. And if when I click on recommendation, it's going to display the recommendation. I can click over here on the personal space. So this personal space is nothing but the private space where I can create new content and I can explore by myself without sharing to any other users. And here we have something called as collections. So here we can create our own collection, and I can click on explore. And when I click on explore, it actually displays me the top level projects. So currently I have two top level projects. One is default and the another one is called as samples. And if I go inside one of the top level projects, I can see the various files. So this is the data source, this is actually a sheet, and so on. This is actually a flow. Okay, and if I have some external assets, so I can get to know about the external assets that I've currently used over here in my account. And by clicking on users, I can get to know about the other users who are created over here. I can create my user groups. So we'll come to the users and user groups very shortly. And then we have schedules. So in case if I have some setup, or if I want to refresh some data, or if I want to fetch the data, so I can set the schedule, I can see the jobs, okay, and I can look at the task, and I can look at the health of my site by looking into my site status, and I can click the settings over here in case if I want to set up my own settings over here. Okay, so this is about quick walkthrough on this Tableau Online website. Okay, so now that we have understood as how we can log in and create an account, now let me do one thing. So here on my Tableau desktop, I have this workbook which I have already created. Now, if I want to share this workbook to my Tableau Online page, so it's very simple. I can just click on this share button. Now, by clicking on the share button, so it is going to ask me what is the server that I want to use. So here I have two options. One is Tableau Online and the another one is Quick Connect. Now, in case the Quick Connect is selected and not the Tableau Online, just you can do one thing, just click on this Tableau Online button. Okay, so this is going to set the Tableau Online and it will ask you to sign in with your Tableau Online account. So let me just do the sign in from my end. So I'll just specify the email address which I've got. So once I log into my Tableau Online account, so it's going to give me a pop-up and it asks me as where exactly that I have to publish this particular workbook. Okay, so currently it's asking me to select a project. Let me do one thing. I'll select the project as samples this time. And for the name, I'll specify it as word indicators example demo. And I can specify the description. I can say this is a Tableau Online demo for word indicators data source. Okay, so this is about the description. Now here I can add tags. Now tags will help me to identify my workbook, and which will actually help me to sort it, or if I want to do the filtering at a later point. Now when we are starting, at least when I'm adding this, I do not have much projects with me, but as I increase the number of users, so as more and more number of users start using our site and they start to create their own visualization to talk about the data storage, it will become very complex. And if I want to search for something, so it will be difficult to simply explore each and every notebook that we have. So the best practice that we follow is we are going to create the tags. So using the tags, we can actually access the required one. So I can create some tags. I'll just say it as GDP. I think that tag has been already, yeah, I can add a tag as GDP. I can add the tag as tourism. I'll add a tag as economy. So in this way, I can create the tags. And here I can mention how many number of sheets that I want to add. So by default, I have selected all the sheets. Now in case if I want to publish only selected sheets from the workbook, so I can do the same. So I can click on edit. So if I hover my mouse over here, you can clearly see that it actually gives me the visualization about each and every sheet. So which in turn helps me to save time. So I can just hover my mouse. Okay, I can understand. Okay, this is the sheet which I'm talking about. So let me add it. Or if I don't want, I can uncheck this. So in this way, we can actually select the sheets. And coming to the permission. So permission means I can mention, okay, which user has which access. So that's actually called as permission. Now by default, here the permission is set as same as project. So whatever the project has, this project has, the sample project has, the same permission will be given for the existing users as well for this new workbook which I'm trying to upload for my Tableau Online. Now for the data source, So I'll be using the data source which is embedded in this current workbook. That means the word indicators data source which I've shown you earlier. So the same data source will be used over here while uploading or while sharing with my Tableau Online. And here I have the more options where I can select whether I want to show the sheets as various tabs, whether I should show the selection, whether I should include my external files as well. So I can do all these selections. And once it's complete, I can click on this publish button. Okay, so this would take a while for publishing to complete. Now, once the publishing is complete, we can go to the Tableau Online to validate whether whatever the worksheet that I have shared from my Tableau desktop, whether is it visible in my Tableau Online. So normally what happens is once the publishing is complete, it would automatically launch my browser. So if you look at it, it has automatically launched my browser and it says publishing complete and the name is word indicators example demo. And here I can share this workbook with the other colleagues of mine in my organization, or I can preview different design layouts. For now, I'll just click on close button so that I can view my worksheets. You can clearly see I have various worksheets that I have just imported, and the owner is Nachiket Murthy, and I have just modified a minute ago. So I have modified at 8:51 p.m., which is just a minute ago. So I have various things. I have views, I have data sources. So data source is the same data source which I've used earlier. Okay, and so I have various data sources. I like this. I have connected metrics. If I've connected something or if I've built any custom views, it would show. If I have any subscription, it will show. And if there is any lineage in the data, so it would show over here under the lineage. Now under the views, so it displays each and every sheet that I had over there. So in this way, I can build my own page using this Tableau desktop itself. It's very simple. I can create my workbook using Tableau and Tableau desktop, and I can just share it with my Tableau Online. Okay. Now this is about building the site. Now the next thing is adding the user. So obviously while working out, so like it's not a one-man game or it's not a few people using this Tableau software and creating the visualization. So the main purpose is to enable the data as well as the people to unleash their highest potential possible, which means we need to add multiple users of our organization. They could belong to multiple groups. When I say groups, they could belong to multiple departments, multiple job roles, and we'll be enabling everyone to use the enterprise data so that they can derive the insight from it, which will help them to take the action on the basis of data. So which means we'll be adding multiple users. Now to add the users, you can click over here, the users, and you can add the various users. Now if you want to add the user, you can click on add user, and there are various options to add the user. One is you can add the users by user using their email address, and the another way is you can import from the file. So while importing from the file, you can actually create a file which contains multiple users. So this will help you to create multiple users in a single go. Okay, so for the demonstration purpose, I'm going to add users by email. Now here I can set up the authentication, so whether I need multi-factor authentication or not, and so on. So I can just add the users whether it's Tableau with multi-factor authentication, and here I have to mention my email addresses of the various users. So I can specify something like this. I'll say demo1 at example.com. Okay, and here I can select the site role. Now when we are talking about this site role, so we have various roles that are available whenever we are working with Tableau. So if I click on site role, so under the creator, we have site administrator creator and a creator. So here, when I talk about site administrator creator under the creator, so this is one of the highest level of access for Tableau Online. So the person who is having the site administrator creator access, he'll have the unrestricted access to the content whenever we are working in this Tableau Online. So uh, like if I want to name a person who is above everything, so that person is actually called as server administrator. So this server administrator is actually present for Tableau server. So when I talk about Tableau server, it actually gives the highest license activated, and it allows the unrestricted access for the configuration settings of Tableau server, browser environment, all sites on the server, users and groups, and all the creative assets that we'll have. So for everyone, we'll have the server administrator as the highest access. So but that means server administrator has all the access, and the similar access will be provided to my site administrator creator, and this is applicable for Tableau Online. Okay, and we also have something called as creator. So here in this creator, so whenever the user has been assigned to this role of creator, it allows new features. That means this site role, it actually offers non-administrators the maximum level of content access. So if I want to name few actions, so they can connect to Tableau or external data in the browser, they can build and publish flows, they can access the data sources, and they can workbook along with that workbook, and they'll also have access to dashboard status as well, and use the interaction features on the published views. Not only that, when I talk about this creator, so they'll also connect to the data from Tableau Prep or Tableau Desktop, and they can publish, or like when I say publish, they can actually upload or save and download the flows, and they can also work with workbooks as well as the data sources. Now this is about the roles under creator. So site administrator creator and the creator. And under the explorer, so we have something called as site administrator explorer. So under this, so it has the same access that as we have seen for site administrator creator. So one difference is they can't connect to the external data from the web editing environment. So that's the difference between site administrator explorer and the site administrator creator. And this site administrator explorer can connect to Tableau they can connect to Tableau published data sources to create new workbooks and edit and saving the existing workbooks. So likewise, we have something called as explorer, and under the viewer we have only one role, that's called as viewer. So this viewer can see the published views which others have created, and use most interaction features, and he can subscribe to views, and he can download the various views as images and whatever the summaries that has been created. So they can also download the same, but they cannot connect to the data, they cannot create the data, or they cannot even edit or publish a content. Okay, so it's a very limited role. So this is the kind of role that we'll be giving to the end users. Okay, so this is about various site roles that we can assign to my individual users. Now, whenever we are working with the organization, so as I mentioned, we'll have most number of users using the content or the data that we have. So which means my individual department has multiple employees. Just to give you an example, my account department has 10 employees, and my data analyst group has 15 employees, and so on. So each user, the permission or the access that I'll give for each and every user in the department will mostly be the same. Now to help us in assigning the permissions, so what we can do is we can actually create the user groups and assign various users for the users, and I can create it as a group, and while giving the permission I can give it at the group level itself, which will help me to manage my permission in an effective manner. So this is about creating the users, and then we can set the permission. So while setting up the permission, so it's always takes in this format. So we'll actually evaluate the permission. So first we'll see whether the capability which we are looking at, whether it is outside the scope of that site role. If it is yes, obviously it will be denied. If no, then I'll be evaluating the role specific or the user specific permission. So whether he's the admin or project leader, If yes, allowed, and so on. So in this way, we'll be evaluating the various permissions. And we can plug in the data. Now, when I talk about plugging in the data, it's about the data source. So we can plug in the data by creating cloud connection, dashboard starter, as well as Tableau bridge. And we'll also have the monitoring and looking at the performance. So monitoring means understanding how the various users are using and what are the sheets that are mostly used and which are the permissions which are actually not required but I have added to them. So those comes under the topic of monitoring the site. And under the step 7, we'll look into increasing the performance. So one thing is like cleaning the data that we have, and instead of using the live connection, wherever possible using the extracts, and pay attention to the site design to make sure that the data and the site that we are working with, it's clutter free. So by doing all these things, we'll be improving the performance. And once we have achieved an optimal performance, we can also look for tuning those performance as well. And coming to the authentication, so Tableau supports various ways of authentication. So we can make use of Tableau authentication, Google, or SSO based authentication.
Previously, we learned about Tableau Online. Now, we will look at the top 5 BI tools, giving an overview of the most popular BI tools and their key features.
Now, learning business intelligence has given us enterprises of all sizes access to the power of data analysis as well. Now, receiving insights and finding trends is absolutely critical for businesses to scale and adapt as the years go on. This is exactly what business intelligence does, and the best thing about these software solutions is that their potential is practically unlimited. Now, before we begin with this session, let's look at a quick note on data governance. So, a successful business strategy, what is it? Now, a successful business strategy or a BI strategy begins even before it is executed and more often than not entails a good data governance policy. Now, cleansing data is essential before it is fed to your BI tool, as good data analytics is practically useless when performed on bad data. But a governance policy goes beyond just this. Now, data governance involves securing the data, levels of encryption, access policies and procedures, consequences for failing to adhere to the policy. All of these things go into a solid data governance program. Upon that, you can build a strong governance policy for your business intelligence systems. Now, having that covered, let's move on to the survey results and let's see what the BI tool buyer is looking for. Now, representatives of over 600 businesses from a variety of industries were surveyed and recorded. Borrowing from the numbers, we've made a list of the features that BI software purchasers are looking for. This shall provide you with the data on the features most desired by those in the market for a business intelligence system. Now, we can infer from this graph that the most sought after features from a BI software are dashboards, visualizations, reporting, predictive analytics, data mining, ETL, OLAP, and drill down facilities. Also, take some time to notice that advanced analytics were viewed as amenities and not as necessities in the graph, which basically means if you have the basic requirements in a BI tool, advanced amenities can definitely be built upon that. But it is not really a critical necessity. Now, enough chit chat. You didn't obviously think we'd give you all this information and leave you out without some recommendations, did you? So, if you're in need of business intelligence tools and services, here are some of our top recommended vendors. At number 5, we have the SAS Business Intelligence. Now, if you wish to get simple answers from complex data analysis, SAS Business Intelligence is a keeper. With really fast processing and effective guided exploration, you get a clear picture of the information you need almost instantly and deploy the models into service faster without any headaches. You will also learn to build better models with simpler features based on tested techniques. At number 4, we have Qlik. Now, among the best tools used in business intelligence is Qlik. With its guided tool QlikView and self-service business intelligence tool QlikSense, this powerful program offers fully interactive data operation. Now, this allows users to explore data at all times during input, processing, and output. QlikView also offers a system memory function that displays every action taking place during the analysis. It is an extremely powerful BI tool with a solid performance report. It is available on mobile platforms, which provides the same interactive analytical tools, intuitive associative search, and excellent visualization available on the palm of your hands. At number 3, we have Sissons. Now, the Sissons BI platform is the provider for one of the most popular and top-rated all-in-one BI solutions. This service offers a user-friendly interface, powerful data visualization tools, and interactive dashboards designed for very quick and easy usage. Sissons also includes the in-memory database tools and SQL Server integration. Now, this basically means that no matter where your data is, you can definitely analyze it, which brings this so high on the list. At number 2, we have the current leader of the Gartner's Magic Quadrant. I'm talking about Microsoft's Power BI. Now, this BI service earned a top score on our leaderboard in several areas. This includes its interactive visualization, predictive analytics, mobile access, the export of analytics reports, big data integration, and storyboarding. Not to mention, it is the current leader in its category as per Gartner's Magic Quadrant. Now, this solution is one of the more affordable options, including a limited free version in addition to their basic package, which makes it a good option if you want to venture into business intelligence tools. Now, many of you might already have guessed our leader in this list. At number 1, we have Tableau. Now, this 7-time leader of the Gartner's Magic Quadrant continues to surprise us by being one of the most popular business intelligence tools. Tableau is a commonly sought after BI platform and a great place to begin if you haven't had any experience with BI tools. It is easy enough that non-technical users can create customized dashboards and other reports to find valuable insights. In fact, Tableau is so popular that many people consider it the de facto standard. And most importantly, it is not just for pretty visualizations. You can aggregate your data and drill down to any level of detail using this service. Apart from that, it comes with a suite of services for prepping and sharing your data.
Having learned the top BI tools, we will now compare Power BI versus MSBI. This module will help you to understand differences between these two Microsoft BI tools and their unique features.
Now, before I begin, let me make it very clear that when I say MSBI, I'm going to talk about only one of its SQL Server data tools, which is the SSRS. I'll let you know the difference in a bit. Now, the MSBI is a Microsoft product with ETL capabilities, which basically means it can extract, transform, and load data. It has this multidimensional data organizing and visualization ability. So MSBI comes with 3 sub-components or tools to support the earlier mentioned functionalities. The following are the components of MSBI. So we have the SQL Server Integration Services, or the SSIS, which is a component which basically works as a data integration service and perform up to some level of ETL activity. Next, we have the SQL Server Analytics Service, which is a component which works as multi-dimensional data storage using Cube to store the facts and dimensions. Finally, this is what we are going to be comparing Power BI with. This component, the SSRS, or the SQL Server Reporting Service, works as a data visualization and reporting layer, and it allows to create dashboards and reports for MSBI. I'm doing this because we can't really compare MSBI with Power BI, which was basically just designed to improve the self-service capabilities of the older SSRS, which is just one of many services of the MSBI. So let's start with the comparison. But first of all, what are these two tools? So the SSRS, or the SQL Server Reporting Services, is a BI service for data analysis and generating reports on the server-based data. It was developed in 2004 by Microsoft, along with its data analytics and data integrating counterparts. Now, it is a comprehensive, extensible reporting platform, which includes integrated set of processing components and programming interfaces. It is used to design, test, and deploy the report So mainly it's a server-based platform. On the other side, we have Power BI, which was also developed by Microsoft in the year 2017, which is a data analysis and reporting tool, which can be used for reporting from a wide range of data sources, both traditional and untraditional. Now, the Power BI desktop allows you to create reports on the fly and publish them. Using any browser, end users can view these reports. So the Power BI is simple and user-friendly, which helps business analyst skills and Power BI users to work easily on it. For the complex and huge data analysis, Power BI is very useful as it is widely used for modeling and structuring of unshaped data. So this comparison is going to be based upon the following criteria. We have implementation, benefits of each of these tools, accessibility and use on various platforms, license and pricing, a learning curve, user experience, data dependency, and finally, the conclusion. So without much ado, let's begin with the comparisons. First of all, we have implementation of each of these tools. Now, the SSRS is used for server-based reports only, while the Power BI is used for server-based as well as cloud-based reports. Now, the biggest difference between these two systems is how they are deployed. Since cloud-based software is hosted on the vendor's servers and accessed through a web browser, and on-prem software is installed locally on a company's own computer and server, the fact that these services are equally promising has led to an ongoing discussion about the superiority and the security concerns of one over the other. The fundamental point is that not all solutions work equally well in the cloud or in the on-premise hosted solution. There are benefits and disadvantages to both the platforms. Your choice between these platforms will depend mostly on the type of need, service, or software you're considering. Now, what about the cloud platform? Hardware failures do not result in data loss because of network backups. So cloud computing uses remote resources, saving organizations the cost of servers and other equipment. Also, a utility pay structure on the cloud platform used by Power BI means that users only have to pay for the resources they use. However, with the rise of cloud-based services, an additional fear comes into play. After all, you're trusting someone else to host your data, aren't you? The fear is so widespread that many IT leaders believe that this powerful internet services are a security nightmare. So in that case, server-based reports are definitely safer, which gives 1 point to SSRS and 1 point to Power BI. Next, we have benefits of each of these tools. Now, both of these services have their own benefits, while the SSRS by MSBI has a better drill-down capacity, which basically means in a GUI environment, you can move from one place to another information to detailed data by focusing in on something. The Power BI, on the other hand, has a plethora of rich visuals, which represent data so much better. Also, since it was designed to improve the self-service capabilities of the older SSRS, anyone who can visualize data can use it easily. Next, we have accessibility. This is a pretty simple point. The SQL Server Reporting Service, or the SSRS, can be operated using the web and desktop, whereas the Power BI can be used with the desktop, the web, and the mobile app. You can also generate a QR code from a report in the Power BI, just in case you want limited people to have access to your reports. Next, we have the license and pricing, pretty important. So the free version for the SSRS lasts 180 days, which is followed by a base charge of $931, whereas a free version for Power BI lasts only 60 days, but the base price is less than $10. Note that the pricing I have mentioned here are only the base prices of both, and there are other versions of these services and the prices vary for each of them. Next, we have a very important aspect, which is the learning curve for each of these tools. Now, the Power BI is a graphical tool, so through drag and drop, you can easily complete your report, but the internal processes are hidden, so you can't really understand how it works. But in the SSRS, the developer has to do all the coding and designing of the report, so the developer has a better picture of the process and a better understanding of how this data works. Next, we have user experience, which is a complete win-win for Power BI, as it has a lot of graphical component as compared to SSRS. It makes Power BI way more efficient and easier to use, whereas in SSRS, it has more manual effort to be put in for analysis and generating the reports, so it's not really the easiest option for beginners. With that, I come to my final point, which is the data dependency. Now, the Power BI can deal with structured as well as unstructured data, but due to that, its data capacity is limited to only 10 MB or 33,000 rows of data, whereas the SSRS deals with structured and semi-structured data, so you can create really large reports on it. I think with that, we are ready to conclude. So as you can see, I've made comparisons on both sides for the SSRS as well as the Power BI. Now the SSRS is for your pixel perfect operational reporting. So that is why it ensures a better background understanding of data, a higher drill down capacity. It works with structured data, does not have any size limit to reports, and most importantly, it has a design first approach. And the Power BI, on the other hand, is first and foremost an analysis tool. So it allows you to visualize your data in different ways in order to allow deeper understanding of your business and not the process. So that is why it is rich in visuals. It is supported by cloud service. It is interactive and pretty user friendly. It is portable and low cost. So till now, SSRS has had a lot of presence in the IT market, but now Power BI has made its presence known across all domains. The choice between Power BI and SSRS will likely be straightforward and likely be driven by requirements. So if your organization uses only paginated reports on premises, you shall decide that SSRS is more cost effective as an option. On the other side, if you have the need to render interactive or analytical reports on the business, then possibility is Power BI reporting services will likely be your preferred choice. So now that you know the pros and cons of each of these services, which one do you prefer?
We just compared Power BI and MSBI. Next, we will prepare for job interviews with data warehouse interview questions and answers, focusing on commonly asked questions and effective answers.
The first obvious question that's usually expected out of a candidate is, what is a data warehouse? Now, before I answer this question, we first have to understand what is business intelligence, right? Because the words business intelligence and data warehouse are very closely related to each other. Business intelligence is the process by which we collect data about a business, we analyze the data, and then take action. This is the definition of business intelligence. Data warehouse is the technology that supports business intelligence. So data warehouse is the collection of tools and technologies that help a business collect data from multiple processes, organize the data, and enable business intelligence. Many times people often mistake that data warehouse is an appliance. It's a different kind of software. So let me tell you, data warehouse is not a different kind of software. Data warehouse is implemented in the same database as a transactional system. The difference is on how you organize the data and how much data you store in a data warehouse. So usually in a transactional system, you store minimal data, whereas in a data warehouse, you store current plus historical data, right? That being said, a data warehouse or a transactional system can be implemented using the same software, such as Microsoft SQL Server or Oracle or MySQL. So as you can see the definition in this slide, data warehouse is nothing but a relational database designed for analytical needs, and it's a central location where data from multiple data sources are stored, which then can be accessed exclusively for data analysis and visualization by using business intelligence tools such as Tableau or Business Objects. Next question is, what is the basic difference between a data warehouse and an operational database? Or in other words, what is the difference between a data warehouse and a transactional system? So think about the dashboard of your car. There are some metrics that are shown to you, such as a speedometer. The speedometer shows you what is the current speed that you're doing right now, right? What happens if the speedometer stops working? It's a real hazard because you could be operating the vehicle beyond its permittable limit, right? Or you could be breaking the speed limit in that territory. So the speedometer is an example of an operational system or a transactional system. Why? Because it helps you run the business. So transactional systems help you run the business. On the other hand, A data warehouse helps you analyze the business. In the dashboard of a car, an odometer is an example of a data warehouse because it's not showing you current information, but it's showing you historical information. What is the total miles that you have put on your vehicle, right? And if the odometer were to stop working, it won't cause any hazard. You can still live without it for a couple of days. This is the fundamental difference between a data warehouse and a transactional system, which is a transactional system is very much necessary for ensuring your business runs all the time, whereas a data warehouse is necessary for not running the business, but for analyzing the business. How well is the business performing? And given these needs, a data warehouse contains historical information, which helps in analyzing business metrics over time. And the most frequent operations that happen in a data warehouse is the reading of the data, right? So data is written once, but the read happens many times over. And the end users are usually business analyst and data analyst. On a transactional system, you maintain as minimum data as possible. That is because you want to ensure that your application keeps running as much as with high performance as possible, right? And in a transactional system, there are large number of transactions that happen, which include create, insert, updates, and deletes. And the end users of transactional systems are users who are necessary for running the business, such as operational team members. All right, we have a question from Vardhan. Vardhan is asking, is a data warehouse OLAP and is a transactional system OLTP? Absolutely, right? So OLAP, or in other words, online analytical processing, is a class of applications that help you analyze information. And data warehouse clearly belongs to a OLAP category, whereas a transactional system belongs to OLTP category. So OLTP stands for online transaction processing. The next question is, what is data warehousing? As I already explained in the first slide, data warehousing and business intelligence are related. Data warehouse is the technology piece that helps you collect data from multiple sources of the business and keep it in a centralized location from where it can be accessed for reporting. So if you look at this diagram, it shows you a typical architecture of a data warehouse. So looking at the diagram from the leftmost side, you have the data sources. So data source can be a database, or it can be a unstructured system such as flat files or CSV files. All of this data initially is kept in a common database, which is called a staging area. Now the staging area is considered a part of your data warehouse. So once the data is stored in a common location, it makes it much easier to integrate the data and clean the data and then move the data forward. As we move the data forward, we transform the data from the staging into dimensions and facts and other supporting data types such as aggregate data and metadata. We will look at what is metadata and aggregate in few slides later. Once you have the dimensions and facts, from here we move the data to data marts. Now this is an optional layer. The data marts can be physical databases, or they can be simply logical grouping of these data. So for someone who's accessing the sales data mart, they will only get to see the dimensions and facts which are relevant for sales. The same applies for purchase and stock. And when it comes to the user group can access the data mart or the data warehouse either directly using a database query editor, or they could be accessing the data through a reporting tool. Next question is, what is OLAP? So OLAP can refer to a class of applications. At the same time, it can refer to a specific set of tools as well. So let me give an answer for both. OLAP stands for online analytical processing. So if you were to divide all the computer applications into two major classification, one would be OLTP, the other would be OLAP. The OLTP, or the online transaction processing, are the systems where the data originates. An example of that would be a point of sale in a retail supermarket. So that is where you bill your products and an invoice is generated, right? And an event has occurred and the data has been generated, which is stored in a database. So that's an example of an online transaction processing. Online analytical processing, on the other hand, does not originate data, it does not create data. Instead, it is used to analyze existing data, right? An example of OLAP is your data warehouse, right? So data warehouse is built to collect data from other OLTP applications and then analyze them. So this is a broad understanding of what is OLAP system. Now, talking specifically about BI tools, OLAP refers to a certain set of tools that load the data directly in memory. And an example of that is SQL Server Analysis Services from Microsoft, or SSAS for short. So what exactly is OLAP? In other words, it's also called as a OLAP cube. So if you look at the tables in your data warehouse, they are not very different from any other tables. It's just that we follow a convention called as dimensions and facts. At the end of the day, you still have to join these tables using primary key foreign key relationships to analyze the data. OLAP cube, on the other hand, takes all of this data together, does the join, gets the aggregate data and stores it in memory. And the data is stored in a proprietary format. Once it is stored in memory, anybody can access the data in the cube by simply using a spreadsheet-like application, including the Excel spreadsheet itself. You can connect to a cube and you can simply drag and drop attributes to get the data. Since the data is already joined and pre-aggregated and it's in memory, the data retrieval is quite instantaneous. One does not have to write any SQL query to get the data. So talking specifically about a tool, when we say OLAP, we are referring to OLAP cubes. Okay, Prakash has a question. Is Tableau a OLAP tool? So, all right, Tableau can do both. Tableau can act as OLAP tool. It can also connect to a database. So there is an option of live and extract in Tableau. When you set it to extract, Tableau will get all the data and it can either keep it on the Tableau server or you can cache it in memory. So anytime anybody refreshes the report, the data is going to be returned from the memory or the server cache instead of the database. So yes, Tableau can act as a cube when configured the right way. Moving on. Another question that's most frequently asked is, what is OLTP? How is OLAP different from OLTP? So just a few slides before, we discussed the example of a car's dashboard, right? So expanding on that example, any system that is absolutely critical for running your business can be thought of as OLTP. Any system that is used for analyzing how your business is running can be considered OLAP. And when you start this classification, you'll realize that OLTP systems are quite critical for the business. Any downtime is not tolerated, whereas OLAP, on the other hand, are not business critical. Even if there is a downtime of few hours to few days, it can still be tolerated. However, they are quite important for analyzing your business. An example for this would be a point of sale. Point of sale in a retail super chain is an example of OLTP where if there is a downtime, if you cannot check out your products, if no bill can be generated, then the business comes to a halt, right? So think about an OLAP. So there is a area sales manager who is responsible for looking at the sales metrics. Now for the sales manager can look at the sales metrics on a daily basis or a weekly basis. However, if the metrics were not to be available for a single day, it won't stop the business, right? So that's an example of a OLAP. Given these differences between OLTP and OLAP, the way the data is organized and the amount of data that is stored between OLTP and OLAP is very different. Okay, Meena has a question. Is banking system an OLTP or OLAP? Good question, Meena. So let me explain the OLTP and OLAP components within a banking system. Now, I'm sure all of you have a bank account and you must have a bank application installed on your smartphone, or you probably go to the website, right? So what you'll notice is that when you log into the bank application, there is a place from where you can look at all your historical statements, right? So usually there is a link and it will let you select the past 60 days or the past 90 days set of transactions, right? And anything beyond 90 days is not available. If you still want transactions older than that, there would be a separate link which would say something like download historical statement. That would be a separate link. So these two links are there for a reason, right? So the reason that there is not a single link is because banks generate a whole lot of information, right? Every customer contributes to a large number of transactions on a daily basis. If all of it were to be stored in one application, which is in the bank application, the performance would be severely degraded. So what banks do is they store the minimal amount of data in the OLTP system. The rest of the data is stored in the OLAP system, and which is why you have two different links. Moving on. What is a dimension table? This again is quite an obvious question, and especially if you're new, you're often wondering what exactly is a dimension table. Dimensions and facts are at the heart of a data model in a data warehouse. So let me put it this way. Assume that you are the area sales manager and you are interested in how the sales organization is doing. So if somebody mentions to you that, yes, today we sold 10,000 units of several products, just the number 10,000 doesn't add any value. You really cannot understand whether you're doing good, whether you're doing bad, what is the room for improvement. That is where we need some context. We need ways by which this number 10,000 can be divided. So you will naturally ask questions such as, if today's sale is 10,000, how much was the sale yesterday? What are my top 5 products? What are my top 3 stores? Who are my top 5 customers? And so on. So the entities by which you divide the data become your dimensions, and the measurement itself becomes a fact. So dimensions are entities that give context to the data. So for example, in a retail chain, if sales is a fact, if sales is a measurement, then the dimensions for that would be product, customer, date and time, store. So these dimensions give a whole new meaning by which you can slice and dice the data. So the earlier $10,000 can now be divided into $5,000 per store, or we sold $7,000 within first half of the day and $3,000 towards the end of the day, and so on. That gives context using which you can take further action. In other words, dimensions answer the 7 questions of a business event. And those 7 questions are who, what, when, where, why, how, and how many. So any business event such as sales or a banking transaction can be associated with 7 of these dimensions. So let me repeat that again. Who, what, when, where, why, how, and how many. Each dimension usually has a set of attributes. For example, if there is a customer dimension, the attributes for a customer dimension would be customer first name, middle name, last name, age, date of birth, contact number, address, and so on. These are called attributes. And all of the data related together, since they are related to a customer, they are collectively called as a customer dimension. What is a fact table? So as I explained in the previous slide, dimensions or facts are at the heart of the data warehousing data models, right? So a fact is the business event. Fact represents the grain of the business event that is to be measured. So for example, if sales is a business event, the fact would be how many number of units did we sell? What is the total selling amount? What did it cost us to buy? What is the discount amount? What is the tax amount? And so on. All these are called facts. The difference between a fact and a dimension is that dimensions can be independent, whereas facts are not. So let me explain that with an example. When you walk into a store as a customer and you purchase a product and you finally get them billed, right? A transaction is created. And that moment when the bill is generated, there are a couple of things that happen. You as a customer walked into a store and picked a couple of products. Before this event happened, all of these dimensions existed already. It's just that they were not related to one another. So you as a customer were already there, the store was already there, and so was the product. It's only because of the sale that all of these dimensions are related together now. So the business event that brings together the dimensions into a transaction is usually what becomes a fact table. So a fact table is dependent on the dimensions. And there's one other interesting thing that happens. When a business event occurs and it is captured into a fact table, it not only captures the different dimensions that are related with each other, but also it gives rise to some numbers. An example of that would be tax amount, discount amount, and the total selling amount. These were numbers that did not exist anywhere before, but were generated as part of the transaction. These numbers are called measures. So as you can see here, a fact table contains two kinds of data mostly. A dimension key that can be tied as a foreign key relationship to any of the dimensions, and a measure. So a dimension key here can be a customer ID or a product ID, and a measure can be total number of products sold, or what is the total selling amount, and what is the tax amount, and so on. Moving on, what is the level of granularity of a fact table? Now this is quite an important question. So what exactly is grain? Now these questions can come to you in different ways. So for example, the interviewer will ask, what is the grain of a fact table, or how do you decide the grain of a fact table, and why is it so important? So the grain is nothing but the level at which the business event occurs. Okay, so let me give you an example. Now, if a sales manager wanted to record the sales of a store, she can do it at a level of a day, meaning you simply consolidate all the sales that happened in a day and you just show one number that shows, okay, today's sales were $5,000, yesterday's sales was $3,000, and so on. So that grain is at a day level. Although it seems to serve the purpose, there are many questions that cannot be asked, such as what are my top selling products, who are my top 3 customers for today, and so on. That is where we need to lower the grain a little bit more. So we need to capture the individual transactions that happen. And when we start doing it, the fact table will have one record for every transaction that is made. So let's assume that every customer who makes a purchase has a sales order ID generated. Now, if you think the sales order ID is the grain of the fact table, you could be mistaken. Because if you look at a sales order ID, it's quite possible that a customer can purchase multiple products and multiple units of every product. So given this, the sales order ID is not the grain. The real grain is a combination of sales order ID and a product. So let's see if this can be broken down even further, right? So a customer walks in to a store, he purchases 2 products, right, and generates a bill. There is nothing more atomic than that. So that is the lowest grain of the fact table for a sales. So I repeat, the grain of a sales table will be the sales order ID and the individual product ID. So for each sales order ID, there could be multiple records in the fact table. Now getting this grain is very important, because if you get the grain right, then it involves a lot of dimensions, which in turn makes your data model very rich in terms of what are the kind of questions you can ask. Going back to the example I started with, which is the sales manager just wants the daily sales. If that was the case, the only dimension that can be attached to that model is the time dimension. All right. So you're just saying, what was my sale yesterday? What is my sale today? And so on. By lowering the grain to the naturally occurring grain of the business event, which is a sales order ID and a product ID, we can now ask very rich questions to the data model, such as show me my top 3 customers for today. Show me the top 5 selling products for today. Show me the discounts or the promotions that were used today, and so on. Okay, Madhav has a question. Can the grain of a fact table change? Good question, Madhav. So if the business users, who are the stakeholders in the data warehouse, and the data modelers who are responsible for creating the dimension facts, if they have done a proper groundwork and a prototype at the very initial level of designing a data warehouse, then they should have got the grain right the first time itself. If not, due to some reasons, if the grain was not correct, then there are chances of correcting it later. However, the impact can be severe, especially on any reports that you may have created. So in cases when the grain of the fact table is changing, it's always advisable to create a new fact table with the new grain and slowly move all the reports and dashboards from the older fact table to the newer fact table. So that way your reports do not break immediately and you do not disturb the existing fact table. All right, moving on. What is the difference between additive, semi-additive, and non-additive facts? This again is a popular question, and sometimes there seems to be some confusion, right? So if you look at the definition here, an additive fact is a measure that can be fully summed across any of the dimensions. So what that means is, if you look at the selling amount or the sold amount that is there in a sales fact table, it can be rolled up across any of the dimensions. So for example, you can write a query such as, show me the total sales amount per day, or show me the total sales amount per customer, or by store, and so on. So the sales amount or the sold amount is a number or a measure that can be aggregated across any of these dimensions. So which makes it a additive fact. And of course, the aggregation that we would be applying would be a summation on the sold amount. A semi-additive fact is a measure that can be summed across only some dimensions, but not all. An example of that would be the daily average balance of a bank account holder. This number can be summed up across customer dimension, but not really a time dimension. And let me tell you why. So let's say my daily average balance for yesterday was $50 and my daily average balance for today is $60. So if I were to do a summation of it over time, it would mean for 2 days, my daily average balance was 50 plus 60, which is $110, which is not right. So you would have to do an average of it, right? So if you were to do the same summation across a different dimension, such as customer, it would make sense. So for example, show me the total daily average balance across 100 customers. So it would maybe show a number like $1,000, which is still fine, right? It makes sense. So the daily average balance in a banking fact table is an example of a semi-additive fact. And sometimes, the questions that are asked is, how do you restrict a semi-additive fact? Because we say here, it cannot be summed up across other dimensions. So is there something that restricts? The answer is no. There is nothing that restricts. You can still roll it up across all the dimensions and you will get a number. The question is, does it make sense, right? So in the example that I gave, I can write a query which will show me $110 when rolled up by a time dimension, but that number does not make sense. So the difference between additive and semi-additive fact is that there's nothing that's going to stop you from generating these numbers or aggregating these numbers in a query. It's just that for us to decide, does that number make sense? Can it be rolled up across a dimension? And finally, non-additive fact. So an example of a non-additive fact is any ratio or a percentage or any calculated measure that is pre-calculated and stored in the fact table. An example in a sales fact table would be a discount percentage. So since it's a percentage, it's already aggregated. If you were to sum it up by time or by customer or any other dimension, it really may not make sense. So for example, if I were to say, do a sum of all the discounts that we did today, and it would show up a number like 5,000%, which really doesn't make sense. The next question is, what is a factless fact table, right? Again, this is quite a popular question and there seems to be some confusion about it. So a factless fact table is a fact table, as we discussed before, except that it only has connections to the dimensions but no measure associated with it. So think about a charity organization, right? Just imagine you do not make a sale in a day. You just simply give out products for free to your customers. So what happens? Your customers walk in, they pick the products that they want, they don't generate a bill, they just walk out. They probably just enter a form saying, okay, I've picked these products. When that happens, you don't have a sold amount, you don't have a tax amount, discount amount, you don't even have a number of products. You just know that the customer walked into this store in this date and time, right? And they went away with these many products. So when you have a business event like that, that is called a factless fact table, right? Because that fact table simply captures the interaction between the different dimensions without any facts to it or without any measures to it, such as sold amount. So the example that I gave for the retail chain, may not happen in reality, but another example that I could give you is, let's suppose there is a seminar and you are collecting statistics of the people who are visiting, right? So people who are attending the seminar. So you would capture things like what is their age group, what is their gender, which area or state they are coming from, right? And maybe other details. So your fact table will have a link to all these different dimensions such as date and time, what was the topic of the seminar and so on. But if you look at the fact table itself, the fact table will simply have dimension keys without any measures because there simply is no measure for this business event. Moving on. What are conformed dimensions and conformed facts? In layman's language, conformed dimensions is nothing but a reusable dimension. So dimensions once created for a department can be used across multiple departments. So if you were to follow Ralph Kimball methodology of building a data warehouse, you will realize that when you start building a data warehouse for an organization, you usually start with the department that needs it most. So let's take an example of a startup firm which is into a retail industry. So in retail, your first and foremost focus is on sales. You want to increase the sales. So obviously you would want to build a data warehouse for sale. And when you do that, you create multiple dimensions. You define new dimension tables. So in a retail, you would have dimensions for customer, product, address, store, date and time, and so on. Now let's assume the data warehouse is built and the sales department is using it. And after a while, you want to build a data warehouse for, let's say, the shipping department. And when you begin with that, you realize that some of the dimensions that are required for shipping are already built in sales, such as customer and product and date and time and even the address, because you are shipping to a customer, you're shipping a product to a customer on a date and time for a specific address. Given all these common data points between the sales and the shipping department, you simply reuse the existing dimensions. So that is an example of a conformed dimension, where dimension once built for a department can be used consistently across other departments in the same organization. Similarly, we also have the concept of a conformed fact. So conformed fact could be business events that are of interest for multiple departments. So for example, when a sales order is placed, it's not only the sales department that's interested in it, but even the shipping department and maybe the inventory department as well, because they want to prepare for their workflow. So in which case, we share those fact tables or measures across the departments. So that's an example of a conformed fact. And related to a fact table is an aggregate table. So let's look at a retail chain as an example again. In a retail scenario, there could be millions or even billions of transactions on a daily basis. And for someone who's responsible for analyzing the sales, it would be a very tedious effort to look at all the millions and billions of sales as individual records. Instead, they probably want to look at the aggregate. They want to condense the information. So all they're looking is what is my daily sales, right? What is the profit for today? How many number of units did we sell today? In such case, we do an aggregate over the base fact table and we give them the data. So for someone who's looking at just the sales by hour, we would probably give them a report containing 24 records or 24 rows in a simple table, with each row showing the count of the number of units sold per hour. So this is fine, and you can get this data from your base table. However, if this is a common data access pattern, if you have to do it on a regular basis, then it makes sense to get the data out and store it in a separate table. So if your base fact table has millions of transactions for a day, your aggregate table will probably have one record if it's at a daily level or 24 records if it's an hourly level. So any knowledge worker or a data analyst who's simply looking at the aggregate number can direct their query towards a very small aggregate table instead of the very large base table. This tremendously improves the query performance of a data warehouse. What is summary information? So summary information and aggregate tables are related to each other. So summary information is the place where we store all the aggregate tables. Now this can happen at various levels. we can either persist these as physical tables, or we can keep them in the reporting layer, such as Tableau and business objects. And within these reporting tools, they have cache at multiple levels, such as report level cache, data access level cache, and so on. So wherever the aggregations are kept, that area or that layer is referred to as summary information. Okay, what is ETL? ETL stands for extract, transform, and load. Now, ETL belongs to a broad classification of tools called as data integration tools. Data integration tools refers to a set of tools that are used in moving data from one application to another application. So Informatica, Talent, Unity, Web Methods, these are all examples of data integration tools. Within data integration, we have three more categories, such as ETL, application to application integration, as well as replication, of which the classification that's of interest here is the ETL. So Talent, Informatica, SSIS, these are examples of ETL. So what is ETL? ETL stands for extract, transform, load. This name has been derived by the architecture of a typical data warehouse, where we usually extract the data from the data sources, we store it in a staging layer, we perform some kind of cleansing and transformation over the data. Now this transformation can include converting the data into dimensions and facts, and finally the prepared data is loaded to a data warehouse. Given this pattern of data movement, which is very specific to a data warehouse, where we read the data, transform it, and then load it, any tool that is purpose built for this is referred to as an ETL tool. But please be aware that not all tools are ETL tools. So as an example, Web Methods, Microsoft BizTalk, Unity, although these can move data as well, they do not have the same features and capabilities of a ETL tool. They are application to application integration or sometimes replication tools. Here are some of the tools that are quite popular in the ETL space. So at the top of the chart is the Informatica, which is very popular across enterprises, followed closely by Talent Studio. So Talent Studio is an open source software which has an enterprise version as well as a community version, and it's quite popular with small startups, mostly because it is completely Java based and it generates Java code as an output. There are other popular tools such as DataStage, Oracle Warehouse Builder, Ab Initio. Then we have SAP, Data Services, SSIS, which is from the Microsoft and part of the MSBI stack. And we also have SAS Data Management. Of these tools, I would highly recommend you to pick up Talent and SSIS. The reason is SSIS is quite developer friendly. So if you are from a Microsoft background, it really helps you understand ETL and how it works. And you can give a try for Talent Studio once you're comfortable with SSIS, because Talent Studio has a lot of rich features. Since it's community driven, you will find a lot of plugins and components that you can use to move data from anywhere to anywhere. So for example, Talent Studio can connect to Google Sheets or your Google Drive. It can read data from there and it can publish to a Hadoop file system. I would personally recommend that you pick up at least 2 of these ETL tools, so that way you get a clear grasp of how these ETL tools work, and you'll realize that most of them have a quite common architecture and how they're implemented. All right, so the next question is, what is a data mart? Now, a data mart, just this definition is often a cause for confusion in many organizations, right? So let me talk about a data mart and a data warehouse. A data mart refers to a data warehouse that is purpose-built for a small department or a single department. A data warehouse, on the other hand, refers to a set of dimensions and fact tables that have been built for the entire organization. A data mart is specific to a department, or it can be specific to a line of business, whereas a data warehouse is built to serve all the departments. And this is often related to the discussion between a Kimball methodology versus Inmon methodology. Rolf Kimball preaches the bottom-up approach of building a data mart for one department at a time and eventually merging all of them into a larger data warehouse, Whereas Inmon suggests that we should build a data warehouse for the entire organization that would serve the needs for all the departments, right? So taking that into consideration, Data Mart is a small version of the data warehouse, or it is a subset of the data warehouse which deals with a single subject. In other words, deals with a single subject area or department or a business vertical, or in other words, a line of business. Given the scope of a data mart, the time taken to build a data mart is very less compared to build a complete data warehouse for the entire organization. But this is not always true. So if you were to consider a very small startup, it's quite possible that they can build a warehouse for all their departments at the beginning itself. But this really may not work for a very large organization. And for those of you who are attending an interview, you must look out for this question because in different organizations, they call it by different names. So they may have a data warehouse that is serving multiple departments, yet they refer to it as a data mart, right? At the same time, in other organizations, they may have a very small data warehouse for a specific department, right? And instead of calling it a data mart, they refer to it as a data warehouse. So always make sure that when you get a question like this, you make yourself clear that as per you, this is the definition, which is a data mart is for a specific department or a subject area, whereas a data warehouse is across departments. Okay. Next question, what is metadata? All right. So metadata is defined as data about data. I believe most of you are familiar with that explanation. But what is metadata in the context of a data warehouse? Why is it important? So metadata is often overlooked but quite powerful when it comes to understanding and maintaining your data warehouse. So if the data warehouse is collecting all the data about a business, the metadata itself collects information on what is the source system from which you're collecting the data, what are the table names, what are the data types, and so on. Once this data is collected, it's easy to build a data lineage. It is easy to understand impact. So for example, if a source system is changing, using the metadata, you can identify a certain table and column in the source system. How is it mapped to a corresponding dimension or a fact table in your data warehouse? It shows you the mapping on how the data is flowing. With this information, you can prepare for your changes. Without metadata, even if somebody tells you that, okay, there is a change that's happening in the source system, you will not be able to react in time. You cannot do impact analysis as easily as you can do when you have metadata. So metadata is often neglected because it is thought of that it's probably not required, but metadata should be created and maintained from day one of building a data warehouse, and it should be continuously updated. Okay, Sheetal has a question. Are there any tools to generate metadata automatically? Okay, that's a good question. So metadata cannot be generated. It can be as long as you're using the same family of tools. So for example, Informatica can generate metadata about the jobs. But what about the reports that are using your dimension tables? What about some other tool like Talent if it is also being used in your project to move the data? How do you maintain the metadata there? So although some of these tools like Informatica can generate metadata, it is specific to the packages that you build using that tool itself, but it cannot support anything outside of it. So I have worked on projects where I have maintained metadata irrespective of the tools. And the idea is to build metadata from day one and continuously update it, keep it away from any automation so that even if the tool were to change, even if the technology were to change, metadata still remains something that can be easily modified. Okay, Pawan has a question. Do users access metadata? Okay, that is quite possible. However, in most cases, metadata is reserved only for the data warehouse developers. So as a member of the data warehousing team, you want to understand how is the data flowing? What are the mapping? What happens if a column in the source table is deleted? All right. So it's of most importance to the data warehouse developer than the business user. However, in some cases, the business user may also want to access this. And those are the kind of users who are very comfortable with the systems, right? And they want to understand where the data is flowing from. What is the source system and what is the corresponding dimension and fact table. So for such power users, yes, you may need to give access to the metadata. Okay. Another question is, what is data mining? How is it different from data warehousing? So before I answer that question, let me give a little refresh about the dimensions and facts. So as we discussed, dimensions are something that give context to the data, right? If sales is the business event, then you have dimensions such as customers, products, date and time, store, geography, and so on. So you can aggregate the data, you can look at the sales by these different perspectives or different dimensions. Data mining, on the other hand, can negotiate across or navigate across all these different dimensions and find hidden patterns. An example of that is when you use your Amazon app or any shopping app. If you're looking at a product and let's say you already bought the product, at the bottom of the screen, you will see some recommendations such as people who bought this phone also bought this case. People who bought this sports equipment also bought probably running shoes and so on. So how is this data generated? So all the transactions that ever happen are stored in a data warehouse, and there are complex data mining algorithms that keep scanning the data. And what they do is they look at the product that you're looking at in real time. They look at the historical transactions, all the sales that have been done by other customers, and they see if there's anything that's common. Is there or was there another customer who bought the same product? If so, what were the other products that the customer bought? And given this information, it would display it immediately to you in the application. This is an example of a data mining. So data mining is slightly different from dimensions and facts in the way that it scans through all those tables and it tries to find correlation between data. But the good thing is data mining is achievable through data warehousing. So what is a data warehouse? Data warehouse is a place where we organize all historical data, right, for analysis. So using that same infrastructure, you can run your data mining algorithms. Okay, Prakash has a question. So I said the data warehouse is historical data, but I'm also saying that the Amazon app is in real time. Very good question. So when I say historical data, what does it mean? Every sale that you ever make, right? All of that goes into the data warehouse. Or let me give you a different example. So let's take a banking application as an example, right? So you can go in and update your contact details or your address details. And when you do, once you have saved the changes, the next time you log in, you will see those changes reflect the new details that you mentioned, right? As far as you're concerned, the data that was earlier there, the contact details, they are gone, right? They have been deleted. But the truth is, they still exist, not in the transactional system, but in the data warehouse. So the data warehouse will keep a track of the number of times you have changed your contact details. And this is how sometimes the banks alert you on some irregular activities, right? So if it feels that you have used two different ATMs at the same time, right? And if they are geographically set apart, then it is historical information processing that helps the bank give you an alert saying, okay, there is some irregularity in your transactions, right? So take that same example. The data mining algorithm is looking at your current activity, which is you're looking at a product, and then it is going to the data warehouse and it works really fast. It works really, really fast. It's scanning all the historical data. So when I say historical data, sales that have already happened, and then it gives you suggestions, right? The Amazon app is an example where there is a blend of real-time and historical data. All right. So what you're looking at right now is real time. You're looking at a product that's there in the inventory. Plus the recommendations that you're looking at are real time as well. However, they are based on historical data. So data mining is very suitable because the way the data is organized in a data warehouse is perfect for running data mining algorithms. Okay. The other popular question that is asked mostly of report developers is what is OLAP servers or what is OLAP cubes? Now these questions can come to you in several ways. What are the different kind of cubes? How do you refresh a OLAP cube? What are the different kind of OLAP architecture and so on, right? So as we explained at the beginning of this slide, an OLAP cube refers to a data structure where the data is stored in memory, right? And users do not have to write a query. The data can be accessed simply by dragging and dropping attributes, right? So There are several architecture styles when building a cube. So let's look at these. The first is a MOLAP or multi-dimensional OLAP. So in multi-dimensional OLAP, you define a cube, which is a set of dimensions and facts. You process the cube. By processing, I'm referring to the fact that you get all the data and populate into the cube. And then you publish the cube into the server or the server's memory. And from there, the users can directly access the data. This has several advantages. One, there is no query being written. Second, the data is retrieved once from the database and stored within memory, which means the performance is going to be very high. The data can be retrieved instantaneously without the user having to worry about where is the data coming from, what are the joins, how many tables are involved, and so on. Some of the shortcomings of multidimensional OLAP is that you can only store a minimal amount of data. The reason is memory or random access memory still is hardware that is not easily procured. It is not cost effective in comparison to, let's say, hard disk or storage. So given this fact, you need to strike a balance between how much data you want to store in the multidimensional OLAP. The next category is relational OLAP. Relational OLAP is very similar to multidimensional OLAP, but here only the cube is published to the memory, but without any data. The data, in fact, is still stored in a database, and the database can be a relational database like SQL Server or MySQL. So what happens when a user accesses a rollup cube? So when somebody accesses this kind of a cube, since the cube does not have any data by itself, it only has the data structure. The cube connects to the database, gets all the data that is required, and then shows it to the user. So the cube does not store any data. It still goes to the database and it can write its own queries to get the data. So this approach has to be taken when there is a severe shortage of RAM, or if there is simply too much data to be stored in the memory. The last category is hybrid OLAP. So hybrid, as the name suggests, is something that has the best of both. And in a hybrid OLAP architecture, you can control what is the amount of data that's stored in the cube or in memory, and what is the data that is stored in the relational database. So you can take a decision based on data access patterns. If there are some tables or if there are some aggregations that are most often used, you can store them in memory, and the data that is used less often can be stored in the database. So this tries to strike a very good balance between the amount of RAM that's available versus how much data you store on the disk. The best example that I have come across so far that implements all these three is again SSAS, which is SQL Server Analysis Services. So when you build a cube in SQL Server Analysis Services, you can control these options per cube. You can precisely say, should it be a MOLAP or ROLAP or HOLAP? And within OLAP, you can set the latency. How often should the data be refreshed, and so on. I would highly recommend everyone to try out SSAS. So the next question is, which one is faster, multidimensional OLAP or ROLAP? So if you understand the architecture very well, then the answer is obvious. Since multidimensional OLAP is directly stored in memory and all the data is pre-processed, it is definitely faster than a relational OLAP. Okay, so this again is a trick question. This question can be asked several ways. What are the operations that can be performed by an OLAP cube? There are many operations that can be performed, but the most popular ones are these: roll up, drill down, slice, dice, and a pivot. For some of you already may be familiar with a slice and dice, right? So I'll show you with an example of what exactly that means. The first is a roll up. A roll up a couple of years ago was being referred as drill up. So drill up, drill down was commonly used terms, but then people realized that you can do a drill down into data but not a drill up. Hence, there was a change in how we call drill up. We started calling it as a roll up. So roll up is an operation by which you condense the data, right? You condense the data from many different records to fewer records. Okay, so if you look at this example, you will see that the cube at the bottom of this picture has data organized by two different dimensions. One is the time dimension represented by these quarters, and the other is the city. So if you were to do a roll up and condense the city into country, what you end up is with 2 records instead of 4 records, right? So the number of records that is being displayed has reduced in the cube, and at the same time, the metrics have been added up. They have been summed up. So this is a simple roll-up operation, right? And we also use the term dimension reduction. Okay, so these kind of operations are pretty easy in a cube since there is no query involved and all of the data is stored in memory. A roll-up operation can be done instantaneously in a cube. The next is a drill down, which is the opposite of a roll-up. So if you see here in this slide, we start. Okay, I believe there is a slight issue with the slide. So let me go back to the slide. So a drill down would be doing the reverse, meaning you start with a country, right? And you drill down into the city. So let's say if you're presented with the total sales for today, right? You would want to drill down to see what are my top 5 products and so on. And if you look at the slide, you'll see that the drill down has occurred on the quarter, right? So the quarter is now expanded into the 12 months in a year, right? So you can see the numbers being spread across these 12 months. So this is an example of a drill down. The next is slice, right? And you'll most often hear people talking about slice and dice, especially those who are from a reporting background or data analyst. Let me tell you, slice and dice is just a buzzword. Simply put, slice and dice is an operation of applying filters on the data, right? So let me show that with an example. So if you see here, if you look at the cube at the top, right? Again, we have the data spread across time and the city. Now, if I were to apply a filter on the Q1 slice, right? On the Q1 dimension, just the quarter one, we end up with this small slice as shown in the figure below. So this is an example of a slice. Now a dice takes it one step further. In a dice, we apply a filter by another dimension, right? So here the filters have been applied both at a city level and a quarter level. So we started with the cube that's at the bottom of this picture. We filter on the time dimension by quarter one and quarter two. We also apply a filter on the cities for only Vancouver and Toronto, right? And the end result is a smaller cube. So this is called a slice and dice. So like I said, it's a simple operation of applying filters. Now, the same can be done by writing queries as well. But when you're using a OLAP cube, since you visualize as a cube, you use the word slice and dice instead of saying filters. That's the only difference between slice and dice and a reporting filter. It's just that slice and dice is implemented in a cube, whereas filters or criteria is applied in a query. Next is a pivot operation. Now, a pivot is called by different names. For those of you who are familiar with a spreadsheet, you will know what a pivot is, right? For others who are coming from a pure reporting background, you can think of it as a matrix table that you create in, let's say, business objects, right? So simply put, a pivot table is a data representation across multiple dimensions, right? So you see here, the data is already in a pivot. So on one axis, we have the city, and on the x-axis, we have the phone security types. Now you can switch this, right? You can switch this so that the mobile phone types or the item types in the y-axis and the cities appear in the x-axis, right? So this is called a pivot operation where you change the axis by which the data is presented. Okay, Meena has a question. Where do we use a pivot operation? Very good question indeed. So you use this mostly to save the real estate area on a dashboard. All right. So let's assume you're showing this information as a flattened table. All right. If you're showing the city and the item types as a rows, if you were to display it as flattened rows, then it will occupy close to 8 records in the grid. But if you were to create it as a pivot table, instead of increasing the length of the grid, you are using the width of the grid as well. So that way you save or you make good use of the width of your screen, right? So that's the number one reason of using a pivot table in showing the data. This is a follow-up question on how many dimensions are usually present in a slice and a dice operation. So as I mentioned already, in a slice operation, it's usually one dimension, but in a dice, it is 2 or more dimensions, right? So the filters are applied across 2 or more dimensions to arrive at a dice. And The word dice is, refers to the object that we use when we're playing games, because when you apply a filter across multiple dimensions, that's what a cube looks like. Okay. Another question that's asked is, what is data normalization? What is the benefit of data normalization? So let me tell you this. For a data warehouse, you don't do normalization. We follow the opposite, which is denormalization. But yet, why do we ask it, right? Why should we be concerned about it? The reason is people who are coming from a OLTP background tend to do the mistake of introducing the concepts of OLTP into OLAP, right? Of a transactional system into a data warehouse. So as a data warehouse developer, you need to not only know the patterns, but you need to know the anti-patterns as well, right? What are the things to avoid, right? So one such thing is the normalization. So normalization is this process of splitting up the data into as atomic number of tables as possible, right? And there are several forms of normalization. First normal form, second normal form, and third normal form. There are plenty of resources over the internet which will tell you how exactly these work, but the end goal is that you avoid data redundancy. And why do we avoid data redundancy? We avoid it so that when there are changes to be made, the changes happen to the one table at a time or one row at a time. So an example would be your banking application again. Let's suppose all of the data is stored as one flat table, right? Your address, your contact details, your name, your email address, your transactions, your preferences, everything is stored as one flat table. If there's a change to even one of those attributes, all of the records that have that value will have to be updated. Now, this is a very costly operation for a database. And remember, banking is a critical application which could be used by multiple users simultaneously. So you want to handle the change very quickly and in a very small place as possible, right? In a single table as possible and in a single row as possible. So given this need, you split the data into very atomic values, and you do that by following the process of normal forms. So this method really helps in improving the performance of a OLTP system or a transactional system, but it works against the favor of a data warehouse. Why? Because in a data warehouse, like I mentioned before, we do not make updates. We store only new records. And even if there's a change that has been done in the operation system, that is also stored as a new record. And given this, if we were to normalize the data in a data warehouse as well, following these operations, then you'll see that the performance will be very, very slow. The joins are a very costly operation in a database. You must avoid it as much as possible. So hence, be familiar with the normalization, know what it means, so that you can avoid doing this in the data warehouse. So the question here could be misleading to some of you. What is the benefit of normalization? Yes, there are benefits, but those benefits are limited to the OLTP system, the transactional system, not the data warehouse. In data warehouse, we denormalize the data. Moving on. What is an ER diagram? So ER diagram is a entity relationship diagram. So ER stands for entity relationship, right? And it shows the relationship between the different entities within the business event. So take sales as an example, right? Your customer is an entity, product is an entity, store is an entity, and so on. Each of these entities will have functions such as a store can have an inventory, a store can have a promotion, right? A store will have an opening time, closing time, and so on. So entity relationship shows you how these entities exist, how they interact with one and the other, right? So for example, the customer entity can interact with the store entity, it can interact with the product entity, and so on. So when it comes to data warehousing, we usually don't follow the entity relationship diagram. Entity relationship diagram is again a purpose built for transactional systems, not data warehouses. For data warehouses, we use dimensional modeling. So dimensional modeling is a process by which you collect data for a specific subject area. You don't worry about the entities or relationships. Instead, your focus is on what is the business event that is being measured. So continuing on the same, what is a dimensional modeling? We've already discussed what are dimensions and facts, right? So the design approach that you take to design dimension and a fact table is called a dimensional modeling. And a dimensional modeling you start by selecting a business grain or a business event, right? So for example, sales is a business event, shipping is a business event. You start with the event. Once you have identified the event, then you identify what is the grain of the event, and then you identify what are the dimensions that are in play in that event, and then you end up with your dimension and fact tables. So this is dimensional modeling in a nutshell. And what are the different phases of dimensional modeling? It's also called types. So when you're building a dimensional model, you usually start with a conceptual model, right? A conceptual model is a very abstract diagram that shows what are the different dimensions, what are the different facts. A conceptual model will not have too many details like what are the attributes, what are the primary key, foreign key, data types. None of these details will be there in the conceptual model. It's at a very abstract level. The reason it is kept so abstract is that changes can be easily made to it, right? So business users can validate very early in the design lifecycle if all the dimensions and facts are captured. Once this conceptual model is refined, you move over to the logical model. So the logical model will expand on the conceptual model by adding attributes, right? So we discussed, for example, customer dimension can have attributes such as first name, last name, middle name, age, date of birth, and so on, right? So you add attributes, you also add the primary key, foreign key relationships, and you make sure that the attributes have a business friendly name, because the logical model again will need to go through the review of a business users. They need to validate if all the data that they need is available in the logical model. Once a logical model is refined, then you go ahead to a physical model. So physical modeling will convert your logical model to a set of tables and columns specific to a database. Another thing to note here is that when you build a logical model, it is not specific to a database. It can really be implemented in anything. It can be a database, it can be a OLAP cube, or it can be even a reporting tool. When it comes to the physical model, a physical model is specific to a database. So since a physical model has the data types, right, it has to be specific to, let's say, SQL Server or Oracle or Teradata, MySQL, or even SSAS cubes, right? So as you progressively move from a conceptual model to a logical model to a physical model, making changes to it get more and more difficult. So it's very difficult to make changes in a physical model, difficult in terms of the time it takes, whereas it's much easier to make changes to a conceptual model or a logical model. This is where tools like Erwin, Power Designer, they come into play. These data modeling tools help you convert automatically from a logical model to a physical model given a database. You simply need to select the target database type, and these tools will convert the logical model to a physical tables and columns based on some rules. Another thing to note here is that in the logical model, we refer the tables as entities and attributes, right? We refer to them as entities and attributes, but the same entities and attributes, when moved to the physical model, they are referred as tables and columns. This is something to be aware of. And the process of converting a logical model to a physical model is called forward engineering. Okay. Another important topic, slowly changing dimension, right? So the SCD stands for slowly changing dimension. Now, think of an example of a product, right? Assume that the product is being sold, right? And you have an existing data warehouse for it, right? So product will be stored in a product dimension and all the sales are being captured in a fact table. Now, after some time, you decide to change the name of a product, right? Based on customer feedback. So you do some survey and you find that customers find the product name not so fancy, right? They don't find it attractive, or there's something about the name that's keeping them away from buying it, right? So you decide to change the name of the product. So when you change the name of the product, you are doing that in the transactional system, right? You have a product inventory where you go ahead and update the name. While you update the name, the ID itself, the unique number attached to the product, that won't change. That still remains the same. Once you make this change, this data will flow into the data warehouse as well. So in the product dimension, you need to capture this change. How do you do that? You usually do that by inserting a new record with the same product ID, but the new product name, and also recording the time at which the record came in. So how is this helpful? When you join the dimension table, the product dimension table with the sales fact table, you can see how were the sales before the change in the name and how are the sales after the change in the name. So the ability to store history in the dimensions lets you do analysis and check the performance, right? Do the business measurement before and after an event, right? So this is an example of why we need to capture any changes in the dimension, and it is achieved through this technique called slowly changing dimension. Now, slowly changing dimension again are several types. We have SCD 1, 2, and 3. In SCD 1, if there is a change in the source system, we simply insert or we simply overwrite the value in the data warehouse. So in the example that I gave, if the product name were to change, we will not keep the historical name in our table. We simply overwrite that same record with the new product name. So depending on the requirement, if the business says that we really don't need to keep the history, we can take this approach of SCD1. SCD2 is where you insert a new record, but you keep a timestamp on when the new record came in. Then SCD3. So SCD3 is where instead of adding new records, you add a new column and you move the historical data over there. So you have something like old product name and new product name as two columns in the product dimension table. And of these, there is another type as well, which is SCD type 0. That's something that may come up. So in SCD type 0, there is no action taken, meaning even if there's a change in the transactional system, we really don't update the data in the data warehouse. So that is SCD type 0. For even a detailed explanation, please look at the Wikipedia page for slowly changing dimension. There are plenty of examples that can be easily understood. Okay, Pawan has a question. Do we set up SCD at the dimension level? Okay, that's a very good question. So Pawan's question is, do we define every dimension table as one of these types? Well, you can do that depending on the business requirement. However, the tools these days, the ETL tools, support handling SCD differently for different columns within the same dimension. So to give you an example, let's assume there is a data warehouse for a school, right? And the data warehouse is collecting data from admissions, right? Grades and so on. So you can use any ETL tool like Informatica or Talent, and you will apply a SCD rule, and this SCD rule can be specific to each column. So for example, it's quite frequent that students, when they're enrolling for the very first time, there is some typo in the names, right? So the first name or the last name may be slightly off, or the initials may be slightly off. In that case, you can set the first name and the last name of the student dimension as a SCD1, which is the moment there is a change in the transactional system, you overwrite the data in the data warehouse, right? There can be other changes such as the contact details or the address. That is something you would want to keep it as SCD2. So you can track that, earlier the students were at this location, now the student has moved to a different location, right? So you can set the address field to be SCD2, right? SCD3, you can store it for, let's say, the contact details, right? What was the previous phone number and what's the new phone number, right? Or what was the previous house the student belonged to and what is the new house, right? So that's something you can do. And let's say gender. Gender is something that you can set as SCD type 0. So if the source system changes the value for the gender for a student, you probably know it's happened because of a mistake, and you don't want to reflect that in the data warehouse. So for such attributes, you can set it as SCD type 0. All right, moving on. What are the key columns in fact and dimension tables, right? So the term key column refers to any column or a set of columns that uniquely identify the records, right? Or in the context of a data warehouse, it's primary key or foreign key. So if you look at this example here, we have a department dimension in which department ID is the primary key, right? And department name is just the description. And we have an employee table, right? Where we have the ID is the primary key, and then we have department ID as a foreign key relationship, right? So these are considered key attributes, right? So any primary key, foreign key are considered key attributes. They help you join these two tables. So similarly, a dimension and a fact table will have foreign key relationship to primary keys in the dimension table. Okay. The other question is, what are the different schemas that are implemented in a data warehouse, right? So I'm sure all of you are aware of star schema, a snowflake, and a fact constellation. So for some of you, the words snowflake and fact constellation may be quite overwhelming and quite new, but let me tell you, it's not very different from a star schema. It's all about the number of tables that you're looking at or you're analyzing at any given time, right? So let's start with star schema and explain what it is. So a star schema is a diagram, right? I repeat, star schema is a visual representation of the tables for a specific subject area, right? So for example, here, this is a star schema for sales, right? At the heart of this diagram is the fact table surrounded by one level of dimension tables. I'm using the word one level because there is no other dimension table that require more than one hop to the fact table. Or in other words, all the dimension tables can connect to the fact table with just a single join, right? So this kind of a setup is called a star schema. So one misconception is that the databases should be a star schema. The moment you add another table to it, it's not a star schema and so on. The truth is that star schema is something that you share with the business users so they can understand the business model easily. So for example, if somebody were to ask you from the business side on what are the tables that I need from the data warehouse to measure the sales activity, right? So in response to it, you would share a diagram with them with these 5 tables. So for someone who looks at it, it's easily understood that, okay, there is a dealer dimension, a branch, a product, and a date, all connected to the sales fact table, right? So this is an example of a star schema. Snowflake schema expands on a star schema. So you see here, we still have the 5 original tables as per the previous slide. We have 3 additional tables, right? So how do you identify a snowflake? If you have dimensions that require more than one join or that join to one dimension table and then to a fact table, then this diagram is called a snowflake schema. We call it a snowflake because it is having multiple branches away from the fact table, right? And for a business user, this is quite a lot of information to process, right? So they need to understand how to join these 2 dimension tables to arrive at a fact table. They need to make sure they use the correct join conditions. Also, the performance will be a little slow because we have more joins now in a snowflake schema. Again, snowflake is a visual representation. There could be many more tables in the database, but when in response to a business user saying, give me all the tables for sales event, you would share a diagram that looks something like this. And you would add the additional tables as well because all these tables are related to the sales event. Moving on is a galaxy schema, or also called as a fact constellation schema, right? In most projects, this is how the tables are going to be, right? You have fact tables for multiple business events. So here you have a fact table for products and their variants, and here you have a table for sales. You see how the dimensions are being shared, right? The product dimension is associated with this fact table. The branch and date are associated with both the fact tables and so on. The dimensions that are at the center of this diagram, the branch and the date, are examples of conformed dimensions. So probably we started by building a data warehouse for the sales, right? And then we eventually added a fact table for the product and their variants as well, right? So this is an example of a galaxy schema. In most cases, all your data warehouse will look something like this, right? But it's up to you on how do you categorize them, right? So when the user says, which table should I access for looking at the sales, then you must share a diagram like this or the list of tables like this. Or if the business user asks, how do I do analysis across sales and product variants? In which case you will share a diagram that looks like this, right? So as you see, star schema, snowflake, and fact constellation are not very different. It is just how you represent the tables to the end users. How do you present it to them? In reality, all the tables may be stored in the same database. Moving on. The next question is, what is real-time data warehousing, right? So real-time, as the name suggests, real-time is the capability by which you view something as it happens. So an example is a bank transaction, right? When you make a bank transaction, you see that on your statement immediately. When I say statement, the list of transactions. So let's say you withdraw some money, right, from the ATM, you get a message on your mobile. And at the same time, if you were to log in to your net banking application, you will see the transaction showing up there. That is real time, right? Something that happens immediately. So how does it apply to a data warehousing, right? So far, we have learned that data warehousing is the process by which you collect data from source systems, all right? And the data flows into the data warehouse. Most cases, there is some latency with which the data moves, right? But in some extreme cases, they want to look at the data as it happens, right? So it can be enabled. However, it demands a completely different architecture, right? You need to look at your source system almost every second, every minute. The moment a transaction is created, you quickly move the data to the data warehouse. So although it takes a separate, set of architectures and very demanding, it can be achieved. And using the word real time could be slightly problematic. Instead, we could use the word near real time. Okay, because the process of moving the data right from the source, transforming it into a dimension and fact, loading it, and that appearing in a report will usually at least take a couple of minutes. Hence, it's also okay to use the word near real time data warehousing. And this is where we use some advanced tools such as data streaming tools, Apache Kafka, and there are other frameworks that support reading data as it happens through database logs and transferring them to a data warehouse or even a big data platform such as Hadoop. Finally, the other question that's asked is, which language is used for defining a schema in a OLAP or data mining? So for data mining, we use something called as a data mining query language, right? So this is a language that is used for defining schema on which the data mining algorithms run, right? So this is very different from your SQL, and it's also different from MDX queries, which you write on OLAP.
We just covered data warehouse interview questions. Our final topic is BI analyst interview questions and answers, where you will learn how to answer typical questions for BI analyst role to boost your interview readiness.
First, let's have a look at the general questions that you may be asked. For example, you may be asked about your experience in business intelligence. Here, you should talk about your educational specialization if it is related to BI, your expertise in it, your career experience with it, and if so, you mention the field of business intelligence in which you specialize. Then describe briefly your career journey. Also remember to show a keen interest in the company's business sphere. Then you may be asked about your opinion on agile software development for BI projects. Firstly, you should define agile. Agile software development refers to the software development methodologies that involve iterative development, where requirements and solutions evolve through collaboration between self-organizing cross-functional teams. It advocates adaptive planning, evolutionary development, early delivery, and continual improvement. The benefits of Agile are that it is more collaborative, saves on time, and since the teams directly work with the client, it provides a clear outcome in an incremental way. So it is being preferred these days. But many companies still prefer using waterfall methodology, especially for projects with concrete timelines and well-defined deliverables. If you have worked in Agile, talk about your experience. Then you may be asked about your experience in SDLC. SDLC refers to Software Development Lifecycle. You should define SDLC. Software Development Lifecycle is the process used by the software industry to design, develop, and test high-quality software. It consists of a detailed plan describing how to develop, maintain, replace, and alter or enhance your specific software. You should talk about your experience in SDLC. If you don't have experience in it, you can talk about your interest in working more with it. Now, let's have a look at some examples of technical questions that you may be asked. The first, you may be asked to define business intelligence. Business intelligence is the field that aims to extract meaningful and useful insights from data. BI analysts analyze data sets and represent their insights in the form of reports, graphs, maps, summaries, cards, and other such formats. They help make strategic and tactical business decisions. Next, you may be asked about uses of business intelligence. The uses of business intelligence include that it helps improve decision making by gathering insights. It helps in studying market trends. It helps spot weak points in business operations, and it helps improve the internal efficiency of organizations. Next question, what is data flow? Data flow consists of the sources from where we extract the data and the destination where we load the data. It consists of transformations that modify and extend the data and the paths that link sources, transformations, and destinations. The three important categories in data flow are data sources, transformations, and destinations. Next question, what is control flow? A control flow consists of the tasks and containers that execute when the package runs. To control order or define the conditions for running the next task or container in the package control flow, we use precedent constraints which connect the task and the containers in a package. SQL Server Integration Services provide three different types of control flow elements, which include containers that provide structures and packages, tasks that provide functionality, and precedence constraints that connect the executable containers and tasks into an ordered control flow. What is OLAP? OLAP is an online analytical processing. It is a computing method that enables users to easily and selectively extract and query data in order to analyze it from different points of view. OLAP business intelligence queries often aid in trends analysis, financial reporting, sales forecasting, budgeting, and other planning purposes. Next, you may be asked to differentiate between OLAP and ETL tools. ETL can extract, transform using various transformations that are available in the tool and aggregate the data. The output can be used as an input for the OLAP tool. ETL is the initial part of data warehouse. While OLAP supports online reports after performing certain join operations and creating some queues. OLAP consists of various applications for scorecarding, reporting, dashboards, consolidation, planning, analysis, master data management, workspace, and foundation. You may be asked about the tools used in MSBI. There are three tools, SSIS or SQL Server Integration Services. It is useful for integrating the data coming from different data sources in a data warehouse. The number of data sources together contribute form data. SSIS is generally responsible for bulk transactions. SSAS or SQL Server Analysis Services, which is an online analytical processing tool, online analytical processing, data mining, and reporting tool used in business intelligence. While SSRS stands for SQL Server Reporting Service. Once the data is in its final state, SSRS provides the tools necessary to create reports to better understand the data. Next, what is a workflow in SSIS? A workflow is a set of instructions tell the program executor how to execute tasks and containers within SSIS packages. Next, what is the difference between where and having clause in SQL Server? Now, there can be three differences. First, having clause can be used with group by clause, while where clause is used with constructs like select, update, delete, etc. The having clause is applied as a filter after the group by clause, whereas in where clause is applied to every row in the select, update, delete, etc. construct. When both having and where clauses are used, having clause is applied after where clause to further filter the output of the where clause, while the where clause is applied before the having clause to every row in the select statement. Next, what is the difference between view and materialized view? First is the definition. A view displays a query's output as a table, while a materialized view are schema objects which can be used to summarize, pre-compute, replicate, and distribute data. Example, to construct a data warehouse. Then, all operations performed on a view will affect data in the base table and so are subject to integrity constraints and triggers of the base table, while in materialized view provides indirect access to the data table by storing the results of a query in a separate schema object. A view can be used to simplify SQL statements for the user or to isolate an application from any future change to the base table definition. A view can also be used to improve security by restricting access to a predetermined set of rows or columns. One view can be based on another. A view can also join a view with a table. While materialized views, when used for query rewrite, improve the performance of SQL execution. Next, what are the differences between truncate and delete clauses in SQL Server? Firstly, truncate is a DDL, that is data definition language command, while delete is a DML, that is data manipulation language command. Truncate removes all the records from a table without making a log entry for individual row deletion, while delete removes all or selected records from a table by making a log entry for individual row deletion. Truncate is faster, while delete is slower. Truncate removes all the records from a table, and a where clause or filter condition cannot be used. While in case of delete, it can remove selected records or all records based on whether where clause, which is optional, is used or not respectively. Truncate cannot be used on a table if it is referenced by one or more foreign key constraints or it is marked enabled for replication, while delete can be used in these conditions. Finally, truncate resets identity in any of the columns in a table, while delete does not reset the identity in any of the columns in a table. Next, we have the intermediate level question. First, name the components of SSAS. Now, SSAS has 5 components. First is the OLAP engine. It is used to provide fast ad hoc queries by users. Then drilling, which is the process of exploring details of the data. Pivoting is the process of switching categories of data between rows and columns. Slicing is the process of placing data in rows and columns. And the fifth component, which is dimensional database, are used in OLAP. Next, you may be asked to describe the SSAS architecture. The architectural view of SQL Server analysis services is based on a 3-tier architecture, which consists of first the RDBMS. The data from different sources like Excel, database, text and others can be pulled with the help of ETL tools into the RDBMS. Second, SSAS, which aggregate data from RDBMS is pushed into SSAS cubes by using analysis service projects. The SSAS will create an analysis database, and once the analysis database is ready, it can be used for many purposes. Third, clients. Clients can access data using dashboards, scorecards, portals, etc. Coming to the next question, describe errors in SSIS. Errors generally occur due to unexpected data values when a data flow component applies the transformation to column data, extracts data from sources, or loads data into destination. Types of errors are: they occur when the connection manager cannot be initialize the connection string in case of data sources, data destinations, and control flows that use the connection string. Data transformation errors occur while data is being transformed over a data pipeline from source to destination, while expression evaluation errors occur if expressions that are evaluated at runtime perform invalid. What languages are used in SSAS? The languages used in SSAS are SQL, which is structured query language. SQL lets you access and manipulate databases. Next is MBX, which is multi-dimensional expression. It is a query language for online analytical processing using database management systems. Like SQL, it is a query language for OLAP queries. It is also a calculation language with syntax similar to spreadsheet formulas. Next, DMX or data mining extensions is a language that you can use to create and work with data mining models in SSAS. You can use DMX to create the structure of new data mining models, to train these models, and to browse, manage, and predict against them. Next, we have the Analysis Services Scripting Language, ASSL, which is an extension to XML that adds an object definition language and command language for creating and managing analysis services structures directly on the server. You can use ASSL in custom applications to communicate with analysis services over the XML protocol. Next, what is write-back? Write-back is the ability to update source systems such as databases, to maintain systems of records while staying within the context of a BI application. This is essential to the concept of embedded BI. A good BI application will enable these data updates in a secure and managed way. Next, name the business analysis enhancements available for SSAS. The business analysis enhancements that are available in Microsoft SQL Server analysis services are time intelligence, account intelligence, dimension intelligence, custom aggregation, semi-additive behavior, custom member formula, custom sorting and uniqueness settings, and dimension write-back. You may also be asked to write an SQL query. Let's take an example. To write an SQL query to extract first tuple from a cell. The SQL query for this will be select date dot calendar year dot members dot item 0 on 0 from AdventureWorks. Here AdventureWorks is the database. It will give the output of the first tuple from the set, as you can see. Next, what is a ragged hierarchy? Now, under normal circumstances, each level in a hierarchy in Microsoft SQL Server Analysis Services, that is SSAS, has the same number of members above it as any other member at the same level. In a ragged hierarchy, the logical parent member of at least one member is not in level immediately above the member. When this occurs, the hierarchy descends to different levels for different drill down paths. Expanding through every level for every drill down path is then unnecessarily complicated. Now let us come to the advanced level question. Firstly, what is the difference between DTS and SSIS? DTS stands for Data Transformation Services, while SSIS stands for SQL Server Integration Services. In DTS, there is limited error handling, while SSIS provides more complex error handling. The messages in DTS, the message boxes use ActiveX script, while in SSIS, the message boxes use .NET scripting. In DTS, there is no deployment wizard, while in SSIS, we are provided with an interactive deployment wizard. In DTS, there are limited transformations, while in SSIS, there are more transformations. Finally, in DTS, there is no BI functionality, while in SSIS, there is complete integration with BI. Which lookup cache modes are available in SSIS? Now, there are three lookup cache modes in SSIS. The first is the full cache mode, which is the default cache mode. Full cache mode will cause the lookup transformation to retrieve and store in SSIS cache the entire set of data from the specified lookup location. As a result, the data flow in which the lookup transformation resides will not start processing any data buffered until all of the rows from the lookup query have been cached in SSIS. Next, we have the partial cache mode. When using this, lookup values will be cached, but only as each distinct value is encountered in the data flow. Initially, each distinct value will be retrieved individually from the specified source and then cached. To be clear, this is a row-by-row lookup for each distinct key value. Next, the no cache mode will not add any values to the lookup cache in SSIS. As a result, every single row in the pipeline data set will require a query against the lookup source. Since no data is cached, it is possible to save a small amount of overhead in SSIS memory in cases where key values are not reused. No cache mode is not used much, but it may be used in the following cases. When the reference data is too large to reasonably be loaded into SSIS memory, the pipeline dataset is small and is not expected to grow, there are expected to be very few or no duplicates of the key values in the pipeline dataset. How to log SSIS execution? SSIS includes logging features that write log entries when runtime events occur. They can also write custom messages, although it is not enabled by default. Integration Services supports a diverse set of log providers, giving you the ability to create custom log providers. The Integration Services log providers can write log entries to text files, SQL Server Profiler, SQL Server, Windows Event Log, or XML files. Logs are associated with packages and are configured at the package level. Each task or container in a package can log information to any package log. The tasks and containers in a package can be enabled for logging even if the package itself is not. How do you deploy SSIS packages? Now there are two ways in which the SSIS packages can be deployed. The first way is that the SSIS project build provides a deployment manifest file. After running this file, you can deploy it to either the file system or the SQL server. The second method is to import the package from SSMS from file system or SQL server. Next, to create a calculated member that intersects all measures, where do you put it and why? Now, in MDX, you can create a calculated member, which is a member based on other members. You can create two different kinds of calculated members, ones that are measures and ones that are not. Remember that a measure is considered to be a member of the measure's dimension. To create a calculated member that intersects all measures, you would put it in a dimension other than measures, because a member in a dimension cannot intersect its own relatives in that dimension. Next, what is the use of property called non-empty behavior while creating a new member in a cube? Non-empty behavior is used for ratio calculation. An MDX expression will return an error if the denominator is empty, just as it would if the denominator were equal to 0. By selecting one or more measures for the non-empty behavior property, we're establishing the requirement that each selected measure first be evaluated before the calculated expression is evaluated. If each selected measure is empty, then the expression is also treated as empty and no error is returned. How are cubes implemented in SSAL? As multi-dimensional cube or hypercube is a data structure in SQL Server Analysis Services, that is SSAL, which is built using OLA-basis databases to allow near instantaneous analysis of data. The useful feature of an OLAP cube is that the data in the cube can be in an aggregated form. SSAS cubes are created in a step-by-step process using the cube wizard. This brings us to the end of today's session. I hope now you have a better understanding of business intelligence analysis and the interview questions that you may be asked.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!